Hi! The was actually appropriate because I wrote and then forgot to clear the test message at the beginning. Hi! Welcome! Cabbage! Oh my goodness, hi! Oh god, the hand's messing up already. What is the hand doing?
Balls. TXXT TXT.
Oh no, the two exclamation marks messed it up. Thank you very much for the resub, Cabbage! And GD as well! Thank you for the flipping sub! Resub! Hi! Welcome both of you and everyone! Hi! Hi! Why does my volume sound a bit weird? Oh, hang on a second, it's because my mic's already facing me. That'll do it! Why does my mic sound so weird? Oh yeah, now it sounds better. Hi! Welcome! How are you doing? Welcome, Fernanda Bannon, and welcome, Mr. Spoons as well. Hi, how are you? Welcome, welcome. Stu as well, hi. Fi, welcome. Hi, Fi, dare I say. Karam, hi. And Jeed, of course. Roshi, Yamano. Dear Lord Yuki, that stream title. Thank you. I was kind of proud of this one. I'm not proud of the fact that VZ Face thinks I'm making a resting bitch face all the time. What is going on here? Hold on, let me make a super big frown. Okay. Okay, nice. Now it understands just how frowny I can get. It doesn't think I'm frowning all the time. Hi, Woody. Welcome, welcome. And Cabbage, welcome, welcome. And Fanana, and yes, okay, that's everybody. Hi. Welcome, welcome. How are you all doing? Meowdy-doo. Meowdy-doo. Nigh long and prosperma as well. Yes, indeed, Cabbage. I hope you nigh very long and prosperma as well. It is Uke time. It is. Unfortunately, it's. What is his hand doing? It actually looks like it's going, flicking my head like that. Why is it doing that? Why do that? Yeah. Hi, welcome. Unfortunately, it's also time for many other people. I was just chilling in Myriad Minds' stream.
Cheese.
And Myriad was just saying why though? Why cheese? Myriad was actually not saying why cheese. So it's me who's saying that. Anyway, we're all just saying how seems to be a day where literally everybody cool streams plus me plus where's my hand? Plus me, there. Sonic and Knuckles.
Cheese.
Hi, welcome, Blap. How are you doing, Kissel? What does that actually mean? What does that actually mean? I don't speak, wait, what's the stereotypical thing? Empanada? I don't know. Anyway, because, I still have a bunch of friends, who refer to their language as the stereotypical food of their language. Or not even a food, but like a windmill for Dutch and baguette for French, and it's fine for them to say it. Anyway, hi, welcome. Damn, you hear Kessel like every stream. Do I? Oh, cheese. I hear cheese every stream. It's true. Hate to say hi and bye-bye. Gotta go pay off that 100 subs. I'm so sorry, Yama. Thank you so much again. Bye. Good luck. I really hope you are taking sufficient care of yourself as well. Before throwing it at the weird cat on the internet. However, I hugely appreciate it, and it is hugely, helpful. Kessel is cheese, and someone's got one of the voice lines recorded in insert language here. I don't remember hearing Kessel. Why is that hand doing? Okay, hold on. I'm gonna restart. Why is it touching my ear like that specifically? One sec. I'm gonna restart the thingy and see if that fixes it. Actually, no, I'm not. That's stupid. It'll just be like this for today. I'm tired of restarting my setup. Am I?
Crazy or from times to says Kessel. I have no memory of that. Hey!
Käse!
Stop! Käse is cheese in German. Is that what you mean? That's Käse. That's German.
Käse!
That's Käse! That's... Yeah, there is another Käse sound, yes. It's, Owly. Owly also would have said Käse in German.
Cheese.
I never realized.
Lactose-filled dairy product.
That Kessa and Keza actually sound a little bit similar.
Cheese.
By the way, the cheese is back to its usual price.
Formaggio.
And you can only
throw 25 slices at me, as if that's not fucking way too much already. Hi. It's beginning.
Formaggio.
Why? Hi, Lexi. Welcome. I see now what you meant though. I see now why you thought that it was Kestel. Hey, if somebody wants to donate a Spanish sound, Mint, I'm talking to you, even though she's not here right now. That'd be nice. New cheese sounds are always welcome. Willie's one had Owl play it. Pretty Little Owlie? Owlie's one is Keza. Because she lives in Germany, although she's actually Greek. Anyway, it was EL Spanish. Wait, what? EL is Spanish? ES is Spanish, right? EL is Greek, isn't it? I'm being flipping gaslit here, what's going on? Yeah, Greek is EL. If you want something from Mint, I can tell her. Oh, no, Willie, no, you don't have to. Shit, I forgot Willie pulls strings for Mint. Oh no. Now she's gonna be like, the fuck does that weird cat want me to record cheese for? What a ridiculous thing. I'm gonna continue doing my pro blender modeling now. I don't think she'd actually say that, but she does make amazing models. I can't remember the word for cheese in Welsh. I don't know that either. Don't worry, Bleb. There's similarities and stuff. I'm not sure how many similarities there are between Greek and Spanish, but I mean, probably more than 0. Oh! Wait, how do you... Wait, hang on, it's a phonetic language, isn't it? So does that mean it's like cows? Cows? Or cows? I actually don't know. Oh, wait. It'd be rather than zzz, wouldn't it? Because it's phonetic, right? So it'd be cows? It comes from cows. So you just called it cows, amazing. Oh, wait, it's a Z. Okay, so zzz sound on the end, sorry, is what I mean. So hello, welcome everybody. Right as I start gesturing, frame rate drops, amazing. Hey, last night, I had a realization. I was looking around on, Spanish comes from Latin, so it makes sense. I guess, does Greek come from Latin? I thought they were different roots. I don't know. Anyway, last night, it's okay. So the broken, in other words, because I designed it wrongly, the never working MIDI LED board, circuit board, the thing that would look a little something like this. However, I've made a subtle change. See if you can see what it is within this 5 seconds. 4, 3, 2, 1. Pew. That board, it's been on my mind a lot. Because I know how to fix it now, but fixing it we would work, but I need to pay a lot for it to be remade. I mean, I need to pay a whole bunch anyway. But particularly the component I was using to control a bunch of 16 LEDs is a lot. Greek and Latin come from the same base. That's interesting. Huh. Latin words are all over the world. It's true. Latin words are all over the world. That's not what you said, but it's what I said. Yeah. What if I told you... Oh yeah, and the big problem is that the red LEDs are stupidly bright and the green ones are stupidly dim. And it's just how they are with the same current. And that's how it is in the datasheet as well. And there aren't really alternatives that are affordable and stuff anyway. And I've got crap loads of these LEDs now, so I'd rather like to use them. The green ones are bright enough to be seen as indicators. They come with the same base. Sounds like a nightmarish code base. I thought it was gonna be a
Beast.
joke. Alright, let me give the pats. Pat, pat. Patsville, let's go. Welcome, welcome. Hi. So what if I told you the buttery... Oh yeah, yes. The buttery biscuit base. Someone else, or was it you possibly, made a reference to the buttery biscuit base the other day and it made me laugh. I don't know why the buttery biscuit base is suddenly making a comeback. But it needs more oomph. Hold on, let me give him more pats. Hi Al as well. Did I ever say hi to Al? I should have, because I thought I saw Al earlier. Hi Al. Hi Alika. Pat, pat. I managed to catch a stream for a while, so it was someone else. How, that's crazy. Wait, what? How did she say it?
Queso.
Queso. Thank you very much, really. Thank you, thank you. 3 flipping months as well. Hi. How's everyone? 3. What is going on? What is happening? Banana! Oh my goodness, thank you as well. Sheesh. Welcome, welcome. Hi. Welcome is... Okay, this hand... I've not changed how this hand is meant to pat my head. It's behaving so weirdly. Maybe when I move down to or forward to a sensible position again, like this. Oh no, that's up and down. Like, wait, I already am in the right position forward and backwards. Okay, there's no excuse for it to be failing then, whatever. Anyway. It'll fix, but it's not. Scam train incoming. It is! Apparently.
Prospectman. Thin shit.
Yes. I think is correct. Yeah. You got me stuck for a second there trying to pronounce it. So here's the thing. What if I told you that for about a quarter of the price of the components that I was using before to drive the LEDs, as in like a quarter in total, not just per component, and however many I'd need. Thank you for the follow, Silver. Welcome, welcome. Oh my god.
Imitate scam train.
No! Ow! Ow! Help! Thank you, Blep. That's very kind of you. You have successfully initiated the Skype train, the scam train. What the fuck? That was a mix of scam and hype. I just said Skype. Wait! So is Skype just a scam hype? It don't make sense. Nah, I used to like Skype, and then it got bought by Microsoft. Anyway, 68%, 1% away from being really nice. Holy. So what if I told you that for a quarter of the price of the component I was using before, the shift register, I can use something that gives me per LED brightness control. This is not just like a normal LED matrix driver that can like control loads of LEDs. Thank you for the follow, Duraz. Now, welcome. What if I told you that you can get per LED brightness control 256 different levels, including full on and off, and it costs like a quarter of the price, and it would make the boards more easy to control without cheese. Yeah, exactly. You wouldn't need any cheese. You wouldn't need the logic to address stuff either. What is the silver bullet component you're talking about? Well.
Cheese.
If you'd stop cheesing me for one moment, I could tell you. Hi, kids. Welcome. The Microsoft Classic. Embrace, extend, exceptionally shite. The 3 E's, you know them. Microsoft moved to Discord from Skype in 2018 or something. 2016. 2016 is when I did as well. I remember it was near the end of 2016, though, but yeah. That is pretty cheesy, right? Why are you pointing to the E? Oh, right! The triple E, yeah! E, exactly. Maysucker's got the perfect emote for that. Okay. Well, you might... Actually, like, some people might legitimately be familiar with this component and not even realize it. Because if you have an RGB LED string, there's a fairly good chance it might have this chip inside it. Like embedded sort of into each LED, or if it's one where you can address every 3 chips, then it would be sorry, if it's one where you can change the color of every 3 chips, then there'll be 3 LEDs and then the chip and then blah blah. Because turns out you can get the WS2811 which is a little chip that's meant to drive an RGB LED by itself. It doesn't have to be as part of an LED string. You can just get the chip in a few different sizes as well. And yeah, this is just an LED driver that drives 3 LEDs. Like, you know, it's designed so that it can be the red and the green and the blue channels of the same in the same package. But like the driver doesn't give a shit whether the 3 LEDs are next to each other or like on opposite sides of the board. It's just providing 3 regulated outputs with pulse width modulation. I was about to ask if it was the WS28s. Yeah. So I could just, and these things, they just take in, they take in like some pulses of data, and then they output a fresh version of that data for the next chip along the line. And it's just like, well, it is shift registers basically. It's like a 24-bit shift register actually, because you have 8 bits for red and 8 bits for green and 8 bits for blue. To update the value of a string, you send the whole string. True. So this is the very beginning of, thank you for the weird upward patterns, Lexi. I mean, it's not your fault that they're weird. I know you tried, but my thingy is slapping me upside the head right now. I don't know why. I'm preparing stuff that I had ready, and then stop being ready. There we are. Wait, is this the right one? Oh, it is. Wait, where's the English version of the datasheet? Did I only save the... What the fuck is wrong with me? Why did I only save the... Hold on. I only saved the flipping Chinese version of this datasheet. Which is fine, because there's actually a typo in the English version. But maybe it's still in the recently accessed temporary files in the... Nope. Well, fuck. Yeah, don't worry, Fernanda. Don't worry. This is the very beginning of a train of thought that I've got ideas for this. Bear with me a moment. I thought I had stuff ready to show. This conversation is going to be on hold until you get yourself sorted. Sorted. I gotta sort myself out. Hold on. We'll do it eventually, I promise. It's the same goddamn datasheet. Where's the flipping one that was in English? Was it this one? Which package is this? I think it's this one. What the fuck? I just crashed my PDF here. There it is. That's the one. Okay, let me just quickly save this. Hold on. We're almost done. We can begin in a second. This is what people subscribe for.
Sir.
This absolute top quality content. I swear to God, the stream's gonna begin in a sec. I deserve this cheese right now. Hi, Forwardie. Welcome. How are you doing? Ah. All right, now we can go. Well, I typed hash as part of the file name, so that's not what we want. Anyway, all right, here we go. Pressing the button. Oh no, wait. Actually, it's still scary to press the button. Hold on. Okay, now it's safe to press the button. Boop. Where's the datasheet gone? Here it is. So, yeah. So here's the thing. There are going to be around 2,000 LEDs on this board, and I realize that now that I'm not going to be caring about like trying to bunch up. Thank you for the hydration. Oh my god, I haven't even done the first one yet. Shit, I'm so behind. I'm sorry. Okay, I'm going to hydrate twice. I'm supposed to check twice. I have already saved the kidney, so that's alright. I also refunded you. Okay, next one. I didn't deserve those pats, but thank you, Stu. Now it's stretching the other direction, I guess. Oh my god. There you go, that one got a crack. There you go. That was a bit weird, actually. That one sounded a little bit just like nan. Not a number. Okay, there we are. Stuff is ready now. Okay, so the original LED board had 2080 LEDs. And the original LED board, I can actually get up the original drawing, not modified. My audio's just died. Amazing. Okay, my audio's back. This is not a drawing. That's a schematic. Where's my drawing? Here it is. Yeah, sorry. When your audio died, you went robot. Yep, I hear it as well. It's fine now, but that was amusing. I can't even make it happen on demand. It's just sometimes. My computer's not even power saving mode right now. So here we go. So originally the board was going to have 2080 LEDs, and they're going to be something like this. And if you count this and multiply by 4, it's going to be less than 2080 because originally I was only planning on having 4 of these special LEDs at the end, but now I'm going to have 1, 2, 3, 4, 5, 6, 7, 8. And in fact, that's what got made already. The board got made with that many. So yeah. The prototype board, which doesn't work because I made 2 mistakes, one of which is kind of insurmountable. Anyway, and when I made this, I was sort of making it with the shift registers that can control 16 LEDs in mind. That's why I made all of these one. So by the way, this is a column of 4 LEDs. So there's one here, one here, one here, and one here. So all of these are 4 LEDs high. That's why I was making all of these little bar graphs 4 high, because, you know, if you have a 16-bit shift register, then you can store 4 columns of 4 LEDs. That's 16. And then the 7 segments work kind of nicely like that as well, because it's just, you'll just be wasting 1 output or able to use it for like one of these. Or am I drawing the exact same color? Anyway, hi Usimtas. Are you an electrical engineer? I'm not an electronic engineer either. I am nothing. I'm a streamer. I've never had a programming or electronics related job. It's always been a hobby. But yeah. But now that if I'm going to be using the WS2811, which can drive 3 LEDs, let's have a better look at the datasheet. Let's scroll down a bit. Look, blah 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 blah. So essentially, it's like this. I love highly compressed JPEGs in the PDF file. So you've got the input voltage, data comes in, data gets cleaned up, and data comes out again to be changed to the next chip. And you've got ground, and you've got these 3 outputs, which are called out G and out B, because, you know, it's intended for red, green, and blue, but it's the same, you know? It doesn't really care. R, G, and B, they have the same current output as well, so yeah. You can connect whatever LEDs you want. And this way I could just turn on the red ones to be like very, very dim and the green ones to full brightness whenever, you know, whenever they should be on. And just match it in software and not need to redesign the board at all. Just have full... I could even make like a dimming function. I could even like choose a display brightness if I wanted to as part of the software rather than just hard-code it. Thank you. Thank you, you seem... Just a nerd cat. It's true. It's true. Why do I have an empty logo area? I still have no logo for electronics, do I? Let's hide the logo area then. Get out of here. Yeah, so, but if I'm driving it with the WS2811, which has 3 outputs, then I'm just going to be chaining and chaining and chaining and chaining and chaining anyway, and not really caring, you know. I can't just magically get 7 segments to line up neatly with multiples of 3 outputs. So whatever, I'm not even going to care about making it neat like this. And here's the thing, whenever I want to update a single LED, I'm going to need to address every LED in the string. And for this reason, the slight spoiler about what I plan to do, but the strings are going to be broken up. It's not going to be one enormous string of like 2080 LEDs snaking across like this and 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 this. So, but I will probably need to at least update a bunch at once. And why was I saying that again? Oh yeah, right, because then it doesn't really matter. You know, before I wanted to just be able to address a specific section, say this LED or this section here, and change this LED to be on and this LED to be off and that off. And I could have just addressed this one shift register. But if I'm using WS3811, which is cheaper and that gives me parity brightness control, which is super nice, then I'm gonna have to update everything anyway. So who cares about neatly dividing them? And in that case, I could maybe even go for 5 columns high instead of 4, and that would give me a center pixel.
Cheese.
A center cheese, exactly. 2080 LEDs. Oh, per board. Whatever that is divided by 4. 520? Don't worry, Finuki. I'm gonna get to it eventually. I promise. I'm sorry for keeping on hold. I just need to explain stuff from the beginning for people. So yeah, I've changed some of these to 5 high, and stuff. Just this is just a thingy, whatever you call it, a plan. Nothing is decided on yet, and maybe I won't be able to do it because maybe there won't be space between the boards for the chips to actually go, and there are going to need to be many more chips. Many more, somewhere around 800. Anyway, but here's the thing. With the shift register, I can clock out data as quickly as I want because it has a clock pin and it has a data pin. And I can pulse that clock pin while presenting data on the data pins as quickly as I possibly can because the Arduino can only do that at a maximum of 8 megahertz. Only 8 megahertz. That's, in my mind, that's super quick. But anyway, the shift register is fine with that. It can go faster. But basically, then time is not really much of a problem there. Bangma bits. I know, right? It's called bit banging. Hi, Lucky Cake. Can you play stuff from the beginning? Oh no. Actually, hey, I am. Hi, Jockibber as well. Welcome. Starting to resemble DMX. I wonder. Just popping in for a while. No worries. Hi, Haku. But with these ones, what you have to do, by the way, this is where there's an error in the datasheet, in the English one. This is wrong. Where's the other datasheet? Hold on. I love working from datasheets, so there isn't. Hold on. The Chinese one is correct. Here. So, essentially, here's how it works. You have a every bit that you want to clock out. By the way, the reason why you can't clock out at a whatever speed you want with these is because there's no dedicated clock line. So it's expecting the data to come in at a specific speed. Otherwise, like, what does it even mean if you're turning on an input at stupidly fast times, right? So you need to be doing it at a specific speed. And the way that you do this, hi, Great Kingzilla. I see a cutie. I see a kind person who might be mistaken. But here's the thing. Every pulse, so here's how if you want to clock in a single bit into one of these, you have to clock in like 8 bits per color channel, and you have to clock in 24 bits because it's red, green, and blue. I think you have to clock in 24 bits. And yeah, we can go to the English one for this section. It's a graphic. It's basically means the same thing. Yeah, if you want to clock in a single bit though, so just imagine this process 24 times. You want to look at the value of the bit that you're wanting to clock in. And you just have one data line. And here's what you do. Let's use Paint for this actually, rather than Notepad. Why is this not fitting my screen? There we are. So here's a timeline. And here's the center. Oh, this is amazingly straight line. There we are. I'm just as good at being straight myself. So the value is either going to be low or it's going to be high. It's also going to go back in time a bit, but ignore that. That's going to be a straight vertical line. So let's just pretend your line is low to begin with. Now when you want to send a byte, I eat bits. Oh my! When you want to send a bit, you start by making the line go high. And how long it remains high for determines whether it will be interpreted as a 1 or a 0. Basically, if you want to send a 1 bit, then you stay high for a relatively long time. and then you stay low for a relatively short time, like this. So right here is the beginning of a new thingy. And right here would be the beginning of another new bit, and like right here would be the beginning of another new bit. So this here would be roughly 2 1-bits. You've got one here, and you've got one here. And if you wanted to send a 0-bit, the way you do it is you stay high for a relatively short time. So instead of this, you'd stay high, low, high, low, and yeah. And what's actually happening inside the chip, by the way, is I believe there are 2 timers. Well, one timer. We don't really care about one timer at the moment. And what happens is the moment you transition to high level, so right here and here, so at the start of every bit, basically, when you transition to a high level, you're starting a timer inside the WS2811. And when that timer runs out, it takes another reading from this data line. And that reading happens somewhere around there and there. So basically, if it's and what it reads on that second, when the timer runs out and it takes that second reading, that's the bit value that it interprets. So if you go high and stay high, then when the timer runs out, it's going to read a high value. If you go high and then low immediately, when it does the second reading, it's going to read a low value. So that's why you have like a long thing, and if it's a 1-bit, and a short thing if it's a low bit. But you have to do it at like a rather specific speed. I think, if I'm correct with this timer assumption that I actually got from reading someone else's post, and it makes a lot of sense, but I didn't come up with such an amazing idea myself. If this is correct, then it's actually not going to be too timing critical when the next bit starts. This timing is very critical. This timing is probably a bit less critical. You could like maybe delay it a little bit if you needed to. There's actually a second timer that starts at the same time, but this second timer is like on a way longer scale, like orders of magnitude longer scale. And when that second timer runs out, oh, by the way, I should mention, every time it goes high, every single time the timer restarts, both timers restart, in fact. This is always restarting the timers. But anyway, when the other timer runs out, this other timer is not for reading in data. The chip doesn't use it to read in data. This other timer in the chip is used to tell whether you've finished sending data in. And it waits like a very, very long time, relatively speaking. We're still in microseconds, but we're in like hundreds of microseconds instead of a microsecond. Actually, I think that's shown there, 280 microseconds. There. So this is like if it waits for a very long time and basically you haven't done any more pulses, that's when it latches whatever is currently in the shift register, like onto the outputs and updates what the LED outputs are. So basically you clock in lots of data. Every time you clock something in, whatever the value was in that chip's internals before gets shifted out to the next chip and the next chip. It really is just shift registers. And then if you just don't send in anything for a while, the second timer on all the chips will kick in, and whatever is currently inside those shift registers gets presented out onto the LEDs. But yeah, that seems to be how they work. Hi, Coding Vibe. Welcome. I was bad at this stuff in college. Digital Logic Design, I think the class is called. It sounds fun! But this is what the chip already does, so I'm not really designing any of this part. I'm going to design something to try to be compliant with this. Can't judge you for not being able to draw straight lines. Holy cow, 1 kilowatt is the legal limit for 4 meters, 70 is the limit, that's 19, freaking 48. What? Okay. Nice. I guess. I'm sure as hell not going to be radiating 48 kilowatts from my board. I flipping hope that'd be some insane messing up if I did that. Sometimes only look like chips could only do 30 kilohertz, if that's written somewhere, be better. Yeah, so this is 800 kilohertz, approximately. Fried cat. Ah! Have you seen those videos, Hakan? Since you're into radio stuff, have you seen those videos that have been doing the rounds recently by some people, like for like a proper reason? This is not just like them going, like they're doing this with permission and for educational purposes, but where they like touch like a sausage on a stick to an AM radio antenna, and the sparks that are jumping, as well as being modulated at the super high frequency of, you know, I mean, I guess it's not super high in radio terms, but like a few hundred kilohertz. It's you hear the audio through the spark or plasma, I guess, that's jumping. So very, very interesting. That would be me. You'd hear the pulsing of the LEDs through my. Okay, it's gonna get a little bit glorious. Let's not go further. Sausage or pickle? Yeah. Got the idea of a fan art with Yuki and messing with the circuit board, and she has the static standing up hair. Oh, that'd be pretty cool. Can't judge you for not being able to be straight. Hey, I just moved a USB cable in a weird way, but thankfully it wasn't plugged in. The thing that blew my mind when I learned it was old school radio with literally a resistor, a capacitor, and an inductor. That sounds interesting. You know, you can get basically, yeah. There were crystal radio sets that didn't even need power. They would just use the power that was already in the air from the AM transmission, basically. And it was literally basically a crystal. And no power supply of its own. And some other stuff probably. But like the key part was the crystal part. And I don't know how it worked. But it was quite amazing. You can do that with a battery clamp too. Yeah. I guess so. You need to do that with cheese, please no. Crystal, oh, diode, okay. Crystal diode radio. You can do that with an LCR circuit. Really? Interesting. I had an electronics kit when I was very young. Like, you know, like a children's sort of 301 electronic lab. I don't think it was 300. I don't know if it was 300 or 150 or whatever. I might just be thinking of Pokemon and I'm thinking of 150. But anyway, one of the things was a crystal radio thing. I couldn't get that to work. Anyway. Use your crystal radio to listen to cryptic messages from the home base. Crystal is basically an AM demodulation diode. Man, RF is such black magic. It's actual black magic. What is this? So anyway, point is, you need to be sending these pulses in at a certain rate. You know, you can't just go ham and pulse as quickly as you want, because the length of your pulses is what gives, you know, your pulses meaning. So you got to do it at the right speed. And that means that for 2080 LEDs, that's how many LEDs were in the old board, by the way. If I add 5 LEDs to every 4-bar chart graph thingy, it ends up being about 13 more LEDs per MIDI channel. So 13 times 16. Anyway, we're going to be looking more. But anyway, just assuming 2080.
Cheese.
Cheese!
Has it?
Lactose-filled dairy product.
Hi, welcome. Exclamation mark, why cheese? Hi, Omni. Yeah, then that would take, if we're looking at approximately 1 microsecond to send all of this stuff, to send 1, bits of data. This is the one that's wrong. By the way, look at this. So, cheese. So the timing for a 0-bit for a high value, sorry, the timing for a 0-bit high and low is, we've got like this low value, 220, 580, and here 580, 220, the other way around for high and if it's a 1-bit. The English datasheet says that you have a 220 for 0 high, 580 for low, but then it says 580 for high and 580 for low, so for the 0-bit, and there's a mistake. Amazing. Thank you for the pads. And so when you were tuning a radio, you were adjusting the resonant frequency of the circuit to change the radio. I see. When you pair those 3 components together, there's a specific circuit resonant frequency depending on the... so you just match it to the radio frequency and out comes cosmic radio waves. Cannot go ham, you must first create the sandwich. I had a sandwich last night that was the jalapeno chili, cheese from the cheese taste testing stream, and a slice of ham. And also a slice of Edam, also from the cheese tasting stream. Like, in that order, stacked in the sandwich. It was so good! Bluetooth pads today. Bluetooth pads. Bluetooth pads? Cats. Oh yeah, right. Cat's whisker. That was a thing as well. Please don't use one of these. These whiskers. I need these whiskers for something. Yeah. So that would take 2080 times 20. No, not times 24. Times 8, right? Because every channel is 8 bits. So that many bits need to be sent. So wait, is that correct? 2080 times 8. Yeah. So that's 16,640. 16,640 microseconds. That would be. Which is wait, is that right? Yeah, it seems about right. So 16,640 microseconds is also known as 16 milliseconds, which is also known as... Wait, what did I do? 1,000 over there. Which is also known as about 60 FPS, which is really cool until you realize... you're gonna have no time left for doing other stuff that you need to do in the circuit. In the program, like working out what values you should even be sending in the first place, like paying attention to the MIDI messages that are coming in, working out, hey, this one's for the instrument, therefore we're going to display this number next in the 7-segment display. So, yeah, but this is kind of best case. This is, remember how I said you could probably get away with like a bigger gap here? And I probably will. Well, yeah. That's like absolute best case. And I kind of don't want that. So, here's the thing. I've been thinking, I want this to be as fast as possible. And now, what if I could use one of the Arduino pods, solder in her whiskers, 800 nanoseconds per symbol at minimum, but the heck at maximum depends on the bits, 13 or 14. Well, there's a big range on these values here. But you could think of like one microsecond is super long, right? But you could also do 580 minus 220 if you, 580 plus 220 if you really wanted, and that's a bit less. So you could, it would work as fast as with as short a time as that, but it would also work with a longer time as this per bit. Isn't that 19.2 microseconds per chip? Because 800 times 8 bits times 3 channels. What? So 580 plus 220 is like the absolute smallest. And this is nanoseconds. So I'm going to divide this by 1,000 to get into microseconds. And then we have 24 bits per chip. Will be 19.2 microseconds. And then you multiply that by the 2080 LEDs, except this is going to be as if they were RGB LEDs. But because it's only one channel per each of them, we end up with... Wait, this is a different value to what I ended up with. Oh yeah, right, of course it is, because I was assuming a 1 microsecond per channel, per bit before, and this is assuming 800. So if we divide this by 800 and multiply it by 1,000, we should get the value I had before. Yeah, okay. Yes, we've come out to the same calculation, Finuki. We just got there in different ways, I guess. Have one deal with the shift radius out. Have one deal with the shift and the... Do soldering cats have tin whiskers? Not if I'm careful. What does this define? What is this in response to? Define chaining. Hi, Sunmike. Would you be able to use an ESP8266 or ESP32? I could do, but I already have an Arduino, and I really, really want to see if this is possible with an Arduino, because this seems like a very cool technical challenge. Because imagine if we could use one port on an Arduino to output 8 lines at once. Then we wouldn't need, each string would just be, imagine if we could just update, imagine if one string of LEDs was one MIDI channel, and we weren't chaining them through like this. We were just doing one string and another string and another string, and each of these went to their own ports. And this is something that I've not seen done before on an Arduino. It has been done on the higher spec boards like the ESP32. But I think with some cursed memory layouts, this is actually totally possible. And so that alone, the fact that no one's done it before, or made a library to do it at least, maybe they have done it on personal projects, but the fact that no one's made a library to do it, so I haven't seen it done before, and the fact that I think it's possible, makes me want to try this. And I already have a little bit of LED string, actually right here on my desk. It's here it is. It's just two of these LEDs, which have the WS2811 or WS2812. Not sure which chip, but the timings should be, you know, pretty much compatible. So we can actually test this, like right here, right now. Isn't that just a WS28 strip? Yes. But here's the thing. Let me just get the goddamn text file that I had up yesterday. All right, so here's what I'm thinking of. These are the values in the datasheet for a 0-bit and a 1-bit. And these are the values used by somebody who decided to split this up into... okay, so... okay, let me back off a bit. At 16 megahertz on the CPU, one clock cycle lasts about 62.5 microseconds, I think. So we've got 16... So 1 divided by the 16 million is this long in seconds. And it's this long in milliseconds. And it's this long in microseconds. And it's this long in nanoseconds. Yeah, okay. So these are really, really small things we're working with here. So like, I mean, really tight timings. I remember that outputting a value on a port took 2 clock cycles. We measured that on my oscilloscope, which is really, really cool. And that was just with like, you know, that was just a one-off, like write the port and write the value and then write another value, hard-coded values. But I might end up having to use assembly for fine timing control and stuff in the future, which is interesting. This might finally be my time to learn assembly. Might finally be here now. Anyway, so the person who did this divided this up into the concept of ticks, where a tick was 2 CPU clocks, and then a 0-bit would be 3 ticks and 5 ticks, and this would be 5 ticks and 3 ticks. And that way, it's always 8 ticks long. It just depends where you split it. If you have the first bit last less time, that's a 0-bit. If you have the first bit last more time, that's a 1-bit. My voice is starting to hurt. Now imagine that we want to send 8 parallel values. Imagine we have 8 LED strings, okay? Each one's data input is attached to one pin on a port on the Arduino. And we can write to all 8 of those pins with one port write. Now imagine we want to send this out. So we want to send a 0-bit on the first 4 strings and a 1-bit on the second 4 strings. So what we want to do is, first of all, we want to, so basically, read these downwards, basically. So these ones here, the first string goes high for a bit and then low for a while. And the same with the second one, third, and the fourth. The 5th one goes 1 and stays high for a while and then goes low. And the same for the 6th and the 7th and the 8th. But then when you look at this, I had an amazing realization. There's actually only one single part in here that matters. Thank you for new countdown in a sec. So here's the thing. No matter what bit you're trying to write out, you always start by putting the output high. So the output on the port will always go high at the beginning, no matter what you're wanting to output. And by this point here, you're always outputting a low value. So the only part that actually matters, so basically you can hard code to output all high levels at the very start, and you can hard code all low levels at this point. The only part that matters is right here. This part depends on whether it should be low or high. And this value here is just this value. It's literally just the value that we want to send. So all we need to do is hard code all high levels, wait a specific amount of time, and then output this value on the port. And then wait some amount of time and go to 0. That's literally that's all we need to do. And then we can move on to the next bit in memory. And this would require a little bit of a cursed memory layout, because rather than storing it byte by byte in memory, we'd be storing 8 bytes interleaved. We'd be storing all of bit 0s, and then all of bit 1s, and then all of bit 2s, and then all of bit 3s, 4s, 5s, 6s, 7s, and 8s. But like, this should actually totally be possible. I think this would actually be possible. And this here is a weird way of me saying that. Also, this is a bad calculation of this, I think. Number of LEDs times 3 bytes. Yeah, this is wrong actually. It's LEDs times 1 byte. So that would be 2080 bytes of memory. Not 2080 bits, but 2080 bytes, because every LED has 8 bits. But if we wanted to save memory, I could just store it as 4-bit brightnesses. And then just do this loop twice for every bit, because the LEDs still need 8 bits, so we just clock every bit twice. And that'll give us cheese. That'll give us cheese. That'll give us a value from 0 to 15 brightness, which is pretty cool. So full off, 14 grays, and then full on. And that's like, we're still kind of, basically we then use half the memory, and we still have 16 values. So it's already so much better than currently, where we can't even dim per LED at all. Anyway, this is very exciting to me, and I kind of want to try to just make a quick thing in Arduino to try to, so-called bit bang, do this output to an LED string. And I'm only going to care about 1 bit of a port at the moment. Because if this works, then it will just automatically, it should just automatically work for 8 strings. Thank you for the pads. Because like, there's going to be no change to the loop. The only difference will be the data that's already stored in memory elsewhere. So I'll need to do stuff differently elsewhere where I'm preparing the stuff to be sent out. But this little routine here that outputs some value to a port, well, all 1s, and then some value, and then all 0s, there, should be the same. Anyway, all right, finally time to hydrate. Thank you for the hydration, Finuki. I actually need it right now. Alice! Thank you for the raid! Hi, welcome! I just have to hydrate, I'm sorry.
Sit.
Oh my goodness. Thank you. Wow. Thank you for follow. Whole life is a joke. Hi, and Grotesque AI. Welcome. And Cupid Good. Hi, welcome. Oh my god. Hi. Welcome, Cupid Good. And GNC. And Headless Grapes. What a good name. I love grapes. I haven't had grapes in ages. Rodney Folk. Hi. Alice, of course. Nominal New Night. Nice. Hi. Welcome. Oh my goodness, Alice as well. Hi, welcome. Thank you for the follow and Headless Graves. What are you up to? Let me shout you out. Wait, I said Alice. Shit, I said Alice. I misread it. I'm sorry. I now see the error of my ways. I'm sorry.
Alice or Ilis or AI Lice, welcome. I'm now gonna do a spooky shout out. Wait, I'm not going to be able to see because I'm on the evil redeem. I can just about see your avatar. Oh no! Pat, don't worry, this wears off in like 30 seconds. AI karaoke quest. Request anything much faster. Pat, Stop spraying me! Stop it! I don't need the holy water, I'm going to be gone soon. I'll be gone by the morning. Wait, when is this gonna stop? Hello? Stop! Wear off! Go away! Oh my god, okay. We did AI karaoke as always.
Alice is good. What are you doing, guys? Okay, I'll say this. Hi, welcome. I hope it went well. AI karaoke. Like RVC, retrieval-based voice cloning thingy? Or voice conversion, is that what RVC stood for? I can't remember. Converting a voice into another singing voice thingy and the voice is AI, I don't know. I'm retro now, apparently. Hi. Oh, okay, I guess I shouldn't be digging into her internals then, sorry. And that's very rude of me to be peering into the internals. Hi. Welcome. I'm a strange cat. Currently I was working on some... oh, sorry, hold on. Hold on. 1 sec. I'm gonna turn off redeems for a second. and now we have to wait for it to actually wear off. Hold on. Screw it, I'm gonna turn it off myself. There we are. It's rude of me to keep it on. I should have turned off redeems when I was the raid. No, I've turned it back on. Stop. Okay. Thank you for the follow, JMC. Hi, welcome. I'm a strange cat, and I was working on about to be trying to do a thing that I haven't seen someone do with an Arduino before, which is a little microcontroller. We're doing a little bit of electronics, a little bit of programming. I was asking a technical question about the AI karaoke, but then I realized, wait a minute, if you're doing this as this wasn't just a special thing, if this is what you're always doing, maybe I shouldn't be asking the details about, or like exposing the details of how you're maybe doing it. I realized it was rude. The nerdy part of me kicked in, I'm sorry. High voltage CP. Welcome. But I hope it went well. Hello everyone. My hands keep on getting stuck. I guess I should do a quick recap of this. The crunching of MIDI data into the memory is probably going to be some kind of pain. Yeah, that's going to be the messy part. Okay, so let me just show people what's happened so far in the grand scheme of this project. So, once upon a time, I thought it'd be a fun idea to make a circuit board. I'm opening the wrong thing right now. My computer is flipping, dying off stream. Okay, here it is. I wanted to make like a circuit board that's just basically a big LED display. Loads of flashy lights and numbers and stuff. And all it's going to do is show you what's happening. Basically visualize music as it plays. You'll be able to see, but it's going to be for a MIDI file because I make MIDI music. And you'll be able to see like the volume and like the attack and decay and release speeds and cutoff and resonance, all these little things. As it plays. And I thought that'd be really cool, because everybody likes flashing lights, right? And a few months went by of like designing this thingy and having it, and yeah, very recently I had it made, and well, long story short, it doesn't work because I made 2 mistakes. One of them was kind of easy to work around, the other one was not. But hey, you can have some photos, at least. It looks interesting, right? Here it is. Ta-da! And this is when some stuff was soldered on. The company that made the board soldered on all these tiny parts, and thank God, because they're really small. And then all these holes are for me to solder in LEDs. There'll be 2,080 of them in total. There we are, there's a mouse for scale. Unfortunately, this little creature known as the long uke, which is based on the derp emote of mine and the mid emote and the tail end emote. Unfortunately, she says uke see flashy lights, but she'll never see any flashy lights because this board doesn't work. Anyway, here's a bunch of beauty shots and shots of me bodging things to be able to test it. Yes, I had to do it in this weird way. I couldn't just solder them in normally because of the mistake I made on the board. Blah, 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 blah. Okay, we've done a couple of streams of that in the past. And now I'm thinking there's probably a way that I can remake this board for cheaper and better, and heaven forbid, maybe it'll actually work this time. In short, Alice just cover any songs that get requested or write a song from zero. Depends on what people want. Oh my. I see. Sounds nice. Thank you for choosing me. I wonder why you chose me. Very, very weird cat to raid into, but I very much appreciate it. I guess it's technical. Still, harder, better, faster, stronger. It's, yeah. Definitely, it's going to be a little easier. It's hopefully going to be better. It's probably going to be slower. Easier, better, slower. Stronger? Question mark? Oh, hold on, let me turn on the radians again. Okay, hold on, it's going to catch up. Ah! Jeez! Oh my god, the hand is completely broken wrist mode right now. Thank you for the pat, thanks. Yeah, hi. Sorry, I had the radiums turned off. Don't worry, they're back on now. Yeah, they're back now. Poof. Sorry about that. I turned them off for a moment because I thought it was like a bit rude for me to be trying to talk to and say hi and chat with the raiders and guests and stuff. In a way that sounds more like oops. Wait, hold on. There it is. Wait, now it's okay, there we are. Where you can't possibly make out what I'm saying. Even if it does sound amusing. Thank you for the hat. What is happening to this hand? Why is this hand looking? Okay, you know what? I'm gonna restart the streaming setup. This is silly. This is very silly. I don't want to break people's wrists every time they try to pat me. One sec. The screen's gonna go black for a sec. Right after this hand has broken its wrist as well. Okay, hold on. I'll be right back. I'm still here, really, but I'm in the void. So let me just... There we are. Now I have the void echo. Bluetooth pads? Why Bluetooth?
Nyan.
Wobble Yeek rises again, but just for a moment. Okay, I'm back. I'm not sure if they'll be fixed. I might also need to restart VC Face. We'll see if this is the problem with my setup or with VC Face. Let me find out. Let me pat myself. Hold on. The future is now. We have self-patting cats. There we go! There you go! That's how the hand is supposed to look. Is your hand rooted to your 2D avatar instead of your 3D model? Is my hand rooted to my 2D avatar instead of my 3D model? Oh, you mean like the patting hand was moving to the... no. I'm not sure why it broke though. It's very weird. Yeah, I know what you mean. I know what you mean. When I was having to be 2D, which I might have to be later if I'm going to want to be showing this stuff in real life. I can go to this view. I can turn on... Wait, where is it? Hold on. I can turn on... this view? Which is the view of the oscilloscope, which is currently reading nothing, but it's here. But I don't have my... Obviously, my camera's tracking me right now, so... I can't point it at the Arduino to show what's happening, or the LEDs to show what's happening. But I think first I need to try to start this programming. Essentially, I just finished like spending an hour trying to explain to people what I'm gonna be doing. But essentially, it's I'm gonna be trying to drive and then control, like send the data to control LEDs. Which are currently RGB LEDs, but they won't be eventually, just because I have a strip of RGB LEDs that use the same controller, driver thingy. I'm going to be trying to make an Arduino program to control this strip of LEDs very manually, sort of low level, not relying on the libraries and stuff, because if I'm able to do it that way, then I can control a bunch at once, literally clocking out the data to 8 different things at the same time, which means I can like control crap loads of LEDs at a high frame rate and stuff. Which sounds great for an LED display, you know? Okay, let's just get rid of this. Where's the actual... Where's Arduino? IDE. Where is it? Programs. Electronics. No, that's not it. Arduino. Hold on. Here it is. It's probably going to reload the last sketch that I had loaded, which was the code for the... that I was trying to write for that prototype version of the board that I had made that didn't work. But if I'm gonna remake it, yeah, it is. It is. Okay, let's just make a whole new thing. Control N. Done. It's on the other screen though for some reason. Hold on, let me save it and then I'll bring it over. Let's call this... What was the previous one called? MIDI LED board. But I'm gonna call this one MIDI LED board V2. Because I have an amazing imagination. and I'm really good at naming things. Alright, here we are. Zoom in a bit. Maybe zoom in a bit further, question mark. I don't know how much I need to zoom in. Oh god, there's not a key I can press to reset it quickly. Oh no. What size was it? This, I think? I know it's... Okay, let's just go with this. Anyway, okay, so, first of all, we will need some data to send. So let me just make an array of data to send. And eventually, when I'm controlling 8 different things at once, like this 1, 2, 3, 4, 5, 6, 7, 8, all these 8 different things at once, I'm gonna have more to send. But now I'm only wanting to send one thing at a time. So I'm gonna need, I need all of the bits that I want to send in a separate byte. How do I explain this? So the first byte is going to be my hand's stuck. The first byte is going to be all of the 0 bits that I want to send. Actually, I think it starts with the high bits, not the low bits. Let me check the data sheet. Not this one. The data of D1 is sent by microcontroller. Data transmit in order of RGB. High data bit first. Okay. Okay. So send all the red values high to low, then all the green values high to low, and then all the blue values high to low. Okay.
The models.
Oh my god. It was a new sound. Hakun, if you're there. That was a new sound. We have a Norwegian cheers. Yeah, so we're gonna want a by the way, hi. Welcome, hi Omzi. But why cheese? Okay. So we're gonna want 24 different bits to send. All the reds, all the greens, all the blues. 8 bits each. And the first byte will be all of the 7 bits. The second byte will be all of the 6 bits. Oh my goodness. Hi, welcome in, Sheps. Hi. Thank you for the raid. How are you shepsing? Hi, Sea of Tranquility. Why cheers? Welcome. Sheps. Oh, mighty. I just saw the description. Sheps has 3 brain cells and just current rate 6 recovery in over my head. Ah, this is the challenge thingy, right? It's not actually a disaster. Someone's made a challenge that sounds like a disaster scenario, but it's a challenge to try to recover the data, right? Hi, Cypher Enigma. Hey!
Oi, cheese.
I just got 2 of the same sound. Hi, Sanadera as well. Welcome. I've been shouting far too much this stream. Way too enthusiastic. My voice is kind of hurting quite a bit. With no help from chat. Don't check the VOD. Alright, I'll believe you. From one streamer to another, I'll believe you. I'm sure that's right. Good job though, Shabs. We all know that streamer brain is a real illness, and when you're streaming, it's a lot harder to do even the most basic of things. So, you know, they were just making up your brain capacity to the usual capacity. Anyway, I'm sure you could have done it if you weren't streaming. Anyway, welcome. The VOD is gone for some reason. Oh wait, why am I still holding my nyan juice? Oh, friendly reminder to stay hydrated, by the way. Hashtag not sponsored. Okay. So we would ultimately have all of the 7 bits, and then all of the 6 bits, and all of 5 bits for all 8 strings. But we only have 1 string now, so I'm just going to use 1 bit of the port to store bit 7, and 1 bit to store bit 6, 1 bit to store bit 5, on like the same bit, but on different bytes. This is going to make more sense if I actually write the goddamn thing. Okay, so we want... What should I call this? Let's call this, LED data, I guess? We'll just make this an array of 24 bytes. I'm using only 1 bit in each byte, which sounds, well, it is obvious, horribly wasteful now that we only have 1 string. But eventually we'll have 8. They'll all be good. They'll all be packed in nice and tight. So what do we actually want to do? How about we try to make them red? What about we try to send a red value? That will be very obvious if we get it correct. So to get a red value, we want to send 8 1 bits. That'll be maximum brightness on red. And then 8 0 bits for no green and 8 0 bits for no blue. Let's try and do that. And this actually is going to be very nice and easy to read because we can literally just say 1 1 1 1 1 1 1 1 and then all the zeros. 0 0 0 0 0 0 0 0 and another 0 0 0 0 0 0 0 0. Yeah. So we're not doing 72-bit color. 72-bit color? Wait, what is 72-bit color? Hang on, what is that? 72 divided by 8. 9. Huh? 9 8-bit channels? Oh my god, I'm hiccuping, sorry. Hi, French Monkey. I'm using an Arduino Mega currently, but I would actually be able to use an Arduino Uno if eventually I incorporate this idea and I store all the colors in 4-bit instead of 8-bit, or brightnesses, I should say. Then I should only need approximately 1 kilobyte of RAM in use for all of the LED data at any one time. I'm going to be keeping all the LED data in memory rather than building an array and sending it and then destroying the array and then building the array and sending it and destroying. We'll just update the bytes in place whenever we receive a new MIDI message. For example, when we receive a MIDI message that changes the volume, we'll adjust the bits that describe the bar graph for the volume LEDs, made out of the volume LEDs, in memory, and we won't sort of, you know, it's not just going to be like a single byte that says the volume. It's going to be a bunch of bytes that describe the brightnesses of all of the volume LEDs. And then we'll just clock out the entire string that contains that MIDI channel. Because every MIDI channel is going to... Oh, right, hang on. I didn't quite say this. So version 2 of this board, which I was probably going to have 5. I've only changed one of these. It still has 4. Yeah, I was thinking of doing 1 string per MIDI channel. So 1, 2, 3, 4, 5, 6, 7, 8. So that's 8 strings, and that'll all be on 1 Arduino port. And then we'll have a second port down here. 1, 2, 3, 4, 5, 6, 7, 8. So we'll be using 2 Arduino ports. One of them will control the first half of the display, and one of them will control the second half of the display. So if we wanted to update anything, say something on here, what about this last channel, channel 16, then we would need to clock out all of the data for this. We don't really care about this string, right? But because this string is attached to this port, this 8-bit port on the Arduino, when we clock out, we'll also be clocking these. Just, you know, it's unavoidable. So we'll end up clocking these out. It doesn't really matter. It's going to be no slower than clocking out data for 1. We just kind of, for free, can update another 7 channels rather than just 8. Whenever we're trying to update 1 channel. So, you know, if a bunch of things change, say on channels 12, 14, and 16, then when it comes next time to send out the new frame of LED data, we'll do it all in the same amount of time as if only 1 had changed. Of course, if something on channel 16 and something on channel 1 both changed, then, well, we've got to clock out all of this and all of this. And probably we won't be able to do it at the same time. Maybe, I don't think the code will be fast enough to clock both of these out in parallel. But, whatever, it's no big deal. If I get this working, it'll be so fast that it's not going to be a big deal at all if we clock out all of these and then all of these afterwards. Anyway, I was drawing all of those scribbles on the wrong layer, and that's how I ended up with scribbles all over one of the previous versions of this drawing, which was then a pain to remove. So next time, I'll scribble on the scribbles layer instead, and save future use some problems. Do you recommend it? Sounds good. It depends what you want. It's very limited by... If you're comparing it to other things like ESP32, it depends what you need. ESP32 is way faster CPU, way more memory, has way fewer output pins, so I/O pins. But it's so fast that you could probably just like add your own shift registers to it and send data out through the shift registers and to multiply the number of ports that you have, the number of pins that you have. 24 bits for each of red, green, and blue. Extra true color. 24. Oh yeah, that would work, wouldn't it? Oh my god, that'd be crazy. Let's call it Bob. Wait, I forgot what that was all about. I'm sorry. Gotta go have dinner. Have a great chat. No worries, chaps. I'm sorry. I missed that message. I hope you're having nice food now. You as well, Alice. Everybody take care of yourself, please. Okay, so what we really need to do now is, well, we need to prepare to be able to output on whatever port we want to output on. For this, I'm going to be probing with my oscilloscope to test the timing. So the pins that are really easy for me to probe, because they have a ground nearby. Screw it, it doesn't really matter if there's not a ground nearby. I can use one of the digital output pins set to low as a ground to probe on. That should work. But the ones that would be good would be like pins 11, 12. Those would be good. And these are, okay, so this is pins 11. These are pins 11 and 12. Pin 0. Maybe on this. Hold on. What do we also have? We have pin 22. We might be able to do this. We could maybe use this port. We can maybe use port A. Port A maps to digital output pins 22, 3, 4, 5, 6, 7, 8, and 9 on the Arduino Mega. And just above pin 22 is... Oh, that's 5 volts and it's not ground. Shit. Okay, hold on. What about port C? Port C maps to these ones. What's a really easy to see one? What about the analog pins? Pin 0, there is bit 0. Analog 0. Okay, I'm gonna use port F then. Port F maps to the analog pins, but I'm gonna use them as digital pins. But I'm just gonna use it because on the Arduino Mega, there's a ground pin nearby to this pin. So I can just put the tip of the probe into this pin, and then the ground spring of the probe into the nearby ground pin, and we can get like a nice clean signal. That way I don't need to use like the clip-on ground lead on my scope probe, which introduces a bunch of noise and stuff. This should be a nice clean signal, which is what we want. We're trying to get pretty high speed readings by my standards. I want to be able to get accurate measurements of exactly how long these pulses are lasting. So I'll do this. Okay, we're using port F. So port F is what we're going to use. I'm actually not going to put this in the loop at all. This is going to be a one-off thing that happens in the setup function. And if I want it to happen again, I'll just press this. The reset button on the Arduino. Are you manually emulating pulse width modulation, or are you using the time on the chip? I remember I got unlucky one time with a chip I had only supported timer 0 and timer 2, so I had to emulate it myself. It's not PWM that I'm doing. It's a bit different. It's where well, I guess you could think of it like PWM, couldn't you? Anyway, I'm doing it myself in software. Yeah, I'm not going to be using timers. I don't think I'm going to be using timers anyway. I don't think I need to use timers. I hope not. Have you seen PIO on the Pi Pico? It's mad powerful. I've not. Excuse me. Kebab, pizza, fish and chips, KFC. Definitely healthy stuff. Wait, what? Oh, eating takeaway for the past week. As does taking care of myself. I don't know. At least you're eating. But, oh my god. Thank you for the saving the kidneys, Stu. I don't actually need to do it right this moment. So I'll pass for now. I'll probably do it on the next one. I'll refund you that one. But thank you for the hydration and the posture check as well. I'll do those now. Kind of want to get started on this. I don't know how it always takes me like 1.5 hours to actually begin the stream. It's crazy. I feel like I've been rushing and saying so much and yet made no progress. Tis the stream away, I guess. Tis the dev stream way. I feel like every dev streamer says the same thing. Maybe I should just not rush so much and stress so much about it. Then my voice wouldn't be dying already. Alright, and the posture check. But I guess I am like introducing new things on this stream, so it makes sense that I've got to yap about it for a while. According to someone, gotta trust someone. Yeah, it was in the comments of an Instructable, I think. It wasn't even the actual Instructable itself. It was like a comment. I can't remember who it was. I should probably look it up. Well, eventually I should too. Hey!
Cues.
Rude. Eventually I should, to credit. Oh, cheers. I'm glad you like the yapping though, for you. I'm glad to hear you're doing it the manual way. Yeah, I think because I want accurate timing, I'm gonna have to learn just a little bit of assembly. Admin assembly. I am wired right now. My hands are small out here, but I'm like... Bloop, bloop, bloop. Alright, so first of all, let's say that we want to write to port F. So for this, we need to write to the DDR F. Hey! What the hell? We need to write to the DDR register for port F, which says the data direction. So data direction? Is that what that stands for? Let's open up this one again. Wait, this is the V2. This one, sorry. I think it was a 1 value means output, if I remember rightly. All this code is going to be for nothing, isn't it? DDRC. What? Why?
Jeez!
Force bit 4 of port B, pin 10 equals latch to output mode. Well, this comment is completely out of date. Man. This comment is fucking... This is silly. Force bits 0 to 3 to output mode is what that is. Anyway, okay, so yes, a value of 1, it means that it's output. So we want to output on just bit 0. You know what? I'm just going to set the entire port to output mode. Let's just set the entire damn port to output mode. I'm not going to be using analog inputs for these ones. That way I can just probe to another analog output pin if I want to, because it'll act as a ground if I output a low on it. Okay, 0xFF. All bits of port F, which is pins, analog inputs 0 to 7 to output mode. And then I guess at this point I'm going to call the send data function, which I'm making right here. Sorry. I don't know why my computer is dying. Like it's nothing is fucking running. I mean, okay, that's a slight exaggeration. A bunch of stuff is running. But my flipping computer is dying right now. Why is it? Oh my god, live is not even... Wait, did I reset the affinities of these processes? No, I didn't. Hold on, let me do the thing. I made a PowerShell script finally to set the affinity of different processes. Oh my god. Am I smoother now than I was before? Have I smoothened up now that some of the VC face tracking stuff is not allowed to use all cores? Auto-tune? My audio setup, which is this ridiculously overkill thing, is using ASIO, and if for a tiny amount of time too much CPU is used, then the ASIO buffer, which is really, really tiny, starts overrunning and looping. I can actually add auto-tune. I did this once when I was playing a game. I think I was playing Distance. I know, hard to believe I got addicted to that game. Sorry, hard to believe, full stop. I got addicted to that game. The hard to believe was sarcasm. Meld Effects has a auto pitch. And I put auto pitch on my voice and changed the scale to be in scale with the music that was playing at the time. And if I do this, let's turn that off, turn this up, and then set a scale like this. There you go. What is the scale of the music that's currently playing now? Let me change the music. Okay, it's E minor. La. There you go. Now I'm in tune with this music. Yeah. Well, hold on. That should happen before the reverb. Yeah. Whoa. Woo. Ah. Ah.
Fromage!
Okay, that's enough. That's enough. Silence.
Cheese.
Ah. One auto nyan. Oh, okay, hold on. Wait, I should do it without the reverb so you can hear it better. Hold on. Nyan. Nyan. Okay, get out of here. Get it. Go away. Be gone. Ah. Well, it sounds really nice when with the reverb, actually, but why cheese long kedda? Hi long kedda. All right, so we set them all to output, and then in send bits we want to do our thing. All we're gonna do is get a pointer to the. I just want to know how many bytes to send first, don't we? Well, you can just do LED data dot or size of LED data, right? So. Is that how it works? I think that's how it works. Because they're bytes. So it's just going to be this size in bytes. The size in bytes is the length of the array. Because it's a byte array. Okay, so we want to do this for a certain amount of time. Well, not for a certain amount of time. A certain number of bytes. So I guess I do need to use 16 for this eventually. Right now I could use a U8. But actually, you know what? Hold on. Let's make a pointer to the start of data. LED data current is equal to... Oh, sorry, it's the pointer. This is a pointer to... Well, it is just LED data, which is the start of LED data. So this is equivalent to this, right? And then we have one for the LED data last. So what is the last? The last entry in this array is going to be LED data plus the length of LED data, size of LED data. So that's plus 24. Minus 1. So the last entry is going to be this plus that. And now we can just say while the current pointer has not yet reached, or is less than or equal to this, I guess, we're going to do a thing. And what we want to do is write to port F the value stored in here. So the value stored in there. And then once we've read that, we're going to increment to the next pointer. And that's it. Congrats, that's the entire program. Oh, we got to call this though, I guess. Send data. Does it compile? Hi, Anacoded. That's a pretty good name. Which software stream are you using for Avatar? I'm using VC Face. VC Face is doing the tracking, but what's doing the rendering is not VC Face. Because behold. Wait, where is it? Hold on. Wait, where is it? It should be running. I'm moving, but I can't see it in my taskbar. Am I blind? Oh, yeah, I'm blind. Okay, here we are. Here's VC Face. But it's not doing the rendering. It's actually sending the motion data over to a Unity program that is responsible for everything that's moving around. So this is like a Unity program that I made myself. My streaming setup. But VC Face is the thing that's doing the tracking. And there's a leap motion for the hands, which is being done by VC Face as well. VC Face has the support for the leap motion. And yeah, it's just a webcam and a leap motion. And moving on to the final interview for the job I interviewed for last week. Good luck! The real Otoyuki? I sound like every modern singer. Hold on. Yeah! Wait, yeah! Woo! I was trying to sit right on the threshold between those two notes. I have no idea how rigging works, but I think yours is great. Thank you! I didn't actually make the avatar from scratch though, because I have zero artistic skill. However, I did modify it a whole bunch, but yes. There are credits below, but Arisaka Mito was the one who made the base, which is basically the avatar. I changed. What are my hands doing, man? Now I removed the human ears, added whiskers, added the collar and bell, changed the clothes, the ones which were also made by someone else. Changed the hair. Changed the eye texture. Completely transplanted legs from another avatar called Glaze, which I also bought on Booth. And probably something else I've forgotten. I have zero artistic skill. Sinus, you have the patience, so artistic. I'll pay plenty of artistic skill. For a second, I thought you said I have patience. I was about to say, now you listen here. I have no patience for being called patient. Hey. Yukia Derulo. Derulo? Okay, I'm kind of gonna upload this and see what happens. Also, I realized this is actually not what I want to do in the slightest. What the fuck am I doing? What I want to do first is turn every bit on, and then turn it into this, and then turn every bit off. Apparently I've forgotten the thing that I just was showing everybody. So we turn every bit on first. Dr. Yuke, she has no patience. Thank God! Okay, so we're gonna output all 1 bits. Output all 1 bits. Output the actual wanted bit value for each of the 8 LED strings. As I say, output 1 bit for all 8 LED strings. And then afterwards you want to turn them off again. And I can't use the delay function in here because delay is for milliseconds. And I can't use the delay microseconds function because that delay is for microseconds. We want a delay here in the hundreds of nanoseconds. So I'm just going to put no delays, and I'm just going to see what speed we get. And I'm curious to see if writing it out like this in C is actually even fast enough at all. If it is, then hopefully I can pad some extra stuff in to make it take longer if it's fast enough already, if it's too fast. But this to this needs to last a short amount of time. Oh, it doesn't. It doesn't need to last that short amount of time. So we clear the bits somewhere around there. Or there. And afterwards we turn them all to 0. Anyway, let's just see what happens. Because after this, there's going to be a wrap around the loop here where it's going to be doing this comparison here. So this is going to take a few clock cycles, probably. I don't know how many clock cycles. I'm guessing it's going to be like a... I don't know how it works. Is there like a native branch if less than or equal to instruction? I guess there must be. Well, I mean, it doesn't have to be. Anyway, eventually I'll probably end up writing this in assembly, but this is basically what I need to happen. So writing it in C first is useful to get my head around it, and then I'll just like try to convert it into assembly, I guess, eventually. Just try to convert it into assembly, says the cat who's never written a line of assembly in her life. I'll put 0 bits. 0 bit for all 8 LED strings. Hi Stu, yeah. I think that my time for assembly has finally come. At least like I've actually have a use case for it now, like a real use case. Okay, I'm plugging in the Arduino. Boop. And it is going to be AVR assembly. Hi Azrael, welcome. How are you, Azraeling? So as a reminder, what we should see is something like something like this. We should see something that looks like this. This is for a 1 bit. And this is for a 0 bit. I guess I should draw the thin line here as well. Through the middle. This is meant to be a thin line through the middle. A straight horizontal line. So we should see this repeated 8 times. And then we should see this repeated 8 times. But the exact shape of this is definitely not going to be right. Definitely not going to be right. But let's see what the hell happens. Let's see if we even get 24 pulses. Let's see if we even get 24 pulses. I think I'm probably thinking a bit too far ahead. It's going to be 0x00, so it looks the same as the one above, even though it means the same thing. Alright, upload. I'm just uploading to the correct board. It is. It's done. Okay, it's running. That was very fast. It's tiny code. It's only 740 bytes. Oh wait, that's yeah, program storage space. I'm trying to select this line for the life of me. 33 bytes of memory. That's pretty fucking cool. 24 here. So the Arduino, wait, the Arduino, whatever you'd call it, SDK, I guess, but in the background is using 9 bytes? You think assembly is easy? Using assembly well is difficult. We'll see. Raid cheese? You raid cheese? Is that a good thing? I'm not sure. Mov R00X Uke. I haven't done assembly yet. Okay, it's time to turn on the oscilloscope and let's see what the hell happens, shall we? Let's do it. Boop. Okay, it's now time to probe analog output pin 0 to ground. So, it's a little hard to get a... I think it's... wait. Oh, you know what? Let's do it this way. Hold on. Trying to get the ground spring to go cleanly into the ground socket. There we are. Okay, nice. This is what it looks like. It's very, very, very clean now. If we zoom out, there's a whole lot of nothing going on. I'm gonna press the reset button and we should see something for a moment. Actually, you know what? I'm just gonna zoom way out. It's going to roll mode. Way out. Okay, I'm gonna press the button. Boop. What? Okay, something happened. Do you see that little spike there? There's a spike there. Let's set up a trigger to catch it, and then we'll have a look at it. Boop. Oh, hang on a second. What's going on? Why am I in such a slow mode? Boop. Wait, why do I see nothing happening? There it is. We need to zoom in way further, huh? Why is this not centered there? I'm gonna press it again. Would you look at that? Would you look at that? Oh my god, my hand is stretched. So we have, how many bits do we have? Do we have the right number of bits for a start? 1, 2, oh my god, okay, hold on. 1, 2, 3, 4. Wait, let's just use the cursors. I mean, I'm sure there's a way to count properly, but 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 4. We have 24 clocks. Yay! Okay, good start. Now how long is this entire, well, how long is one of these taking? My next question. Let's zoom in a little bit. Let's measure from, let's get another reading. Hold on, this is messy. Okay, let's get a reading from here, the moment that it turns on. Actually, we can get even closer. Another reading. Let's measure from here. Actually, I can zoom in a bit this way as well. Another reading. So from there to the next one along. Why am I measuring backwards? What is this? Okay, that's approximately 680 nanoseconds? This is really cool, actually. This is already within the realm of working. What the hell? I have an oscilloscope. Yeah, I finally bit the bullet earlier this year. I was able to find a relatively cheap one. And finally, having been thinking the one would be super useful to have for a long time, I actually bought it. And it's thanks to flipping generous, you know, subs and bits and just really kind, you know, generous people that I was able to. So thank you to everybody. It is thanks to you I bow before you, and is this up there is like the living symbol. It's not living. It's not actually alive, but the unliving symbol of generosity. And look, I am using it. I'm making use of it. I promise. Where are we? Where's the line? Go up and down. Great success. Hell yeah! And we did it quickly as well. We didn't dump the program memory by accident. I know, right? I was using pointers as well. Okay, let's have a look at this again. Get a reminder. Okay, so the on, if it's short, the on needs to last for a short amount of time. If it's short, okay, hang on. Effectively, we're outputting on bit 0, the lowest bit of the port, this value. So effectively, on all other bits on the port, we're outputting zeros all the time. But I'm only probing this one bit actually, so this is irrelevant. So we actually want this bit to last a longer time than it is. We want this bit to last about, well, 580 up to 1000 nanoseconds. And currently this bit is lasting, my computer's dying. My bit is lasting like 250 nanoseconds. Wow, we are way ahead of schedule on our timing. Holy crap. This is cool. This is good. It's much better to be fast. I mean, it's not gonna work, but it's like we've got more room to play with, you know? We've got more space. Unlike in my taskbar where I'm having to close stuff because I've got too much crap open right now. What can I close? I don't even know what I can close. This one can go, I guess. Okay, so let's work that out. So it's somewhere around 250 nanoseconds. Let's see how many CPU cycles this actually is. So one CPU cycle is 62.5. Oh, what the fuck? Okay, it's literally 4 CPU cycles. Okay, right. Huh, nice. 4, not even point something. I wasn't sure if I was correctly measuring the 250. I was just rounding down to a number that looked like the closest. Multiple of 10 nanoseconds. Okay, nice. And interestingly, this is a really interesting part. This part here, where we're going off, this is lasting 400 and 40 or something. Thank you for the follow, Slime Swallow. Welcome, welcome. And silly scope. Yeah, it's perfect for me. And yes, the bits are banging indeed. See, I joined late. What is this component being analyzed? The Arduino. This is the result of our program running on the Arduino. We're trying to clock out data, very quickly and stuff. But you need to get a very precise timing. Why the fuck you got to sub to this channel? Probably because the other day, I was doing like my 3-year streaming anniversary, birthday stream, like simultaneous birthday and streaming celebration stream, and there was some people going a little crazy with the gift subs. Much appreciated it. Oh god, I just bumped the scope out. I need to read it again. So yeah, I think you might have got caught in the crossfire. There we are. Do you work with ESP32? I think I've used it once in my life. Not really. This is an Arduino Mega I'm using now though. Much love. Thank you. I do have a scope analyzer fast enough for this. This is fairly entry level. This is 100 megahertz scope. It's not crazy, like we're not into gigahertz here. The Arduino is just not that vast. It's a 16 megahertz CPU, so yeah. I think, yeah, a 100 megahertz scope is okay for this. If you're interested in what the scope is, I'll drop a link. But by the way, this is not sponsored, but since we're talking about it and you're asking, it's This one. There you go. Nice one, Sly. Yes. I feel like I've seen this one in a bunch of other people's videos as well. But, I think it's like the new car phenomenon though, where supposedly if you buy a new car, you notice that car suddenly everywhere after you've bought it. I don't have a car. I am not rich enough to have a car. This, I mean, I'm not needing a car either, so I prioritize the oscilloscope over that. I'm not rich enough. So the oscilloscope is a one-off cost. The car is constant tax and petrol and everything, so you know how it is, maintenance. Anyway, I think that's the same scope I have. Yeah, but I've noticed it in a bunch of different things is what I was trying to say. Hi, Linted. Welcome. And I think I've only noticed it in a bunch of YouTubers' channels after I got one, and then I was like more curious about, well, what are they using? Oh, look, it's mine. I recognize that knob layout. I've seen you driving. That's true. I think it's safer for other people to not... for me to not be driving. Anyway, alright. If I were to do this in, hang on a second. What are we trying? Oh, wait a second. I didn't even turn off interrupts. Look, so the things on the scope here, look, this spike and this one, these are longer. And look, this one is shorter. And these are both meant to be the same value being clocked out. And I'm pretty sure it's because I haven't disabled interrupts. So whatever the fuck is set up when the microcontroller turns on is firing every now and then in the background and just making things inconsistent. So I'm going to disable interrupts for a moment. We're going to clear interrupts. I'm actually going to treat that as if it's a block. And then we're going to turn on interrupts again afterwards, even though that's the end of the code. Whatever. Okay, let's upload. And it's going to run again. There it is. We are still getting different length pulses. It was not the interrupts making them different lengths. Huh. Hi, Automagician. Welcome. You have it as well? Oh, hell yeah. Is a mod available? Yeah, I've heard of it. I've heard about it. I have heard. I haven't done it yet or ever, because no one would ever do such a thing, surely. But I had heard about it. Why am I not getting another reading? Oh, because this thingy fell out. Oh god. What is this? Why can I... This, I'm not getting a very good connection with this spring for some reason into the ground thingy. SCI, delimited code blocks. Yes. That's the reason why I bought mine. Oh, you have... yeah. Everyone has one. Holy crap. Holy. Why am I not getting fucking... This is bugging me. I chose the pin really close to a ground pin so that I could probe into the ground with the spring easily. I'm not getting a connection to it. I'm having to flipping poke it to get a connection to the ground pin. There we are, okay. Let's try again. Why are they all so wildly different sizes? Also, towards the end, there should be pulses that are less long. There should be like 8 slightly wider pulses, and then 16 less wide pulses. Am I being silly? Am I probing the wrong thing? Oh my god, where is it? Here it is. Analog 0. I'm probing this. So this is bit 0 of port F. So I should be probing the right port. The right pin, sorry. Short pulse, long pulse? Exactly, Cabbage. Exactly like that. Hold on, I'm trying to show it for the benefit of the archive. how do you get the physical control on PC? I use the web interface. It presents its own web interface, and then I just have a browser source on OBS. Thank you for the follow, Automagician. Yeah, it's just connected by Ethernet. Then you can just access the page. And hang on, let me show you actually. Let me show you. It's yeah, ta-da! And you can even pop out this, and it zooms in for some reason. What the? Why is it zoomed in instantly? Does it zoom in every time? It does. How annoying. Anyway, these buttons like actually do things, which is pretty cool, and it controls the thingy. And then I just have that cropped down on the what's it? On the source on OBS. Which is very, very, very nice. Thank you for the hydration, the posture check, Oxim. Welcome, welcome. Thank you for the pants, Stu. And Otto. Alright, so I think what I'm gonna have to do is start learning assembly. Yeah, because I need actual control over really what's happening and like inserting null operations. Or no operations? Nops? Is this short for null operation or no operation? I think it's no op, right? I mean, well, who really cares, right? It's doing nothing. With the inline assembly thing. Yes. That's what I would like to do. Exactly. No op. Okay, cabbage. Thanks. Thank you. And we do. So this is all I need to do. I need to convert it into assembly somehow. So I need to have... So you could also call it... Nope. That's true, I could. I can't believe my taskbar is so full of stuff and I can't really close any of it. Underscore ASM open bracket. Okay, I kind of... Where do I even begin with searching for this? Arduino... ASM... How to use assembly in Arduino? I don't think this is... Yeah, this is not inline assembly, this is like something else, right? Inline assembly. Hold on. Hold on. Oh, I gotta be quiet. I think people are coming to bed at this time. Hold on, I gotta go into quiet mode. Where's my music? Here it is. I'm gonna quieten you down a little bit. But that's not gonna help me be quiet for other people, so let me just adjust my volume thingy. Then I can be more quiet. So if anybody's wondering, the time has just gone 10 PM, so people are gonna be sleeping now. So I'm changing some settings. There we are. Let's have a look. Where is OBS? My computer is just full of crap right now. I mean, like, my monitors are full of crap. Oh my god, that's so cramped. I'm sorry. It's really hard for me to keep on top of everything right now. Oh, you've linked to something. Okay. I just got this ready. I'll have a look in a sec. We you're writing this, use the keyword asm or underscore underscore asm underscore underscore. This feels kind of Python. Very Pythonic. So nice neighbors. Oh, there's actually people in the next room as well. So the room behind me. They're gonna be smashing on my door if I don't. But also don't actually want to disturb them, so yeah. ASM volatile. Oh, okay, this is like they've converted everything for blinking LED, even the setup here. Pin mode 13 output. Oh, they're using like a... Wait, is this like a macro in the middle of assembly? Something to work out which port of a pin something corresponds to or something? This looks incredibly cursed for just... Oh, DDRB. So I'm guessing what this is doing is forcing pin 5 of DDRB to be high. But why are they doing it in... Is there already another... Okay, whatever. I don't know if Pythonic... Gin tonic? No, not Pythonic. Pythonic. I get it. Ready on. SBI. Okay, what the fuck is SBI? And what are percent 0, percent 1? This does look incredibly cursed. Percent 0, percent 1. Backslash n, backslash t. Is this new line? And tab? Is that what that means? Why is there no tab here then? There's only a tab on the next line? Or what is this? I actually don't know if backslash t is tab or not. Call 1 second delay. Okay, so I'm guessing call is something that has a return. There's a return. I should have a look. I'll look at the actual link in a moment, Stu. Your one. LDI, LDI, LDI. I'm gonna need to know a lot, I think. Delay 1 second. Okay, so apparently I'm guessing this is loading something into some register question mark? Why does this make it delay 1 second? Yeah, I don't know anything that's happening here. Okay, let me just have a look at your link. Hopefully it explains it more. I'm guessing the other one would as well, but... Your link? SBI equals set bit in IO register. Thank you, Slime! Day dose of Valorant depression. Hope you have fun. The link only explains the C side of things. Okay. That's being made extra complicated due to being inline in a C file. Raw assembly is a little neater. Okay. I think I want it to be inline though. I don't have to do everything in its own blah blah blah. Thank you. Is this like, would this also work with like 80 mega 2560? Or is it just like everything that's part of... Okay, I'll have a look at that in a minute. I've lost the thing that I just had open. Here it is. Now I've lost OBS. Here it is. Nice. What a professional streamer I am. Constraint modifiers. I'm lost already. Oh wait, this wasn't the beginning of it. Oh, it kind of was actually. Thank you for the follow, Shy Assassin. Welcome, welcome. I don't even know what a constraint modifier is. I don't know what a constraint is. Let's start with this for now. Okay, let's have a look. SPI percent 0, percent 1, backslash n, backslash t. And actually, okay, what is what is backslash t? C backslash t. Escape sequences in C. That's amazing. Look at that. Found it. Backslash t is a tab. Okay, so they are just going onto a new line, then a tab. I'm assuming it, like, assembly is not actually white space sensitive. like Python and you don't need a tab. Hi, Kristan. I'm not doing too badly, question mark, I think. Check the first links in the first thing. It does have to be tabbed. Why are they only tabbing the second line on then? They're not tabbing the first line. Or the first line here either. There's like a tab on the new line. AVR libc, how to use inline assembly. Okay, let me read this for now. In this example, you use the ASM volatile. Volatile is essentially telling compiler not to mess with your assembly code during optimization, but the compiler might decide your code is unnecessary and cut it out. Okay. Like when you declare a variable. Thank you for the pats. As volatile. To avoid it being like cached in a register, because it could be modified and interrupt. Okay. Great way to wrap your head around is to dissect an existing, so let's do it. Okay. SBI is the set bit in IO register instruction. Oh no. I'm hoping you can set the entire IO register, which I assume is a port, question mark? %0 is replaced by _SFR_AO_adder. Oh! All of this crap is down here. I was seeing this and I was looking down below and I couldn't see like where the rest of it was, but I see. This is the stuff that replaces the %0 and the %1, I guess. This : space speech mark I speech mark space and this is not syntax I'm familiar with at all, NC, which is interesting. Yeah, it'd be interesting to know what any of that actually means. I wonder if that's in here. I guess I should look at one of the other links. Let's look at one of the other ones. I think I just clicked the thing I didn't mean to click. I know which one to look at, so I'll open them all. That's German and that's German. Yoink. I think we talked about this in a call before. Wait, talked about what? The : space, speech mark, letter, speech mark, space, something else? The assembly thing goes ASM. I have no memory of that, by the way, if we did. ASM. I've lost the page. Why have I still got the flipping oscilloscope up? It's blocking quarter of the view. Sorry, I forgot that was still there. ASM thing goes ASM. A bracket, yep. Code, yep. : outputs, : inputs, : clobbers. Okay, yeah, no, that's definitely not something I have any memory of at all. I doubt that was with me. So outputs, inputs, and then there is no : for clobbers. But the outputs input clobbers thing basically indicates to see what registers are used as outputs, what are used as inputs, and what just gets modified. That's kind of neat, actually. That's really neat. Since the assembly can do anything to the registers, C codes needs a way to keep track. Yeah. That is what I was wondering about how you're even able to put assembly in C, because I know C is going to want to be using the registers. This makes sense. So you have to specify it. Oh, that's kind of cool, actually. You just literally tell it what you're going to be touching. And I guess you can't assume what the contents of the registers will be at all, right? By the time when you're beginning. 0% 1 are like placeholders. past the colons. Yeah, I see that much. Because outputs were empty, the inputs were prefixed with colon. Right. So, and there is no clubbers, so the last one's emitted, I guess. I guess you can emit from the right hand side. There's nothing used, like if you only had outputs and no inputs. You just put colon outputs there and then nothing afterwards. I don't know what the point of such code would be, but since 0%1 is taking those specifiers and putting them in the code, you can, because on the input part there are ways to specify the values. Huh. Right, so this is not part, right, this is not even part of the assembly. Yeah, this is outside these quotes. Okay, so this is just a C macro, I guess. Or function. Okay, so LED on, so SPI %0% 1. So this is going to be SPI port 5 on port B, I guess. So set bit, so we turn on bit 5. Call 1 second delay. 1 second delay does this. I have no idea what this is, how this is working. Oh wait, that's not even it. This is where it actually. Oh, for fuck's sake, they're just separating it. Okay. 10 times ran this loop equals 1 millisecond. Okay, they're just burning CPU. Okay, I see. I guess. Okay. And then LDI, I don't know what that means. If you have 2 string literals in sequence, that becomes a single string literal. Yeah, I do remember using that once. I went like basically almost all my life without knowing that until very recently. Which is something you probably know already, but it's used very heavily. Okay, that's very useful actually. To be reminded about that, thank you. 1 second delay goes all the way down to the return, yeah. This is where indentation would help. Although I know that's not standard in assembly, right? It's all line labels and stuff. But for my C coded question mark brain, it might help me understand more. Okay, let's have a look. Void loop. The LED is turned on, waits for 1 second, turns off, and waits for another second. Cycle repeats. This one sets bit port to high, which turns on the LED. Then call this for 1 second. Then clear bit 5. Call 1 second. This relative jump command jumps forward to the exit point marked with 4. Wait, what? I thought it said this loops. Oh, right, it's in the loop. Yeah, okay, so we need to still terminate the loop function itself. Okay. Relative jumps. Is that significant? Is it because it's like faster to do a relative jump than like an absolute jump? Is that why they use relative jump? Because is it like that you can jump a certain distance ahead, like you know, like up to 255 bytes, for example, something like that. I wonder, or instructions or something. Read and check. Yeah, I should do that eventually. Let me just get through the rest of this. I'm curious about what this is doing. What it's doing. The 1 second delay creates a delay of approximately 1 second, encoded with less bytes. Okay. Right, so I see. The registers are 18, R20, and 21. I wonder why they chose those ones are initialized to 0. The subroutine runs 2 nested loops. In a loop, 2b iterates 400 times. Where's my music? There it is. I'll turn it down a bit. For concentration. In a loop, 2b iterates 400 times. In the outer loop, 1b iterates 10 times. The set of 400 times. Did I say 100? I meant 400. The set of 4,000 iterations is performed 1,000 times. Okay. This poor CPU is capable of so much more, and all it's doing is wasting time. I feel bad now whenever I use a delay. Sheesh. LDI, L24, L08, 400, blah 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 blah. Wait a minute, is this? Oh, this is the literal text. Okay. Low 8, 400, high 8, 400. Is this just like a macro to get the lower 8 bits of a 16-bit number or something? And the upper 8 bits, like the... Send you a screenshot. Okay, thank you. In short, yes, our jump is faster. 2 cycles versus 3. Okie dokie. Nice. Can you jump backwards with a relative jump? I should stop asking all this. I'll look in the flipping PDF eventually. These load the low and high 8 bits of 400 into R24 and R25. Okay, nice, it does. I should fucking read before I ask questions, I swear. Oh my goodness! Meteora! Meteora! Hi! Welcome, welcome. Thank you for the hydration center and the posture checker center. Welcome. And welcome in Spike. Welcome Pomba. Welcome, welcome. Hi, Meteora. And a waffle that is frozen. And Johnny Paimon. Hi. Oh my goodness. Hi, Irina. Welcome. Ending. Hi, Crazy Games. Welcome, welcome. We got 2 crazies here now. Hi, Olam. I heard rumors of food and I'm compelled to investigate. Nice. Enjoy that food. Hi, Eurobeat as well. Hi. Thank you for the flipping follow, Crazy and Jenny. Welcome, Crazy Johnny. Sorry, I'm combining names. Let's sprinkle some magic on those LED strings. Thank you. I'll take this. I'll take this magic. Double raid? Wait, double raid? Double raid? Wait, double raid? Double raid? Or like one went into you and then you went into me? That's very kind. Hi, how's your stream? I will hydrate in 1 sec. I just want to shout you out first though. Meteora. We narrated Meteora and then we raided together. Nice, that's very kind of you. If you're wondering why I'm talking quietly, it's because the time right now is it's nearly 10:30. It's nearly 10:30. And people are trying to sleep in the room behind me, so I've also just been instructed to hydrate by a center. But yeah, how do your stream go? I need to shout you out. Raided while preparing for raiding. It happens. What are you up to? Let's find out. Wait. How have I never checked? This is an adorable avatar. Have I not been checking? I need to flipping check you out. Look at this. It's adorable. Karaoke time with a new layout. Wow, you are the second karaoke raid I've had tonight, which is very interesting. Some brain rot, but not too bad considering I read most of my code. Some possessed floor and some brain rot. Wait, was it actually not a karaoke stream? Is that a previous title? I've had this logo for 5 days now, so that's why I haven't seen it. Ah, okay. I see. Guess people sleep late around me actually. That's lucky of you. I hope you went well, and I hope the redoing of code was successful. I'm a weird cat. I should introduce myself. Hi. It's me, I'm a weird cat. And I'm trying to learn how to do inline assembly in C for the Arduino AVR assembly. For the very first time. I've never even done any assembly before. So yeah. It was meet? Just singles with the voice of an angel. Why is angel like this? Why do I feel like you're meaning biblically accurate angel? The voice of an angel. One second, I have to do a... There you go. That was a pretty good quiet nyan, considering I'm having to be quiet. Biblically accurate weird cat. And yeah, the reason I'm doing this is because I've had an idea for how to completely. Oh my god! Thank you. I appreciate it. I'm glad you appreciate the Nyan. Yeah, the reason I'm doing this is because I had an idea for a way to remake the circuit board. That I made before, and I don't have the file open anymore apparently. Let's open it again. That is for a display. Basically a huge LED display that we made out of 4 parts. And couldn't even see that line I was drawing, amazing. And it just shows what's happening inside a MIDI file as it plays, and there'll be these little bar graphs. And yeah, the top ones are longer than these ones because I've started updating the drawing, but I've only done the top row, not the rest yet. I haven't even finished the top row yet. Once I've done the top row properly, it will probably become 5 wide instead of 4 wide. Then I'll copy and paste it to the other rows. You're looking at something mid-update right now. Anyway, I just had an idea of how to... I had a prototype of this board made. It didn't work though because I made 2 big mistakes, or 1 big mistake really. That stopped it from working. I made 2 mistakes, so anyway. Here are the boards they were made. They looked cool. It's really nice to see them in the flesh. Not that they're made of flesh. But they don't work. So I've had an idea for how to completely remake it in a cheaper way, which will also be better because I can control the brightness of every LED. And to do that, it's basically gonna just mean that the LED display is a very oddly shaped string of LEDs. You know, like an LED string that you literally is just RGB. Thank you for the follow, GGXP. Yeah. And that means I need to send in data to the drivers of the LEDs, and to be able to do that with accurate timings, I need to be using assembly basically, so that I have control over exactly what the CPU is doing. And thanks for coming to my TED Talk, that's why I'm trying to learn how to do assembly. So I need someone to explain to me the C++ basic till Thursday, so I might just stick around for a bit. Oh, this is, I would say this is not basic. This is like when C doesn't let you go low level enough. RTOS? Isn't that like an entire operating system? Is that right? Isn't that real-time operating system? Best nylon 2024? No survey. Thanks. No survey. In order to understand C++, you must first understand the first 50 years of computer science. Maybe a little bit. The C++ library for real-time. Huh. Interesting. I mean, like, C is already running in, like, real-time. I mean, the Arduino is doing nothing else. It's not running an operating system, which is nice. Like, I don't need an operating system. It's just that, I need to know exactly how many cycles every instruction that I'm writing is lasting. Which is CPU dependent. So that's not like a thing that's built into the C language. Well, it's not really a thing that's built into assembly either. You need to look at the instruction set details and stuff and see, oh my goodness, this is a very long document, 162 pages. And then that should tell you how many clock cycles it takes. But I have an oscilloscope to measure how fast it actually is being as well, so... Anyway, I'm just reading through this example about how to flash an LED with 1 second gap between on and off. And it's explaining every little line. These load the low and high bits of 400 into R24 and R25. Distort OS, object-oriented real-time origin systems for microcontrollers. Yeah, no. That's hugely way more than I need. To give you a perspective, this is the entirety of the code that I need right now. But I need this part to be done in assembly so that I can sort of pad out certain parts with NOPs, no operations, in order to make the exact timing between certain bits be correct. So that way, I need that is so that I can have the correct timing between bits to these blah 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 blah. Here's the drawing. Ta-da! I'm sorry. Just so that I can have this and this, and this, and this be the correct length. Because these are super tiny durations, less than 1 microsecond. There is a delay microsecond function in the Arduino libraries, but that can only be accurate to multiples of 4 microseconds, and we're needing like nanoseconds here. Nanoseconds, son. I'm using this Chinese datasheet because this one's actually printed correctly and doesn't have an error in it like the English one does, so... Just for this table, there's a typo in this table in the English datasheet, which is not great. Anyway, let's keep on working our way through this. Can't you just take a snapshot of ticks till startup in each loop you call it and compare that? I think I know what you mean, but no, this would take way too many clock cycles. 1 clock cycle is 62.5 nanoseconds. So let's say call it 63 nanoseconds for having it in your memory more easily. And these need to last... like that kind of nanoseconds, like 4 or 5... Oh no, sorry, yeah, whatever, on the order of 10 clock cycles. So no, this is far too many. That'll be far too much. So I need to actually know... I want to control the CPU directly, basically. Make it do exactly the instructions of the correct length and stuff. Okay, let's work our way through this still. These load the low and the high bits of 400 into R24 and R25. This load into R24 the low bits of 400 and load into 25 the high bits of 400. My computer is actually dying. Sorry about that. This is gonna keep happening. Probably. My computer has recently been getting really fucking bad. Like I'm not even doing anything super intensive, and it's probably gonna blue screen soon. What are you doing again to need that sort of latency? Just bit banging, like controlling with software the timing of data that's being sent to LED drivers. Okay. SPIW, no idea what that means. Subtract, apparently. Sub. Something, maybe integer? Something? This subtracts 1 from the 16-bit word. Okay, probably is integer then. The 16-bit word that's stored in R24 and R25. Ah, right, okay, so we store the low and the high. And we subtract 1 from this low and high pair. Okay. Branch if not equal, I assume that means. Branches back to the start if the result of the previous operation wasn't 0. Okay. After the loop is run 400 times, R18 is incremented. Right, because this is going to go around 400, and then it's going to subtract 1, it's 399, 398, 397, all the way down to 0, okie dokie. When R18 reaches 10? Oh, sorry, after it's run 400 times, R18 is incremented. When R18 reaches 10... I feel like I'm skipping over a bit here, hang on a second. 18. Ah, here we are. Okay, so this is branch to 2B. What's 2B? 2B. Wait, why does it say 2B? What is 2B referring to? Does it mean 2? Or do you just put a B at the end of a label? Okay, why 2B? This is labeled. This is called 2, but does it mean 2B? Okay, whatever. I hate that you actually sort of understand this. Why? Why do you hate it? It's cool. It's cool. Okay, so this is looped. We've subtracted and then branched, then subtracted and then branched, subtract, blah 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 blah, and eventually we continue. And we increment the value in R18. I'm guessing that is compare integer. So we're comparing the value stored in there to 10 and branch if not equal. So if this is not equal to 10, Then we're branching to 1 B. I don't know what the B is all about, but where we reload 400 and count down another 400. Okay, I actually understand this so far. So far, I understand this. Thank you for the follow, Reddits. Welcome, welcome. Also, brick 3F and jump 4F. Yeah, what does that mean? F could mean far, but then, I mean, the opposite of far would be near, so you don't spell near with a B, otherwise you get beer. Or bear, I guess. I miss Long Nuke. Like, she needs a little bit of a rest after that stream, okay? Ah!
Cheese.
Why cheese? I'm caring for her right now. Don't know the nuances, but it seems like the F and B are forward and backward. Oh! Nice! Okay, okay. Yeah, that makes sense. I don't know why you need it, but that makes sense. Okay. What would be really nice is if we could give like labels, but not numeric.
Jeez.
Shh, stop. Why is Aaron's avatar not working? Why is Aaron's avatar not working? Thank you for the pats. I'm gonna dive into this for a second. Sound. Redeem. Let's emote. Redeem. Cheese. Speech. We've got all of Aaron's sounds here. We've got Aaron's avatar. Oh, it's a fucking... Why is it JPEG? Okay, let me just save this as a PNG. And then we'll hopefully get Aaron's avatar to appear. Sure. Sure. Okay, I think I need to restart my streaming setup for that to take effect. 1 sec, I'm gonna disappear for a moment. I'm coming back.
Nyan.
I'm back. Okay. Hopefully now, if cheese is thrown at me and Aaron's sound is chosen, we'll actually get Aaron's avatar now. By the way, when someone throws cheese at me, a random cheese sound is played, and all of those sounds that you saw are donated. All of these sounds are donated by these kind of viewers, plus like some anonymous, like ones that don't have an avatar. And so, these ones are just TTS ones, but whatever. So, if you'd like to have a chance of a sound file of yourself saying cheese or a line similar to it, then you too can donate to the most important database of our times, the Cheese Sound Database, by just sending me a recording of yourself saying that if you want to. Okay, bye, that's it. Hi, Erickson. Could have something to do with the label being only a number? Maybe, otherwise just number would probably be considered an immediate instead of a label. I wonder how it would even interpret that as a thingy, I wonder. Why they chose to use literal numbers is certainly a choice, right? Okay, so we're branching from not equal to that. Otherwise, once this reaches 10, we continue. Let me just keep on reading this and see if I understand what it says. Subtract. Oh, I know this is different. SBIW. SUBI is different. So SBIW is subtracting 1 from the values stored here. SUBI. Could it be that the W means wide? Because it's 2? And sub is just 1? In that case, yeah, because 0xFF is an 8-bit value. So then this would subtract... Wait, no, this doesn't make sense. Does it would subtract 0xFF from 2? Okay, no, I don't know. Let's find out what it is. I was trying to read it by guessing. I don't know what it is. What is it? It doesn't explain. Interesting. There. Subtract immediate. This command subtracts a constant from the contents of a register. Okay then. Subtract immediate with carry. Subtracts the constant and the carry flag from a register. Okay, this is gonna trip me up. This carry flag thingy. CPC, compare with carry. This command compares the contents of 2 registers and considers the carry flag. I guess I'm not really understanding this concept of carry flag. branch if equal, I guess that much, and return goes back to where we were when you did the call. Okay. Alright. Well, using just this information, let's start to set up a thing in here, shall we? Word is also 2 byte though. Oh, word, okay. 2 bytes for a word, okay. Thank you. I stands for immediate. Oh, okay. Okay, so instead of this, if you wanted to convert this, I kind of want to try and do this myself rather than be backseated though. I know no one is yet. So assembly and volatile and open bracket. And then we start a thing. So essentially we don't need to do this first. So let me make it so that we do... It doesn't really matter which way around we do it, does it? I guess it does actually. I guess it does matter. Let me rewrite this in a way that we do the check at the end and see, so it's easy to translate. So we could do this while this is less than or equal to this, but we need to do while it is. No, this would still work. This will still work. This will make sure that it executes at least once, but that's fine. We're definitely always going to have at least one LED in a string. Why is this an or equal to blah blah blah? Yeah, that should work.
Jeez.
There might not be a way to... I don't know if there's a branch if less than or equal to... I can't remember. Help!
Post.
Why? Thank you for the hydration, Oxen.
Cheese.
Not supposed to check. Why suddenly cheese? What is this? High trade splatter. Okay, that explains it because of the splat. Trade splatter living out their name. Done this sticky cheese that like slides around my head, especially when I lose tracking like that. Posture has been checked as well. Okay, so the first thing we're going to want to do is output to a port, and what they're doing is using an instruction that is pretty cool that exists, which is set a single bit in a port or IO register as they're calling it. But I actually want to set the entire IO register. So I think at this point it might be time for me to have a look in the... I need to call it a datasheet. The list of instructions. What is available? Let's have a look. Bye-bye, Meteora! Bye-bye, take care of yourself. Thank you again for the raid. Let's see what's available. Register. Direct. Single register. Register direct 2 registers. Oh wait, this isn't register like... port. Do they call it ports in here? Customer sub port. There we are. Clear bit 7 in port D. Huh? Bit 7 in port D. 0x12 relates to port D somehow. IO register, IO register. CBI. I kind of don't want to just clear a single... Okay, they are calling them IO registers. Alright, let's keep our eyes peeled for the words IO register. Branch? Okay, let's have a look at what branches we have. Branch if less than... Okay, so we have branch if less than... We don't have branch if less than or equal to. Okay. We don't have if less than or equal to. That's fine. That's not hard to change. Branch if lower. Wait, what's the difference if between branch if lower and branch if less than? I want to read about this. What's the difference between low and brolt? Number of clocks is 1 or 2, either way. Branch if lower. Branch if less than. Signed. If S is equal to 1, then PC. Wah? I'm guessing PC is program counter? Maybe I should be jumping into this halfway. Maybe there's an explanation about this somewhere. I don't know where. Yeah, one is signed, yeah. Okay, in that case, we'll change this to be after. So this is the first byte afterwards. We'll just make it that, and then if less than that. Okay. So that would let us use branch if lower, unsigned. Capital letters are the CPU status register. They are set by the previous instruction. Was it the S? The S thing? This is making me think of shift register. But I doubt that it is. Load an IO location to register. Store register to IO location. Wait! This sounds like what I want. And it's out as well, my beloved out, which I was using in DOS and C though. Right, how do I... Okay, which flipping... Why do they not make them links? PDFs can have links into the same thing. Out is on page of what? Oh my god. Case sensitive, whole words. That should help. Oh, there it is. Out to IO location. That sounds like what I want. One single clock cycle? Sheesh! Wait, I don't know what AVRE, AVRXM, AVRXT, and AVRRC are though. AVRE. What are any of these? What is AVRE? Let's see. AVRE. AVR instruction set extended with the move word. Okay, I need to look up what the flipping at Mega 2560 has then, which I'm guessing is not in this document, but let's just search anyway. Oh, there it is. Oh, okay. AVRE plus. Nice. Okay, AVRE plus. AVRE plus. AVRE plus. Huh? Oh, right, it's not case sensitive. Extended with the multiply instruction. Okay. AVRE plus. But there is not a column for AVRE plus. So... that's not very useful. I guess we just use AVRE. And... you know... oh yeah, same time as AVR and AVRE plus. Okay, AVRE. AVRE is what I look at then. Okay. So, out, case sensitive, whole words. So I'm guessing what I'll need an out. I'm just gonna start writing down some of the things I'll need. I'll need out, I'll need branch, if lower, I think that's what it was. Unsigned. I'll need something to increment a pointer. One that just INC. Adds 1 minus 1 minus. They could have written that in a less complicated way. To the contents of register RD. And let me keep reading. The mind is woke up this controller. It is! Dumb, not dumb. Pat nymph. Pat, you know what? You know what? Pat. There you go. You get free pads. This is a medical emergency. I had to deliver the pads. You're in severe need of them. Thank you for the pads as well, Cabbage. Or the cats as well, Pabbage. But I'm guessing this is only going to increment a single byte? I guess pointers are going to be words, right? Right? There's 16 bits, I think. So I guess we'd need something that can work with words. The C flag in sreg is not affected by the operation. The C flag in sreg. What the fuck is sreg? I need to look at what this is. Sreg. Sreg is showing up everywhere. Sreg. Status register. So C is the carry flag. Okay, the status register. Zero flag, the carry flag, zero flag, negative flag, two's complement overflow, sign, half, transfer, global interrupt enable. Ah, so I could just disable interrupts through assembly as well, instead of doing CLI, I guess. Registers and operands. D is a destination and source. Huh? Destination and source? Register in the register file. I guess that's like a list of all available registers? Source register in the register file. Result after instruction is executed. Why do they need to use single letters? This isn't maths. It's probably a way to auto-increment a pointer when using it. Oh! Okay. Well, that's really nice then. I mean, it's nice because it will be efficient if that's the case. I'll have a look anyway. Okay, so our main things so far are we need to output this value. We need to output whatever's stored here and increment this pointer. And then we need to output this. And somewhere between these, we'll put some no-ops to get the timing correct. And then we just do branch if lower than. Back up to here. That's literally it! That's the entire fucking assembly. Oh my god, okay, I'm starting to feel like this might actually be within my ability. Oh my, I'm actually kind of excited. Oh my goodness. I'm kind of excited. And we need like to put the colon thingy so that we pass in something. Control F on post increment. Okay, I wanna actually control F on dereference or pointer. Just pointer actually. Pointer. Memory space identifiers. DS represents a pointer to address in data space and a pointer to address in program space. Okay, well, that's gonna be in data space, I would assume. I'm assuming this is like progmem stuff, and this is like SRAM stuff if we're using more Arduino terminology. Thank you. No, thank you for the cheese. Oh, hi, Chaos. The stack pointer. There was cheese. Look at it go. Data indirect addressing. X, Y, or Z pointer. So something exists in data space. The operand address. I don't know what that means. It's the contents of the X, Y, or the Z pointer. In AVR devices without SRAM, data indirect is called register indirect. Okay, well there is SRAM on this one, right? Right? Static RAM? Wait, how can you have a thing without static RAM? Wait, what do you have if you don't have static RAM? Dynamic RAM? Or just like external memory? I'm pretty sure this is built onto the chip though, isn't it? I'm sure the 2560 actually has the RAM on it, surely. Surely, she says. Data interact with pre-decrement. Well, this is neat. Next we have the pointer. We add -1. And then we do this infinitely. What? Post increment. Post increment is what I want then, right? Post increment, like you said, Jockibber. Data interact with post increment. The operand address is the content of the X, Y, or Z pointer before incrementing. Operand address. So I assume what this means is what you're going to read is the contents of this pointer before it was incremented. So in other words, what that point... Yeah, okay. Data interact with displacement. Oh, no, wait. Is this the way that you can increment it by a custom amount? The operand array is the result of the queue displacement contained blah 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 blah. Oh, I guess this is like for accessing members inside a struct or something. This would be the pointer to a struct, and then this would be like the offset of one of the variables inside the struct. I don't need that right now. Or probably ever in this project. Program memory, constant addressing. Okay, we're not doing program memory. Offsets without changing the pointer. Right, okay, that's the significant thing, yeah, because we modify the pointer of this, yeah. Okay. So we want data interact with post increment. Doesn't actually tell me the instruction for that. Add without carry, add with carry. I'll have a look at that later. Let's just search for increment. Increment. Load, indirect, and post increment. That's it, right? So you put a plus sign after the thingy to show that you're post incrementing it. So LD. LDI load immediate and LD load indirect. This is, I like this minus x and x plus. This is very intuitive. What's the difference between y and, or y plus, I guess, and x plus, I wonder? Are x and y like the registers that it'll get loaded into or something? I guess. Which specific Arduino are you using? The Mega 2560. 2560 being the at Mega 80 Mega. So I guess I can just use X? Question mark? So I said X, Y, and Z when I was looking through here, didn't it? Z pointer, X, Y, or Z pointer. Is this just a way that you can... Is this just where you like store the pointer value? Something? I'm really confused. LD. Anyway, on LD. RD. 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 RD was one of those, here it was, destination and source register. XYZ indirect address register. Oh, it's just one of the normal registers. Why are we like confusingly giving it a different name? Maybe it's not that confusing, I don't know. So I need to not touch these two registers is what I'm seeing. And the ones that I'm... So what do we touch? We are touching R27 to R26, which is also known as X. And RD destination? Is that right? Or is RD just a placeholder? Is RD just a placeholder where you specify which register you want it to go into, I wonder? How is this done in here? Oh, here we just loaded a value into the thingy, didn't we? We didn't, like an immediate value, we didn't load from outside. But we did pass in this value. So these are the inputs, and this is what is clobbered. I guess RD is a placeholder. Okay, and outputs, we don't care about the output at all. I mean, we're not outputting anything. I mean, we're outputting over a port, but we're not storing anything in RAM that we care about. Just modifying the pointer, which will be reset up the next time around. Okay. Okay. ramp XYZ. Registers concatenated with this. Okay, yeah, no, we don't need to worry about any of this, I think. So wait, we can specify our own. Are there like any examples in? Oh, there are. Okay, let's see where load is used. LD. Case sensitive, whole word. Load indirect from data space. Oh wait, there's a proper flipping description thingy. Loads 1 byte indirect from the data space to a register. The data space usually consists of the register file, IO memory, and SRAM. IO memory. The data location is pointed to by the X pointer register. Memory access is limited to the current data segment of 64 kilobytes. That's fine, we've only got 8 kilobytes to work with. To access another data segment? No, that's fine. X pointer can either be left unchanged, or it can be post-incremented or pre-decremented. Yeah, it's super nice. Super nice. Okay, let me just start penning what I believe I need to do. Out. Store registered to IO location. What I'm realizing is that in the Arduino these are known as ports A, B, C, D, E, F, etc. But here you need to give a number. Stores data from register something in the register file to IO space. Syntax out A, comma. Oh wait, no! A! Okay, no, you do specify with A. Okay. Can you literally just write the word? Oh no, never mind. A is a number. So we need like some mapping of a number onto a letter. The AVR PDF does have a table of content of its chapters that might help. Yeah, maybe I should have a look at that. I'm gonna keep searching for port though. Oh, nothing was found because case sensitive. Port B. So 0x18 is port B. This is interesting. They store a value of all zeros in there. And they store a value of all ones in here. Oh! Do you have to store right, you can't output an immediate value, can you? You have to store whatever you want to output first. That's interesting. Arduino headers just has definitions to the memory addresses of the ports. Sounds interesting. Port B. Port D is apparently 0x10. Oh, is that not what it is? If bit 0 port D 0. Thanks, Stu. I'll do that in a bit. I need to concentrate for a moment. I'm sorry. Thank you for the pants. Welcome back. Was your food nice? Clear but 7 in port D. So port D is apparently 0x12. Where is this? Where is the mapping of ports to whatever this is? Nothing? Do I need like a specific datasheet for the 2560, I wonder? How are ASMs the ASMR cat? It's not too bad, thanks. I'm kind of needing to find out how to convert a port letter into a port number that's needed in the instruction. In the example here, they just say port B and then this, but I can't see a table that maps letters to numbers. I'm guessing it's going to be in the 2560 thingy. This PDF is just about the instructions, yeah. I'll find it, don't worry, I'll find it. Nah, let me find it. Nah, you've been doing everything, let me find it. Here we are. ports. Register definition. Hi, Brillan. Thank you, thank you. I'm glad you find it a chill stream. Oh, thank you for the follow as well. Port A data register. Welcome, welcome. I will save the kidneys in a moment, Stu. Data direction. Okay, so 0x22. Ah! So when I say output... Well, let me just double check this works. In their example, they were saying the port B is 0x18. Port B is 0x25. Oh, wait, that's data... No, it's correct. Wait, there's different things. Hang on. It's data register, that's not pins, though. It's 0x18. 0x18 is... nowhere to be seen. What CPU is that for? Yes. Oh no, are the sections completely separated? How do I know? The example you're looking at? Oh! I have no idea. No idea at all. I couldn't... yeah, I don't know. I don't know. So basically I could use the out command and essentially output to something named DDRA world 0x21 to set the data direction register and then output to 0x22 to write to port A, I guess? I don't quite understand what this means. 0x02, 0x22, 0x01, 0x21. And you've got input pins as well. Oh wait, no, it's the same. There was something else. I forget what it was. There was another thing on Arduino. Like you have port A, DDRA. Oh, was it? I guess it must be pin A. I don't remember using that. I do remember it being different when you're trying to read input rather than output. If you need to only set or clear one bit, I don't. I need to write the entire port. That's the reason I'm doing it this way, because it's fast. To do it this way. I mean, it's 2 cycles we discovered last time, I think. I can't remember, maybe it's not. Okay, I'm gonna go and save the kidneys and I will be right back. Friendly reminder to anybody, if you need to go to the toilet, do it. Take care everybody, it's okay, I'll be right back. Pew! Yeah? I've returned, hi. Welcome, welcome. Wait, no, why am I saying welcome? I mean, hi. Hi is what I meant to be saying. Hi. Okay. So, in these thingies, you know what? Maybe I should have a look in the hardware definition of the ports as well. I'm sorry there's the sound of my scope when I'm talking in the background. If I do this, I lean back, maybe you can hear it more. Or I just move the mic closer to it. I have to tap the mic so that it opens the sound gate. Yeah, it has a fan that's fine. It's an okay volume, but when I'm having to speak quietly, it's noticeable. Alright, where is stuff stored? Tools, AVR? No, where are the... Hardware serial? Hardware.h? Is this where it's stored, I wonder? Oh my god, I can't drag a file on there. There we are. Here, question mark? No. Where would it be stored, I wonder? Let's see. Binary... Wiring? Question mark? Digital? Perhaps? Wiring? Question mark? Maybe it's in there? I'm a little bit scared about what's going to appear. It looks like it's been modified immediately. That looks like it's been modified recently. Thanks, Dara. I was proud of it as well. Oh, wait, these are C files, not the header files. Star.h. Wiring _ private? No, none of that. Somebody earlier found the... screw it, I'm just gonna search every fucking .h and .c file for the word port. Well, actually .h files probably makes more sense. Lisk. How's the diary doing? Welcome in, welcome in. Welcome in .h. Port A. Start search. Boop. Wow, that was fast. Oh, did it even search subfolders? It did. Oh, right, this is just the folder that has it already. And it's found in udp.h. What the fuck? UDP? udp.h. Port A. Port A is not in there. I mean, it's in part of the word important. Found it, the to address thing. The to address thing? I'm not sure what you mean. To address thing. There's such in the entirety of this. This is more the kind of speed I was expecting. Oh my god. Port A is both 0x02 and 0x22 at the same time. Do you know where that's defined? What about hash define? If it's indented, this won't work, but... Oh my goodness. Why does it look like there are more results now? Fast pin ESP8266 SFR defs? SFR defs? When using the IO specific commands in and out, the IO addresses 00 to 3F must be used. When addressing IO registers as data space, as opposed to what? When using the IO specific commands in and out. When addressing... Why is my computer fucking dying? Like it's actually on its knees right now. We're doing the bare minimum. Like it's... I mean, it's apparently not. Well, wait a minute. Never mind. Actually, 4 cores are being absolutely destroyed. That's interesting. That's interesting. Let me have a check. Which one is that? Is live also on those cores? No, it's everywhere. What's on those cores? Is that the face tracking? Yeah, that's the face tracking. Interesting. What if I put those on those cores as well? Does that help? Nope. Does Face Tracker really need more than 4 cores? I mean, the individual processors are not using that much. How is it? I'm just gonna blame VC Face. Let's put VC Face onto 8 cores instead. Yeah, now it drops down. How is VC Face so CPU hungry? It's absolutely ridiculous. That's crazy. And it still only shows up as only like no %. Isn't that ridiculous? I don't understand what it's doing. It's just crazy. I don't know how it manages to bring every computer to its knees. Anyway. Yeah, I tried to make this... When I built this computer a few years ago, I was trying to make it super future-proof long killer. When doing normal memory stuff, you use the +21. Oh, okay. Interesting. When doing normal memory stuff, you use the +21. Wait, I just read that. For example, if you try to do a load instruction to read or write or store. When snack? I don't like how the hand tracking in Snack Studio looks. I mean, it's not Snack Studio's fault, it's MediaPipe, but it kind of tends to look very... kind of... you know... I don't know. Also, my webcam is actually too narrow a field of view to even be able to see my hands when they're on my desk. You can see my face, but basically +20 is the real address, but for use with in and out, it takes the fake address that starts at 0. Oh, okay. Oh, bye, blip. Oh my god, I didn't see. I'm so sorry. Bye, blip. They've probably gone already, but bye. No. I don't want to be a stream that ignores people. It's not on purpose, I swear. So 0x18, we gotta use the one that starts really low down. So we're looking for like a 1-8 low down. Is there a 1-8 in this example? No, it stops at 1-4. Oh wait, hang on. Oh, these ones are like extra high. There's only one value. That's interesting. I guess you come out to them then? Anyway, port F. We want port F for my code. Pine. Pin E. Register summary at the bottom is a bit table with all of them. Register summary at the, like, further down? Register summary. Oh my god, just go there. They put links here. Why do we have links to him in other places? Oh, this is nice. But wait, these are the bracket ones. Thank you for the follow up, Pleasant. Welcome. Porta is Portuguese for door. Nice. Scroll down. Down. C, D, E, F. Wait, where's port H there? Sorry, port F. Oh, there it is. Port F. Okay, nice. Oh, this is a useful table, man. Thank you, Stu. Yeah, right, Erickson? Okay, so 0x11 is where you want port F. So 0x11 is when you are... Wait, 0x11 is... So the zeros are the out. Okay, check the notes below. There it is! When using the IO specific commands in and out, IO address 0 to 3F must be used when you addressing registers as data using load and store. I guess that's what those mean. Choose 0 must be added. It is a complex microcontroller with more peripheral units than can be supported, with the 64 locations reserved in opcode for the in and out. Okay, I just need to know this in 0x11. Okay. So, if we go back to our barely beginning code, we would want to start by outputting to port 0x11. Actually, I need to look up the out instruction again. Syntax out A, comma RR. Stores data from register RR here. Okay, this has to be from a register, so we have to store it in a register first, which is why they do this. Okay. And they're using registers 16 and 17 as an example. So why the hell don't we do the same? We are going to need to write all zeros and all ones, so we might as well just steal 90% of this code, which is slightly, you know, slightly, whatever the word is, an underwhelming outcome. I don't know what the word is. Anticlimax. Considering I was going to try and do it myself. CLR and SER. I'm guessing that's set register, like as in all bits in register, and clear all bits in register. So R16 and R17 then. We'd use R16. Wait, these need to be lowercase, don't they? Okay, in that case we'd set... This needs to be outside the loop. So we'd do... Is this capitals or not capitals? This does... Lowercase. How unsatisfying. Oh, doesn't matter? Okay, nice. Is there a 0 register? I don't know. I'll have a look in a bit. For now, I'm gonna put in the code that they used. I'm gonna look up the instructions that they used as well afterwards. So we are clearing register. Oh my god, I can't on tab. I hate how Arduino IDE responds to all tabs. It's so buggy, so inconsistent. Oh my goodness, hydration in that already? I've only just gone. By the way, this is gonna be a brand new bottle of Nyan juice. Why is it not tracking me? This is gonna be a brand new bottle of Nyan juice. I'm gonna open it. I'm gonna try to keep it kind of quiet though, because people are trying to sleep, but here we go. Brace yourself for the opening of a brand new bottle of Nyan juice. Complete with the sound of an oscilloscope fan in the background. Wonderful. Oh, they fixed the bottling of the tonic water on this. The labeling of the tonic water, which is totally Nyan juice. It was doing the thing where, like, for a while they were saying that it was just like just tonic water without it being lemon flavored. But it actually was lemon flavored in the bottle. This is now plain again, which is nice. Okay, so R16. So clear register R16. I'll add like, you know, the ending of the lines afterwards. And set register 17. Can you have comments inside the string? They need to be outside. Oh, maybe you can, but they do the comments outside. Let's start doing this. Oh my god. And then we'll do the new lines. Okay, so, and then we want to do this before. So R16 is our all zeros. So R16 is all zeros, and R17 is all ones. Come and start with semicolon. Okay, thank you. I wonder, oh wait, I'm still holding mine and just going. I wonder if it'd be easier to have the comments as part of the string. Okay, so we set those, and then we want to output. So we're going to output to port F the contents of R17, which is all set. So this is simply port F equals R17. And then we want some gap, you know, nops here. And then we want out again to 0x11. Okay, this is where we actually want to put a value here. So I'm thinking it might be wise to preload the value that we want to send out, which is like the load indirect, or load, what's it called? Load data indirect from a pointer and post increment. This thingy. We might want to do that here, because between here and here and here, we need like pretty accurate timing. This at the end of the bit, if you remember, it might not matter this part. We might be able to be a little flexible with this part. So in case this loading takes too long, I'm kind of tempted to move it to the part of the loop where we've got more time free. Just, you know, it feels like good practice to do that, even if I don't need to. Okay, let's prepare a value then. So in that case, the beginning of the loop would be like right here. And the loop is just something with a colon, right? Here they've used this. I wonder if you're allowed to have something with a colon and then nothing on that line. Does there have to be data there? I'm sorry, does there have to be an instruction on the line, or can I just do a label? I wonder. Let's call this loop start, in case we can have it by itself. And here's where we want to load something. So this is where a pointer sits, right? And the data that was in that pointer gets stored somewhere, if I remember rightly. So we're gonna need to like store something somewhere else. Is there an R18? I guess there is. I wonder how I find out what registers exist. Register summary. 0x00, 0x20. That's the lowest one marked, so I wonder if registers below 0x20 are just like, you know, the working registers that you can use. Where would I find such a thing? Register. Register summary? I guess that's this again, no? Register. Surely that's not gonna make a million results. Why not just hold enter? General purpose register. Line page 36, and there's no fucking way to click again. 30s. Wait, is this page? I guess it's 36. Why is table of contents at the bottom of the fucking thing? What the hell? 36. General purpose registers. 0x2b bracket 0x4b. Wait, there are only 3 general purpose registers? I guess that these are not what I thought they were then. Oh, GPIO! That's not what I want. Register? I hardly know. Excel memory, general purpose, register description, line page 34, and overview 27 might be good on this time. External memory interface. What? I don't want anything to do with this external memory interface. Huh? Do I? This has got memory that's built in, hasn't it? Register description, page 48. Oh my god, every time I'm searching there's like something different every time. Register description. I don't think this is the right table of contents. Register. Power reduction register. Register description. Register description. Register description for I/O ports. Register description for interrupts. External interrupts. There's a register description for like every section it seems. Okay. Where's just the main... Like where... where are just the normal registers? This one I would assume? Page 13? At the AVR status register. General purpose register file. Sounds like I'm on the right track now. Here we are! Here we are! Okay. Oh, 0 to 2, 13 to 17, ... Wait, hang on, what does this mean? 6, 7, 8, 9, 31. X register low byte, right? Yeah, okay, so I won't touch any of those ones. Oh, these ones specifically. Does this actually mean 0 to 25? Or does it mean there's 0, 1, 2, 13, 14, 15, 16, 17, and then nothing? I wonder. General registers are located 0 to 0. 1F is less than 0 is less than 20. Wow. Or 32 I should say. You have 32 in total. Okay. Nice. In that case I'll use 32. Sorry, I'll use I'll use 18. 16, 17, and 18. Okay. So that means we want to load into... How is this done again? I think it was R18, comma something plus. I forget what it was. Let's see. Where was it? Load indirect from data space to register using index X. Sure. Ah, wait. This means I need to put... Hang on. Doesn't this mean I need to store something into X first? The pointer loads 1 byte indirectly from the data space to a register. The data space usually consists of the blah, blah. The data location is pointed to by the X register. Okay, so I need to store something in the X register first, and that's the pointer.
The models.
Oh my. Hi, Breeze. The dot dot is just omitting them for brevity. You have the full 0 to 32. Okay, nice. So in that case, I would literally type X plus. Yeah, I get it. No worries, Joker, but why? Okay, so in this case, so we need, before we do this, we need to put something, into the X registers.
Cheese.
Put something into the register. Although, no, we kind of want that to be loaded into the X register at the very beginning, like by the colon thing at the end. So inputs, we want R27 to R26 to be, which is X, to be this, the pointer. U8 star. And then we're gonna load the value stored there into R18 and increment the pointer. Then we're going to, this should be, yeah, sure. then we signify the start of a byte. A bit, sorry. Start of bit on all 8 LED strings. And then there's some knobs there, and then we want to send the value that we've actually decoded into R18 out here. So this is equivalent to saying port F equals R18, which is data stored at LED date. Well, that's basically saying this equals star LED data code. This is saying, well, this actually it's more like it's saying R18 equals star LED data code plus plus. And then this is saying R18. Wanted bit values on all 8 LED strings. And then some knobs to get it to the correct length. And then the end of the thingy for everything. Out 0x11, all zeros. This is surprisingly fun. Maybe it's not surprising. Maybe we should zoom in a bit. This is port F equals 16, which is end of bit equals low on all 8 LED strings. And at this point, we sort of are free to do the decoding of the next thingy and stuff. And we need to go back to the loop start actually. We need to go back to the loop start. Oh, we need another thing stored in here actually. We need to see if the pointer that is in X has reached another pointer. So we're gonna need to store another pointer in registers. Where can I store that? Let's see. Wait, where was the table I was just on? Wait. Oh, hang on, it was here, wasn't it? Yeah. Y or Z? I feel like we don't need that. I mean, we could, but we could just use other registers, right? Because I don't need to... This is useful if we want to... We use X, Y, and Z if we want to dereference something and see what's actually stored there, right? But I didn't need to see if anything's stored there, so I could just compare any register pair to the X register pair. I could store it in, like, 19 and 20 for all I care. 16, because we got 16, 17, 18, so we might as well use 19 and 20, I guess. I'm a little bit scared about which ones I'm going to use. I'm a little bit worried that, well, maybe I should use lower number ones or as high number ones as possible because the compiler is going to be using the lower ones or something. I don't want to be like knocking stuff out. Obviously the compiler, if I tell it that I'm going to be touching these registers or changing these registers, it's not going to corrupt data. But is it then gonna like temporarily move things out of there to run my code and then move its things back? Isn't that gonna be like a waste of time? Although to be honest, it doesn't really matter that much because it's gonna be outside of this super hot loop, so I guess I'm screwed. Even if it'll slow it down, it's not gonna be a big deal. Okay, we wanna store something else. We wanna store, let's say in registers 19 and 20 LED data after, which is a U8 star as well. We don't really care what type it is, the star is the important point. Whoa! Is that Alex? Hi! Welcome! Hi, how are you doing? Welcome, Brainoid Games. Oh my goodness, Thorolf as well. Hi, RGB Productions as well. Hi, Sabin or Sayabin. Annie Hanshad. I just combined both of your names together. Utterly ruined. Cubes rolling on through. Welcome, welcome. How are you doing? Sona Cuspt? I wonder if I'm pronouncing that correctly. Hi. How are you doing? Let me shout out. Don't delightfully you made that progress thing today. Oh my god, I've heard of that. Are you saying it's not just a mythical thing? I'd love to make some of that one day. Let's see what you're up to. I like this new green software and game development. It makes me feel more clever than I am. Caught in a loop. A gameplay loop. Bad. Working on the gameplay loop of your game, I guess? Certain it's real, I've recorded it. Oh my god, I'll have to check the VOD. Please show me this rare footage. The cryptid. I love the logo change. Yeah. I like your logo as well though. Thank you for the follow, Sana Cuspt. One day I'll learn how to read your name. But hi everybody, I'm a weird cat. I'm currently, finally learning and using assembly for the first ever time. This is AVR assembly for the Arduino Mega, the 80 Mega 2560 CPU, which is on the Arduino Mega. Sonic. Okay. I know why I'm subbed but not following. This happens a lot. No worries. Thank you for the follow, RGB. I swear Twitch does unfollow you sometimes. I swear that I've followed someone, a specific person, at least 3 times. And he thought he'd seen the follow from me as well. It's really weird. Finally piecing it all together, had to return... had to do a bunch of quest stuff, and I'm trying to make it all loop. Good luck. Is a loop less than 256? Actually, you're right. I think it will be. I think it might be. Yeah, I think it will actually be. Bet it's mess ups with people's follow moderation settings. Wait, follow moderation settings? What does that mean? I didn't even know you could moderate people being allowed to follow. Right now I'm looking at the AVR instruction set manual and manual specifically for the CPU, and I'm trying to make a piece of code that basically does this. I'm trying to convert this into assembly, and I've got this so far. It's not quite done yet. I haven't tested anything yet. I'm just sort of writing it down. I haven't even got the /ins and stuff at the end. You can say this to people have to have an account for X days before following. I'm guessing as Twitch's code is perfect there. Maybe, yeah. I guess that's so that you can avoid some like malicious named users from being like announced on stream or something like that. Can I ask what you're making? You can, and I would like to tell you right now. Thank you for the follow, Saibin. Hi. So I'm trying to make a circuit board with many LEDs on it, basically just a big LED display. I've already had one made, like a prototype, and it didn't work due to a mistake I made, a rather critical one. I made 2 big mistakes, two mistakes really. One of them was not workaroundable, and since it didn't work, let me show you the boards that got made, because they look pretty even if they don't work. So this is one of the boards, which I think looks cool. The back side has all the small components soldered by the company that fabricated the board. This is the first time I'd used that. I used GLC-PCB. I've used GLC-PCB before, #not sponsored, but I'd never used their assembly service before. And, I don't know, it looks really neat. I soldered these things on, and then I would also be soldering all these LEDs. 2080 in total. There's a Microsoft mouse for size comparison. It's quite big. And there'll be 4 of those stacked above each other. Some more close-ups. This is me bodging some LEDs onto it to be able to test it, because I couldn't just put the LEDs through there because these are all ground when they should have been 5 volts. So I just hooked these together and put that down to a 5-volt thingy down there. And got it working. I did this on stream recently, like I had a desk cam kind of looking at the board while I was getting it to work. This was me attempting to watch this display on, but it didn't work. Anyway, so anyway, recently I thought, well, as in last night, I thought that actually there's a way that I could remake this board, or make a version that's hopefully going to work for less money, and it would be better because I'd have individual control over the brightness of every single LED. Because one of the problems with this board is, well, due to the components I've chosen, due to what's available cheaply, the red LED here is so... Where's my mouse? This red LED here is... This here is so bright compared to this yellow one's a little bit dimmer at the same current. So like, if you blast the green one with 20 milliamps, it's not particularly bright, but the red one is fucking so overshadowing, excuse my swearing. Like, if they're next to each other, you can't even see that the green one is on. It's just so overshadowed by the red ones. So, it'd be really nice to run this at low power and this at high power. And the thought occurred to me, wow, look at that. You can see the pin through there. Or is that a reflection? It's probably a reflection of this, actually. Yeah, it must be a reflection. That's a fun optical illusion. But if I use one of the chips that is often found on RGB LED strings, WS2811, which is a little driver chip that's designed to control RGB LEDs. So it's got 3 outputs, one for a red, a green, and a blue. I could just use that chip. You can buy the chip by itself, like outside, not embedded inside the LED. And then, well, you've now got a very small, very cheap driver for 3 LEDs that lets you do 256 different brightness levels for each of its outputs, and it just changes it onto the next one. So basically, I'd be reducing my LED display to a very weirdly shaped LED string. That's basically all it would be. It would be simpler, there'd be no need to try to address a specific shift register, which is the way I was doing it before, in addressing blocks of 16 LEDs. But it would mean I need to like send data for the entire display at once, which takes a while. I wouldn't be able to have a super fast update rate. And so I thought, what if I can break this into effectively 8 or 16 much shorter displays, ideally 16, because this display is designed to show everything that's happening inside a MIDI file as it's playing, like the volume, expression, all these different things, instrument, pitch band, sensitivity, and how much it's being done, vibrato, panning, number of notes playing. These things flash whenever a message is received. They're actually 8 LEDs, 1, 2, 3, 4 extra ones on the end. And so if I could just break this down to 16 short strings, like just one here, instead of going all the way along and then this one and then this one and this one, then that'd be kind of nice. But I haven't seen anyone do that before on an Arduino. I've seen them do it on an ESP32, which is a much more competent or capable microcontroller. But I've got an Arduino Mega, old faithful, little 16 megahertz and 8 kilobytes of RAM. That should be enough for anyone. And I kind of like the idea of a challenge of using that, and I'm pretty sure it's possible. So what I want to do is basically, the microcontroller addresses pins in groups of 8. Or some of the pins that are exposed on the Arduino are addressable in groups of 8 as so-called ports, a port of 8 bits, and each bit maps to a digital pin. And so if I just connect 8 LED strings, 1 to each bit of a port, and I set up an array ahead of time so that you have all of the 0 bits on one byte, all of the 1 bits on one byte, all the 2 bits, the 3 bits, the 4, 5, 6, 7. Actually, you would need to go backwards. I think we start at the MSB and works backwards. But anyway, then I just clock out byte after byte after byte to that port. Then effectively, if you just look at any one pin, I'm clocking out bit by bit 8 bits. And then if you look at pin 2, I'm also clocking out a different 8 bits. And on pin 3, I'm clocking out a different 8 bits. So basically, I'd have 8 parallel LED strings that I'm clocking out data onto all at the same time. And effectively, I'll be clocking out 8 times as much data, almost for free, instead of having to clock it out all on one pin, because you're limited in the speed that you can clock out at, because that's just how these driver chips work. They're expecting specific on and off durations in the bits, and that's how they tell whether you're sending a 1 bit or a 0 bit. There's no separate clock pin. It's all about how long the pulses are. Hi Kelvin, welcome, welcome. And so, scribbled earlier, if you want to send a 1 bit to one of these driver chips, you gotta send a long on and a short off. If you want to send a 0 bit, you gotta send a short on and a long off. And what's happening behind the scenes is, whenever it sees a low to high transition, it starts a little timer inside itself. This is the driver chip. The driver chip, whenever you send a high value, it starts a timer. And after a certain amount of time, it polls the input again. And if it's high at this moment, then it knows that this is a 1 bit. And if it's 0 at that moment, then it knows that it's a low at that moment, then it knows it's a 0 bit. And then when you want to send another bit, you put the input high again, that kicks off the timer again. So that's why you need like a long bit if it's a 1 and a short bit if it's a 0. And it also starts a secondary timer every time you do a high bit, which is like goes on for way longer, like orders of magnitude longer before it times out. But when it eventually times out, which it'll do when you have sent all your data and a little while later has passed, that's how it knows that you've sent all your data. And when that happens, that's when it presents the data that you clocked in out on the LED pins. And you actually see, like, that's when it updates the LED brightnesses in, like, reality, rather than just the internally stored thingy. And, yeah, and what you actually send it is just 3 8-bit values. You send it all the red values, and then all the green values, and then all the blue values. So you just send it 24 bits. A red byte, a green byte, and a blue byte. And then that's it. And if you only send it, one 24-bit value, so one color if you like, then, and then you wait after a long time, you'll see that color. I say a long time, it's like a few hundred microseconds. Oh my goodness. It is pretty spooky. But I'm not sure why, but I am sure it is high foreplay. And if you send more than 3 bytes, it passes on the previous 3 to the next chip. And that's how you send the value on all of the chips. It just passes them on. It is just shift registers. It's like a 24-bit shift register. And so, I'm trying to write code that will do very accurate timing. And basically I need assembly because I need to know exactly how long the thingies last. I know assembly is very scary. That's kind of fun. Oh, thank you, Sato. And I realized I had like an epiphany last night when I was looking at this. And I thought, okay, if we have 8 outputs. If you have 8 outputs, 8 LED strings, and we want to send all 0 bits on the first 4 strings, and the next 4 strings we want to send all 1s, then at the start, we'll turn everything on, because, every bit starts with a transition to high. It's just how long it stays high that determines whether it's a 1 or a 0. And then, at this point, we'll turn off some of the bits, and then down here, we'll turn off all of the bits. And no matter what we're sending, it always starts with all 1 bits, and it always stops with all 0 bits. And this point is the only significant point in time where if it's meant to be a 0 bit, those outputs go low. And if it's meant to be a 1 bit, the outputs stay high. And this, it's just this. It's just this. So all you need to do is output hard-coded 1s, wait a little while, specific amount of time, the same every time. Then you output this value that you actually want, and then wait a specific amount of time. Then output all 0s. Then you have a little bit of time to prepare the next bit of data, and you go around again with the next bit and the next bit and the next bit. And so I wrote this little loop which does that. This outputs all 1s on one of the ports. That is 8 pins. Then it outputs the value that should be there. So this is just pointed to the data that we're sending here. So this is all reds, greens and blues. So this should present a red color. By the way, I have an actual LED string here with RGB LEDs that I can test this on eventually. And an oscilloscope hooked up so I can make sure the timing looks correct first. And yeah, so we start at the beginning of the array, we set port F to whatever is stored there, and then we move on to the next position in the array. And then we output all zeros, and we go back around again, this time the next byte in the array or next bit. Then all off, all on, next bit, all off, all on, next bit, all off, blah 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 blah. Until we've reached, or gone past the end actually, this should be that. And now I'm just trying to convert, oh, by the way, yeah, between these lines is where we need accurate timing, and really accurate delays, because the timing that we're dealing with here is so small, it's just a few clock cycles in the Arduino. So yeah, that's why I need it. The timing we're working with is this many nanoseconds. So this is 0 high, 0 low. So this is how long you stay high if it's a 0 bit, and how long you stay low afterwards. So that's a short time and a long time. And if it's the 1 bit you're outputting, it's a long time and a short time. But this time here is so short when you compare it to how many nanoseconds an Arduino takes to execute one clock cycle, or how long one clock cycle is. Because the Arduino has a 16 megahertz CPU, and if we just divide that, this many seconds, milliseconds, microseconds, nanoseconds. Look, we're talking just a few 62.5s. It's kind of been very, very tight territory here. But I think it's possible. Especially because if I am right in how the chip works with this timer thingy, which was not my idea, I read it in a comment on an Instructable, but I think they have the right idea. It wouldn't matter if you are a little bit late with doing the next bit, because the timeout bit, which it determines that you finish sending all data, is like so long. Look, it's 280 microseconds. So this is nanoseconds, and this is microseconds. This is 1,000 times longer than this. Like, we're talking like 3 orders of magnitude longer. This is, so as long as you're not 3 orders of magnitude slower in preparing the next byte, you can probably delay a little bit and drag your heels and be like, I wasn't quite ready with the next byte, and then it'll probably be fine. Obviously, it'll take longer to send everything, so you kind of want to do it quickly if you want to keep a nice high frame rate on the LEDs, as the display updates for maximum smooth flashiness. But there you go. That's what I'm trying to do right now. It's absurd how fast. I know, right? And they're not even milliseconds, that's microseconds. So we're wanting to send, I don't know, if we wanted 30 FPS, then that would be, as I'm sure you know, set to be like 33 milliseconds.
Bytes.
Yeah. Indeed, exactly. Bit, byte. Yes, that's 8 bits. Thank you so much for the overview. Yeah, no worries, you're welcome. So the total amount of data we need to send is going to be somewhere around 150 LEDs for each channel. So 150 times 8, because there are 8 bits for every LED. And then it's approximately that many microseconds, which is like, yeah, because the microsecond is, wait, hang on, am I right here? Yeah, approximately one, let's say 1 microsecond for both of these combined. So divide that by 1,000, and there we are. So it's just over 1 millisecond then to send 1 channel's worth, whereas 8 milliseconds is 120. Yeah, that sounds right, because 16 roughly is 60 FPS, yeah. Yeah, so that would be 1.2 milliseconds to update 8 channels in like parallel, which is so cool to me, because if you're trying to update those 8 channels individually, in series in a row, one long windy string of LEDs, well, that would take 8 times as long. And now, like, it's actually starting to add up now, and it's just, I don't know, just the idea of being able to do it in parallel is cool, especially since I would be sending like 8 LEDs, 8 channels, and then the other 8 channels, because there are 16 mini channels in total. So, you know, we'd send all of these ones, and then all of these ones. These would be on one port, and these would be on another port. And I don't know if the Arduino is fast enough to send both of these in parallel. Possibly not. So I do all of these and then all of these. So at that point, yeah, if it was entirely one long string of LEDs, then now we're actually starting to add up to like quite slow. So this is approximately 50 FPS if all we wanted to do was just non-stop send stuff out to the display. But there's a lot more that we have to do in our program than just communicate with the display. Like, we have to even work out what should be shown on the display based on MIDI messages that we receive. So like there's a bunch of other processing we have to do. And so the actual frame rate will be quite a lot less than this. Than 50. I think 50 would be really excessively fast though. So I'm aiming for like 30 FPS or so. Not least because right, but hold on, 1.2 was if we're doing 8 in parallel. If we're doing 16, then it'll be this long instead. That's what I wanted to say. So it's around 2.5 milliseconds instead of 20 if we can do them in parallel. But anyway, I'm probably going to aim for about 30 FPS anyway, and just leaving lots of time to process other things, because the LEDs on the far right flash. They're meant to do like one really fast, just like a blip, the moment that a message of this type is received. So you can see activity on each MIDI channel. You can see like a blip, 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 blip on this one if there's like notes going bim, 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 or something. I thought that'd be pretty nice. And so I don't want the frame rate to be too high, because if we just want to turn an LED on and then on the next update turn it off, we don't want too short a time. Otherwise that flash is going to be so ludicrously short. It's going to be, you know, the LED is going to look dimmer and it's going to be harder to capture on camera and stuff like that. So we kind of do want to put some kind of upper limit on the frame rate. Like, not a crazily high frame rate. Nice jams. Thank you. Let me turn on the auto-tune and do it again. I was playing around with auto-tune earlier for no good reason. Oh, I can't be bothered. I have to set it up again. Never mind. Sorry. I just realized there's no longer any undo history. Because many things like this have been triggered since then. And they add to the undo thing. Thank you, Clever. You're very kind. We'll see if any of this works at the end, and then I'll accept your compliment. I will accept it anyway, thank you. So what we do so far is we prepare a register just holding all zeros. We prepare a register just holding all ones. And the reason I have to store these in registers is because the command to output on a port can only output a value that's stored in a register. We can't pass a literal value here. So we store all ones here and all zeros here, and this thing reads in, if I'm not mistaken, because I have never done this before, but if I'm understanding the datasheet correctly, the manual, this reads X is a special pair of pointers, registers, these that contain a pointer. Pointers on the AVR microcontroller are 16-bit. So at least on this CPU are 16-bit. Thank you for the pats. Thank you. No, you shush, silence, stop. And so this basically just dereferences. This is equivalent to dereference the value stored here. So this is just loading the value stored here. And the plus means we increment it afterwards. That's like the plus in C. And the result gets stored into this register. And then here's what we do. We just output all ones, which we stored there. Then we output the thing we just read from the pointer. And then we output all zeros. And somewhere between here is where I need to insert the no operation instructions to just like pad it out a bit longer to wait the right amount of time. I did this in C first, as you can see, and I did run it. It's still being shown on the oscilloscope actually, and before this gets burned into my oscilloscope screen, but there you go. And it's very fast, and it's actually faster than it needs to be. So I actually need to slow it down with no ops here, which is a very nice situation to be in. Even the C code is faster. I mean, obviously, assembly is not just automatically faster than C. You have more control over it, so if you know what you're doing in the assembly, maybe you could be faster, but I'm a complete noob when it comes to assembly, so I probably won't be writing a super great assembly. A pair of pointers, you can see. A pair of bytes that are one pointer. That's what I meant to say. I probably did say it wrongly though. There we are. That's everything so far. And now I need to do a part. I need to put the value I need into X. Oh wait, right, that should be being done at the beginning. Then we've got the start of a loop. Okay, so here I need to be looping back to the start of the loop if something else is less than if this pointer that we've been incrementing has not yet reached the end. So this is what the pointer currently is. This is what the pointer will be once we've gone past the end, at which point we don't want to branch anymore. So we need to see, because there's an instruction to branch if less than. So as long as this is less than this, the current pointer has not become after the end, then we'll branch. And I believe that was BRLO. Let's have a look in the sheet. Branch if lower. Tests. Okay, I'm still not super understanding the carry flag. But anyway, test the carry flag and branch is relative to the program counter if C is set. If the instruction is executed immediately after any of the instructions, this or this, which is not, so never mind. Thank you for the follow, Goopy. Thanks for the overview. It kind of is a lot, sorry. This is a curious question. Can you have just added knobs in assembly between those C instructions? Probably, but the lengths were weirdly inconsistent in C, or a little bit not as consistent as I thought. So I'm a little bit confused about what's actually happening. That's why I want to sort of do it this way so I have an idea of what's actually happening. Do you still have the C code? I do. It's just this. I'll zoom in a bit. I'm gonna hold tab, so feel free to screenshot. You probably already have. You can check the generated assembly. Oh, okay. I'd rather actually learn assembly here. The branch will only... Okay, this instruction branch is relative. PC minus 63 is less than this, is less than this, plus 64. So I think... I hate this notation so much, I have to work it out every time. So this means... This means what? This means... This minus 63 is this... Okay, destination is less than or equal to this, makes sense. Destination less than or equal to 63 means... This is less than or equal to 63. Less than or equal to. So I guess that means this is larger than or equal to? Right? Or just larger than or equal to, right? Anyway, K is the offset from the program counter and is represented in blah blah. Wait a minute. This is like... Wait. I have to specify a literal number of bytes? I can't just give a pointer? Oh, not a pointer, a label? Because in this tutorial, they wrote 1:2:3:4, and there's clearly more than one instruction between 2 and 3. And then they say 1B when they want to go backwards, and 3F when they want to go forwards. What does that even mean then? Oh wait, here we are! You can put a thingy. Loop, colon. So you can also give it a name as well, it doesn't just have to be a number. Interesting. But you might have to have this as part of the line. You might not be able to have this by itself, I guess. On its own line. BRLO loop. Branch of R19 is less than. Yeah, okay. So BRLO, so if this is less than. Oh, we have to do the comparison first. And this is super an alien concept to me. I'm having to like. This is effectively testing, and this is acting based on it. Like this would normally just be like a thing in my head. You'd use named labels for ease of development. 16-bit comparison will be annoying if you go that way. 16-bit comparison. I was thinking because that would be faster. Well, at least it looks faster in C. But yeah, if it's not that way, we can just get the size of LED data instead, I guess. We just do it this way then. Sure, let's do it in 8-bit. Number of LEDs, I'll just have to make it so there are less than 255 LEDs per thingy. I'm guessing there should be. Well, I mean, there were 2080 in total before. Divided by 16, 130. And I was going to increase the number a little bit, making the 4-bar graphs. Oh, sorry, 4-segment bar graphs into like 5-segment. But that should still be less than 255. I'm not flipping doubling. And it wouldn't be affecting the 7-segment displays anyway. Okay, we'll do 8-bit then. So rather than doing it this way, alright, let me change my code. I'm gonna comment this out. Just because I'm wanting to have something I can translate from. This is how it was done before. And this is how we'll do it now. While? Oh, well, it's gonna be identical, but just... Is it? Yeah, I guess it is. So we want to do something like this. We have the size of... We're gonna need a separate value, which is the index of the LED, I guess, or index of the bit of data that we're sending, actually. We're just gonna start at 0. Or I guess it could start at the size of, in fact. LED data. If you want to do subtraction. And then... Well, let me... Okay, this is gonna be a bit different. I'm not used to doing it this way. Let's see what instructions we've got available. It's gonna require me rethinking a little bit. 16-bit compare would use C, P, C, and 2 instructions. 8 can be done with 1. Okay. Well, I need to have a look at stuff. What do we have available? Branching. Branch if equal? So we could say if it's equal to 0. That would work. I wonder if it's just a branch if 0. Doesn't look like it. Branch if floor plus T bit set. Wait, what was T bit? T was in the status register, wasn't it? Oh my goodness, slowly. Transfer bit. Okay, I don't know what that is. Alright. Branch if minus branch if plus. Wait, what does that mean? Like if it's negative or if it's positive? I wonder. Okay, I'm gonna do this myself. Sorry, Erickson. So if we're gonna decrease to 0, then increase from 0. If we're increasing from 0 to this, that's way more intuitive in my head than going down to 0. I guess I should see what that actually would require. We would need to set some register to be this. Well, I mean, that's going to be done by the thingy that initializes everything, I guess. So we're not going to do this. Oh my god, this music's taking forever to finish. Okay, so then instead of 19 and 20, we're just using 19, and this will be size of that. Okay. So... and whether we go up or down, we're gonna need this. I wonder if there are any good books for this stuff. I wonder. This is kind of... well, this and this are... well, they're not books, are they? Never mind, you're asking about books. Sorry. Sorry. I was gonna say, well, they seem to have enough if I were just to read the entire goddamn thing. Instead of needing Stewie to point out where stuff is. BRL, okay, so we're not doing that. Or maybe we are. What do we have? Branch if equal, lower, minus plus. Branch if greater or equal, signed. Branch if less than, signed. I guess we do need lower then, because we don't have a greater than unsigned version, do we? I mean, it takes the same number of clock cycles. Well, 1 or 2. I wonder why it's 1 or 2. That's weird. Branch if lower. Want me to point out where stuff is? No, thank you. It's fine. Branch if lower. Branch if same or higher. Oh, there we are. Wait, greater than or equal to. Never mind. Boosh. I was looking for greater than. It's interesting. They're using words like lower and higher. And now they're using greater or equal, which is so weird to me. Why are they not staying with the same name? Looks like when it's signed, they're calling it greater. Are they also using less than when it's signed? Ah, who cares? Okay, so in this case, we'd start at 0. If I do it this way. Thank you for the follow, Anako, then. So this would be while int bit is less than... okay, which way around would this be? Hold on, which way around would this be? If we wanted to send a single bit, then 0, then we'd do our thing, we'd increment bit. I'm using a do loop rather than a for loop because this is like more similar to how a loop actually is in assembly. So I just wanted to write something that I could easily translate. Okay, so it'll be 0. What am I using? BRLO, branch if lower. So this would now be 1, and we're testing if 1 is less than 1, and that would fail. And that would be good, because we have gone through this loop once. Okay, this works. This should work. R19 is going to be this. Okay, I'm just going to also add notes. R19 is size of LED data after. I'm going to say is already. Stuff. Stuff. Trey one for supposed to be writing about how I try something. Ah, it's alright. It's alright. I know you want to help. But specifically for something like this, I feel like this is like within my personal ability to be able to do. If I'm understanding correctly, I'm sure this isn't going to work first time, of course, but you know, it's kind of exciting because this is literally the first time I've ever done this assembly. BRLO. So we're seeing if is white space significant here? Could I indent this like this to be the same width? I wonder. This would please my brain if I could have them aligned in columns like this. Okay, thank you. Okay. So I'm gonna branch if C is equal to branch if low if. So this is the comparison, right? Wait. Oh, wait, this is carry, right? Okay, hold on. Let me have a look. BRLO. How do they do it? CPI. Why am I not searching for case sensitive? Compare with an immediate value. Okay, so I need to not compare with immediate, I need to compare it with something else in a register. So I need just CP. If the instruction is executed immediately after CP, the branch will only occur only if the signed binary number represented in RD. Wait, sorry, this is greater or equal to. Anyway, only occur if the unsigned binary number for RD was smaller than this. Instruction branches relatively to the program. I think this is what I want, right? So CP, we're gonna compare. How does this work again? I wanna actually look, because there was an example code. Oh, yeah, probably down here, right? Oh, they're comparing immediate. So I'm guessing the value that you want to compare comes first, or you know, the value that's likely changing. Instruction performs the compare between two registers. None of the registers are changed. All conditional branches can be used afterwards. So they were saying RD is like the destination, but it's not a... Compare. RD minus RR. Wait, is this actually a subtraction? RD minus RR? It's effectively taking the number that you, in my case, I'm expecting to be lower, and I'm subtracting a value that is going to be higher. So this will go negative if that's actually what it's performing. And then BRLO would never work because, you know, this is for unsigned stuff. Right? Yeah, I'm gonna add those later, Jockey Bro, thank you. Am I right about that? Am I right that this would not work? Because if we're subtracting a large number from a small number, that's not gonna work. Because it's unsigned. I guess I can find out. So the small number is... Oh, we need another register. We need another fucking register. Help! This is so many registers, although it's actually the same number of registers as I would have done before, so it's fine. It's fine. R20 is one that we don't need to set up here, though. We set it up ourselves. So we'll just set this to all zeros. R20 equals 0. This is our loop counter, sure. So any program is all about the registers. I'm going crazy with the stack location you stored some. Thankfully, I'm not gonna need to do any like. It's just a small part of one function, so it should be okay. For me, my brain. Okay, so we're comparing R20 to R19. Yeah, compare loop counter with size of LED data after, and this would be the RLO. If anybody knows whether this would not work, because this is a small number and this is a large number, and it says that the option that the operation it's doing is R20 minus R19, so this is like saying 2 minus 150 or something, and then this would obviously need to be that would be signed. Then that would be useful backseating. Well, I mean, it wouldn't be backseating at all. It would just be helping BRLO. BRLO. Then, so looping back to loop start if it is less than. We also need to increment our counter, which I'll do immediately before. But I wonder if there's something that automatically increments something somewhere. Should work since it's a combination of CP and BRLO which determines the comparison. Okay. Okie dokie. Compare skip if equal. Compare the immediate. Relative jump. Oh, interesting. A clear bit in brackets S in register, so I guess you can just. I was just doing C. Was it CBR or C? Oh, CLR. I'm doing CLR is clear register. Okay, yeah, it's just the whole register. Did you see my mouse wheel doing the thingy where it's not sure what position it's in? Data encryption. I actually don't see anything with increment. Let's see. Ink. Rem. Increment. Oh, right, ink. I just use ink here, not add, just the ink thing. Increment. 20. Increment loop counter this is. Increment. Storing, loading. Okay. Oh, this is program memory stuff. Let's not help. Now we're into scary territory. Help. Get out of there. Why does it do this? How can I jump to the first one? Oh my goodness. Well, let's keep pressing enter, I guess. There we are. Alright, so see if loop counter. We'll just compare this. If less than jump to loop start. Loop start is the actual name of it, I guess. That's super cute. That hyphen echo emote. Okay. I wonder if this will work. I need, next up, before I even do the lines, I kind of want to remember how the hell this works. It was like colon, right? So colon for the outputs, which is nothing. Colon for the inputs. Now open bracket, speech mark I, speech mark space. Wait, hold on. So how did this work again? So I means unsigned 6-bit integer constants? That doesn't seem to be the right area that I'm looking at. These not constraints. How do the trees get on the internet? They log on. Nice. So I'm guessing the letter is not I. I'm guessing the I is not constraint. This I doesn't mean constraint. I don't know what constraint means though. Assembler instructions without operands? Assembly instructions with C expression operands? Ah, here we are. Here we are. Okay, nice. ASM qualifies this. Then close bracket. Oh, okay, so the bracket comes all the way at the very end. All the way down here. Okay, nice. Semicolon, I guess. Then you do colon outputs. There are none. Go to labels. Wait, you can go to a section outside assembly? That's pretty cool. Wow. Alright, output will go there. Input goes here. Input operands. Input operands. A comma separated list of C expressions. With GNU this or later the strings can also be constant expressions inside parents. This always looks like to me. So in this example, this is a thing, this is an output, and this is an input, I guess. This code copies source to destination and adds 1 to destination. So moving %1. Wait, %1%? Wait, there's only one though. There's only one thing. Or is this %0? Wait, okay, how the hell are these accessed? Is %0 literally... Wait a minute. So... anything between here or anything here is like all numbered from 0. So if there are things in this first colon section, this would be 0 and this would be 1. Even though they're separated by colons, that you keep counting when you reach the end of this, and that's a 0 and that's a 1. That's not a percent. No, here. Here, there's %1 and %0. So moving this, but there's only like one input, right? This is the inputs, I think. Source is 1 and destination is nothing yet. I'm guessing, well, I'm guessing the source, I'm guessing this must mean that's the, wait, 0, destination, 0, and 1 is source, so I guess this takes %1, which is this, and moves into %0. R is any register, let me uke. No, don't let me uke. That's not gonna be good. So these are the ones that we're gonna mess with. I'm wondering what this speech mark is. I don't know where to look to find this. There's a lot here. What if I just type speech mark I, speech mark? There's not a speech mark. Well, there is nothing with capitals. Here's an I there. There's no I in this table, so it's not a Modifier, question mark? Modifier. Now it is modifier. Print the character I if the operand is not a register. Print the character I if the operand is not a register. I think this is probably something else. Wait, hold on. Print 0 instead of 0 if the operand is an immediate with a value of 0. Print the character I if the operand is an immediate. Wait, is that what it means? Wait, it's literally just replacing the... Wait, is it literally just replacing the... Well, it's not gonna be done at runtime, surely. It's like it's actually building a string, isn't it? My Arduino thingy, here it is. Where's the other thingy? Here it is. So is this meaning write this as an integer and write this as an integer? You're on the risk of thing, not AVR. Okay. I don't know what to be looking at. I don't know what anything is. I don't even know what anything is called. I don't know what to search for. So I'm just searching for speech mark I speech mark, and that was a place where speech mark I speech mark showed up. What is speech mark I speech mark in assembly? That's not gonna work because you can't search for speech marks on search engines. What is quote I quote? Quotation mark in inline assembly. That's not what I want. American Society of Microbiology. What the fuck is that the second result for, huh? I don't think it's gonna work. Oh, because ASM, right. Interesting. That's the I constraint. Oh my goodness. Thank you very much for the follow. I'm gonna just call you Albinos, I guess? Because I do not know how to say the first one. Skiak? I'm trying anyway. Where did you see that? Where did I see what? Oh, when I typed ASM on the start page. Yeah, thank you for the follow. Where is it being used? Where did you see that? Basically a number 0 to 60 albinos is enough. Okay. Nice. You're welcome. Where is it being used? Where did you see that? The number 0 to 63. The number 0 to 63. So this won't work for... Well, then this wouldn't work, would it? This wouldn't work if this happened to be the highest bit. Well, wait, no. No, never mind. Where is it being used? Which other port A and port B stuff? This? To use with in and out. Yeah, this is port F. The 0x00 to 0x3f address, which is 0 to 63. Oh, is that what this is? Interesting. Huh. So it was the 6-bit thing. So it is this. Okay. So in that case, for this input, well, how do I even specify it? Do I put X? Do I put R27 colon R26? Wait, how do you even specify what the... Wait, what? So fucking confused. These are values. Oh, right. I've been doing this wrongly. Hold on. This is where I've been wanting to... Okay. So, if I wanted to store this in this position, this would need to be percent. I would need to refer to %0. I'd need to do something like, I mean, this isn't going to work obviously, but I need to do something like, I love the way it deletes all of my things. I need to do something like LD into there. This is like sudo or something, from %0, and then this will become %0. So rather than this, rather than typing this, it's censored, I'm afraid, Nymph, and so is yours, Ericsson. If people want to search for things, I can allow them to post a link. Hold on. Now we wait for the Twitch thingy to load for me. Oh, bye, student. Okay, I'll definitely. Wait, I think links should be able to be posted now. Posted in Discord. Okay. Links on. Thank you. Yeah, links. You can now post a link if you want to, Ericsson. Let's see. What is this? This is the same table, right? But this is specifically for AVR rather than AVR. Wait, it's the same thing, right? Hold on. Okay, no worries. Thank you. GCCASM statement. ASM in %0, %1. What is in? Is this specifically for AVR? Yeah, it looks like it is. AVR is an address file. Let's see how in works. In case sensitive, whole words. In from IO location. So it's going to be stored in RD from A. Except in this case, it's going to be in from %1, stored into %0. Wait, is that the same order? No, it's the opposite way around. The destination is first. So into %0, we're storing %1. A list of output operands separated by commas. Our example uses just one. Equals are. Oh my goodness, thank you for the follow, Coding Grid. My brain is starting to reach its limit right now. Equals are value. A list of output operands separated by commas. Okay. I guess this will be explained later. Comma separated list of input operands. Something. Clobbered registers nothing. You can write assembly instructions that have registers and constants used in different ways if they refer to expressions in your C program. The connection between registers and C operands is specified in the second and third part of the ASM instruction. The connection between registers and C operands. What is a C operand? I wonder. is a C operand. Okay, I don't know what that means. It's specified in the second and third part of the ASM instruction, which I guess is this and this. The list of input and output operands, respectively. What? Well, everything else said that it's output and then input. But this is saying it's input and then output. Well, who knows? Who knows? This one's explicitly saying that it's input and then outputs. And then this one is saying... Well, I don't know what that's saying. This is saying output and then input. I'm sure something else said output and then input as well. I wonder if is colon even explained anywhere here. Nope. Somewhere here the colon was explained. Colon, colon. Not there. Colon, colon. Here we are. Oh, that's not explaining. Colon, colon. No. Colon, colon. I haven't used this page yet. Wonder where I was. Was I here? No, this page doesn't send anything. What's this? Where the fuck was the thing that told me? I was on a thing somewhere. Oh, here we are. This one. Well, not this one, but this one. But this is not for AVR, it's saying. So it's AVR input and then output, and this one is output and then input? Yeah, this seems... Let's just... Well, now I have conflicting things. Code. Output, input. Okay, so it's conflicting with itself. Exactly. Okay, amazing. Okay, I'm not sure how much I can trust this page. Are they just saying respectively to sound like, you know, intelligent, but they don't actually know what it means? Relatable. Clobbered registers left empty. Nooch!
Yuki's nose, a perfect charm, so small, so sweet it disarms. With every twitch, a playful sight, a touch of joy, pure delight. A gentle curve, so soft, so neat, her little nose is simply sweet. No feature could more love compose than Yuki's cute, adorable nose.
The cliffhanger at the end. Thank you very much, Nooch. Tacos! Oh my god, I haven't had those in ages. Ah, I really want some now. Nice. Hi, Nooch. How are you nooching? Well, pretty well by the sound of it. In the code section, operands are referenced by a percent sign followed by a single digit. Percent 0 refers to the first, percent 1 to the second operand, and so forth. Percent 0 refers to equals R. Percent 1 refers to this. Okay, so yeah, the colons are completely ignored. This may still look a little odd now. But the syntax of an operand list will be explained soon. Let us first examine the part of a compiler listing which may have been generated from our example. The part of a compiler listing which may have been generated from our example. Okay, what was our example? This? Wait, example? The part of a compiler listing which may have been generated from our example. Is this like translated or something? This is really strange. I'm not, this way this is written is very confusing to me. LDSR24. Is this going to be generated based on this? LDSR24 value. app in R24. No app. STS value R24. R24 is like nowhere in here. Oh my god. Paragraph is just written conversationally. This part and yeah. The words have meanings. You can't just. That's ridiculous. The comments. Okay, so there is no example. It's not respective. All right, nice. The comments have been added by the compiler to inform the assembler that the included code was not generated by the compilation of C statements. What was I trying to read again? I don't remember what I was reading. What was I wanting to know? Outputs, inputs. Okay, I wanted to know about the... What was I even doing? I want to know about this. Speech mark, I, speech mark. Okay, so this value is a pointer. So it needs to go into two things. So it's not 6-bit unsigned, it's not 6-bit negative. It's not... Wait, is this a constant? Is this constant? I guess I could make it constant? If I make this constant, the value can still change, right? But the pointer doesn't change? This is where C becomes very silly in my opinion. And it becomes really hard for me to keep track. Whether const u8 something or u8 const something or const u8 const something const something const. Let's have a look. Constant array pointer. The pointer itself needs to be constant, but I don't know. Const array pointer to const values. No, that's not what I want. Arrays and pointers. Const pointer array. Let's say const pointer. Why is an array called a constant pointer in C? Wait, what? So it is constant? What? I don't know whether this is constant or not. No, it is. Let's just try that and see what happens, I guess. Let's just comment this entire thing out and see if this even compiles. Yes, okay. 742 bytes, 0%. Okay, so it's okay with that being called const. Okay. Let's see if the data is like even correct. Let's just do this, but I'm gonna modify this a little bit so that it delays by a lot, I guess. This is just a silly debug version. Everything that's silly, I'm indenting. I'll delete it afterwards. So this is gonna make a tiny pulse, and then we're gonna output the actual value of the thing. We're gonna wait for. I mean, we want 1 microsecond, but 4 is the lowest you can do. But I'll type 1 anyway. And then turn off. Okay, let me just compile that and see if I can see 24 pulses followed by some really long ones on the oscilloscope. Let's get back to. Let's get a grounding in reality again, because I'm losing it, Scoob. Okay, let's upload. Oh wait, is that already up? Did I upload this already? Can't remember if I uploaded this or not. Let's press the button. Oh, hold on. Let's just do it once. Okay, here's what we get. And it looks like it is kind of as I expected. It looks like it's not doing any delay actually, because I put delay 4 microseconds, 1 microsecond, it looks like it's just not doing a delay. But yeah, we have the 8 double ones, 1, 2, 3, 4, 5, 6, 7, 8, and then 16 ones which are nothing in between. Okay, so it is reading from my data correctly. This const thing is fine. Let me just see if I can modify it though. Let's see if I set LED data at position 2, so the third one along, to 0. Do we get a gap? Does it even compile? Read only location LED data 2. Okay, so no, the value itself is apparently constant. That's interesting. Thank you for the follow, Fermented Crab. Fermented Crab, oh my. What if I do it this way around? It's still read-only. So wherever the const is actually irrelevant apparently. Okay, so it can't be const then, I guess. This should work now, but it wouldn't be const. And probing and running. And there we are. We see a gap on the third one of those passes. Right around there. Okay, so it's reading the data and setting the data just fine. But I guess it can't be constant. So I can't use the whatever it was. Or any of these actually, these are all constant. Okay, so we can't use any of this, I guess. Size of is constant though, right? So for... let's remove all this. Size of is constant though, so... this one, R19, could be constant. If I'm not mistaken. Right? Registers. A simple upper registers that support... okay, what? I don't understand this at all. What? Why registers? These are stored elsewhere at the moment, right? Or can you tell it to store it into a register somehow? Any register, upper register. How do you even specify a register? Like it's just stored somewhere at the moment, right? Somewhere in RAM. This is why we need to do the %0, isn't it? I thought this is why we need the %0 and %1. Operands can be given names. The name is prepended in brackets to the constraint. %. Oh, that's nice. The above example could be written as in %redval %port. %redval. Okay, where's redval? Is that meaning this? I guess it's meaning that, right? Okay. That's interesting. Redval is the name of a variable that I've used, or tend to use, when I'm writing functions as well. It's kind of fun. Huh? Huh? I didn't think I pressed anything. Why is it wanting to save the page? That's it's concerning. What the fuck just happened? Or did I actually just press Ctrl S completely out of habit and forget about it in the time between me pressing it and realizing? I mean pressing it and it happening. Alright. So I'm guessing at the very beginning, we want to put something into x plus. So we want to put something into x plus. So how do we copy a 16-bit input? What does an input even mean? What does it mean to have an input that's not a byte, I wonder? This is where they would not be backseating to help them. Understandable if this strangeness is confusing other people as well. My brain is almost completely fried for tonight though. How do we like load this? I mean, this is an 8-bit microcontroller, so I guess. But no, it would have W's in there, right? It had W's for 16-bit things. Add immediate to Word. Yep. Subtract immediate from Word. So I'm looking for W's. Wait, without it matching. Move Word. AVRE. Move Word. Well, this one exists, right? Because AVR, it's AVRE plus with my one. So move Word. So we can move Word. Oh no. So essentially we want to move a word? How does move word work? Move a word.
Choose.
This is acting as if we're copying a register though. I'm gonna pack it in yet. Copy register pair. So into the first one we store the second one. So into a pair. Wait, RD plus 1 to RD. RD plus 1 to RD. RD plus 1. RD plus 1 to RD. So RD. Wait. This is R27 to R26. Should I have written R26 to R27? Where does it explain about the X's? X. This is R27 to R26. But in the MOVWA, it says this plus 1. So I wouldn't be able to just pass X, would I? If I pass just X, it's gonna go R28 to R27. So I guess I manually need to pass R26 here. And then comma %0, I guess. I have no idea what an input is. Like, what is an input? Like, what is it? It's not an immediate value, I'm guessing, and it's not a register. So like, I don't know whether I need an instruction that deals with moving a register to a register or an immediate value to a register, or like maybe it's load indirect. Who knows? What the fuck is an input? Do we have any examples of a percent in here, I wonder? Percent. No, there's no percent anywhere in here.
Brain has reached capacity. Error.
Oh, they're there.
I knew it.
Oh no, the brain is failing. Nope, there's no such thing as inputs according to that either. Which I guess makes sense because they're assuming that you're going to write the entire thing in assembly in the first place, and this is if we're interfacing with C code. Oh no, the brain is releasing steam. Thank you for the pets. Okay, so this will maybe, who fucking knows, store the pointer, which is a 16-bit thing, into X. So move to R27 colon R26 X. Or move wait, is move what we want? Wait, does move actually move or does move copy? Hold on. Oh, it copies, okay, thank God. That could have been weird otherwise. The source range is about R plus 1 colon R is left unchanged while the destination is blah blah blah. Okay, nice. That's what I want. Even nicer if I can just pass X, I guess, but... Wait. Could I instead do percent 0 X? Oh, percent 0 plus here? Instead of this? Oh, who knows? I don't know why it keeps changing my keyboard layout to American. So speech mark becomes at. But thank you, Spray. What's a high spray? Did I ever say high spray? High spray. Where is Arduino? Here it is. Okay. Next one, R19 equals this. So R19 is already not yet. It's not. Not yet. It's not. So we want to. I guess morph is how you copy something that's not 16-bit. Yeah, looks like it. Yeah. Okay. Okay. Let's see then. Morph into register 19. This. We have R18. What is R18? Move. To this. Less than regulatory 205. Do I want to do this first, I guess, as well? And then this is from %1. I guess. CLR 20 becomes 0 and this becomes... Wait, oh yeah, that's right. So you've got 19, 20, so 16, 17, no 18, 19, 20, and this special one. So 18 here. 18 equals... Oh, this is the value that gets read. Okay. Okay. So now I want to specify the inputs. How do we do this? How do I specify the inputs? How are they doing it? So they're putting I every time. But how, like, isn't it super unlikely that the value is gonna be less than, like, less than 64? Why is there no example of how to do it without a value less than 64? Like, surely it's not possible. Surely it's not only possible to pass in 6-bit integers, right? E. Pointer registers X, Y, and Z constraints. So could I put E for this one? Because I want to store this one inside a pointer register. And for this one, I want registers. These ones? Upper registers support LDI, ORI. Okay, what are LDR, ORI? LDI. Load immediate. Load immediate. Is it an immediate then? No, surely not. No, no. And ORI. What? Logical OR with immediate. Okay. Adil and spill. Okay. And the ones we want to change are this, R16, R17, and R18. We also want R20 is our loop counter. 16, 17, 18, 19 is the size of
cheese.
So R19 will be changed. The R20, 16, 17, 18, 19, 20. So 20 is the loop counter. 16 and 17 are zeros and ones. Hi, Ethereal Chinch. Welcome, welcome. Shove what into register 18 and 19. 18 is the value that we've read from the pointer dereferenced. This equals this. I feel like I'm making copies of things. I don't. Okay, whatever. Maybe it's just unavoidable. Okay, so how do we specify stuff? So this one is going to be stored inside X. So I guess I'll put D. Wait, no, sorry, E. Sorry, E. Jeez. E. Where do I put E? Here, E. Is that right? E. Space. And in brackets? Do you put brackets on here as well? Yeah. Parentheses. And this is where you put the actual C thing, right? So this is this. And this said it was comma separated, so my mind just said all kinds of stuff. Okay, there's a comma there. And this time we're storing a value. This is the same, isn't it? E. Okay, what's next? Size of R19. This is a value that's less than or equal to 255. Less than or equal to 255. And this is like a constant, isn't it? Actually. So would morph even work? Maybe morph wouldn't work because this is a constant. But is it a constant on the assemblies? From the assemblies point of view? It's a constant from C's point of view. Like it's an immediate thing, right? This is known at compile time, it's a literal. I mean, it's not literal, but it's known at compile time. Where's the data sheet? How do we set a register to a literal, I guess? That's what I want to know. Let's see. Or immediate, I should say immediate. Immediate. Add immediate to word, hold on. Add immediate to word, subtract immediate with carry, subtract immediate, logical and with immediate, logical, compare with, load. Load immediate, okay, LDI. LDI. Let's try that. Yeah, same Ericsson, it's very complicated. Very unclear. Everywhere. Okay, what's next? This, R19. R19 is something less than regular 255. And this is an immediate. So... oh, but whatever, it's going into a register. The register is R19. R19 is this. Ah, this one's different. This one says that support blah blah blah. Okay, let's go to this. R19. R19. I mean, I need to interface with C. I'm not going to write the whole thing in assembly. Right? I don't want to have to define, you know, this needs modifying. I can't just hard code this. I mean, it's hard coded right now. But it's going to get modified eventually. I want to modify it with C code rather than assembly. How could I have done it differently? R19 equals size of... okay, so R19 is what I want. So R19 is D. This size of LED data after. Oh, okay. It's tricky now. Okay. So this is outputs and then inputs and then the stuff that gets modified. How do you specify the stuff that gets modified? Okay, this is normal. You just, I mean, this is easy. You just do normal strings. I'm assuming this can be uppercase or maybe lowercase. Who knows? R16. 17. R18, 19, 20, 27, 26. And that's it. Now I need new lines, and apparently tabs are only for these ones, but not for this one. Who knows why? Does this page even do the backslash n backslash t as well? Backslash n backslash t, yes it does. Input and output operands. Each input and output operand is described by a constraint string. What is an operand? Is an operand the name of an input? Simple upper... wait, what does this mean? Described by a constant string. 0.00 to 63. Oh, you can specify constants! Oh my god! You can! Okay, so it's M! It's M! M would better describe this. This is a constant. It's an 8-bit integer constant. Okay. This? Maybe this can be described better as well. Pointer! Wait, pointer register pair X. I'm not quite sure what that means. It will be stored in pair X, but it's probably not in pair X currently, right? So E, pointer register pairs, pointer register pair X is where it's gonna go. M, integer constant. Wait, so can I just use %1 everywhere where I was using size of blah 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 blah. So we don't use R19 then. Hi 1186, how's it going? Extremely headachy. How's it going for you? R19 is a type of fiberglass or no?
Cheese.
Please be careful. My jeez. It's gonna make my head worse. I mean, just the fact that it's being thrown at me. Q. The memory address based on this with displacement integer constant. -6 to 5. What the fuck? Okay. Range 8, 16, or 24. Wow. This is like a size, I guess. Like a size of... But you can't do 32. Thank you, Spray, for smudging the cheese into my head. I'm gonna work in 2 hours? Oh my, good luck! Good luck. 8-bit integer constant. Integer constant, lower integer, constant. The selection of the proper constraint depends on the range of the constraint constants or registers, which must be acceptable. C compiler doesn't check any line of your assembler code, but it is able to check the constraint against your C expression. If you specify the wrong constraints, then the compiler may silently pass wrong code to the assembler, and of course the assembler will fail with some cryptic output or internal errors. Oh boy, I can't wait! For example, if you specify the constraint R, lowercase, is any register, and you're using this register with an ORI instruction in your assembler code. An ORI instruction in your assembler code. ORI. What is ORI? Oh, that was logical OR with immediate, wasn't it? Yeah. If you specify R and you're using this register, does it mean operate?
This is your inner voice. This is your daily reminder. You are cute.
No! It is not my inner voice 1 second. One bit. Thank you for the reminder though. You will never choose thank you, Cabbage. Then the compiler may select any register. This will fail if the compiler chooses R2 to R15. You will never choose 0 or 1 because those are for special purposes. Okay. Thank you, Kings. There you go. Oh no, not the... Yeah, kid. Whoa. Shut up, inner voice. I don't want to hear you. Go away. Whoa. There we go. That's what she sounds like. No, that's what I sound like talking to her. Guys, I'm trying to say the goodness. I wish my inner voice told me that. Why would that fail then? Because... like this requires... Wait, ORI. Where is the logical OR with immediate? Like why did... I'm so confused. What's so special about... What's so special about R2 to R15? Huh? And if you use the constraint M is 8-bit constant, the compiler will make sure that you don't pass anything else but an 8-bit value. Okay. So there's no way that you can... Wait! Does this mean that I can just this mean that I can do // here? And this will just automatically go into this slot? I take it that Ori can't be used with the lower half of the registers. Apparently not. Who knows why? I didn't see that in the datasheet, but... And this is a constant. And you can specify... thank you, the plus check for hydration. Also, welcome back, Stu. Stu, do you have any idea how to pass things in from Sealand? What that means from the thingy's point of view? Assemblies? Do you feel that? Oh my god, I can't. I'm just crunching this lid against the little thingy. Yes, either that or how do I do it myself? If it's like, for example, thank you for that, by the way. I'll save the, I don't actually need to save the kidneys right now. I'll save the kidneys on the next one. Hold on. Moderation, not moderation. Reward queue is loading, please wait. Okay, refunded. So for example, I mark this as X. Does that mean that this pointer then gets stored in the X register, or do I need to move word, because it's a 16-bit pointer, into R26, which is the lower one of this pair, the value from %0, which is the 16-bit pointer. So basically move the 16-bit word that's stored who knows where into X. Like, I don't really know what this means, because you can't specify the register that you want it to be in, right? You can just specify a range. Like, you can say, I'm gonna put it in one of these, but like, to actually make use of it. You know what I mean, maybe. I think use equals before the X. Really? Oh wait, I thought isn't that when you set the output? But okay. Wait, where's the equals? Equals. I've only seen the equals show up on the outputs. Oh, there it is. Write only operand, usually used for all outputs. Read write operand. Register should be used for output only. I don't understand what any of that means. Input operands are, you guessed it, read only, but what if you need the same operand for input and output? Okay, I don't. So is an operand the word for an input or an output? Like, is this an operand and is this an operand? Also, I just remembered that somewhere it said that you can name them. Like this, I guess? Oh, wait, no, it's not. Hang on. Where's the name? Where is it? Somewhere near the top. There we are. Operands can be given names. The name is prepended in brackets to the constraints. Prepended. Excuse me. Oh my god, I'm flipping dying here. Both are input operands. Okay. Names. The name is prepended in brackets to the constraints in the operand list. In the operand list. Prepended in names to the constraint in the operand list. Square brackets then, like this. Okay. So I could give this a name. Oh wait, I could literally call this. Wait, I could literally call this LED data cur then. And I could call this... Sorry, this is the length size of LED data. Don't think I need anything. So I don't need to move it. I don't need to... LED data car X. Like, I don't know where this sits currently, but I guess I don't need to worry about it. I guess. This is constant, this goes in there. In this occasion, I guess I don't need to. I can easily see how in the future there'll be situations where I don't need to. The M is, I put the M because it's a constant 8-bit value. Or I want to like, interpret it as that. I guess I could go as num LEDs. The X will put the value in the X register. Okay, nice. Nice. Okay, and so we're gonna modify that though. Like, this is gonna be modified when I do this. So I guess I do need to read that bit at the bottom that says about modifying it. Wherever that was. Read, write are not supported in inline assembly code. For input operators, it is possible to use a single digit in the constraint string. Using digit n tells the compiler to use the same register as for the same register, starting with 0. Oh wait, this is for input and output, not for reading and writing. This is for input and output. Is that the same thing? The M will need to be referred to with a %0 or %1. The M constraint will need to be referred to with a %0 or %1. Or I guess with this now, right? Because I think it said that I can refer to it with like this. Yeah, like this. Maybe. Let's see if it works, I guess. So instead of, so this size of LED thingy was going into R19 before, but now let's just try doing this, I guess. But this is comparing a register, but now I want to compare it with an immediate. So I'm guessing, is there a CPI instruction maybe? CPI in capitals. Compare with immediate. Yeah, okay. So CPI I think is what I need there. This insert mode might actually be useful here. R20 is just completely internal. So now we're not gonna be using R19 at all. We can get rid of that. R26 and R27. Do I need to mark R26 and R27? Yeah, I mean we are going to modify it, but it's going to be data that's already been set up by C. So I'm guessing it doesn't matter if we modify it. If you modify X, I think you need to also have it on either output or clobber, so C knows it's changing. Okay then.
Cheese.
I'll have it on the clobber. Are you able to put X here instead of R27 and R26? I wonder. Thank you for the pats. Why the cheese though? There's something like sub RXXRXX. Sub RXXRXX. Declare it to 0, then add RXX %1. I would need to know what those instructions do. But yeah, %1 would wait. Is %1 is ADU is the second parameter of ADU an output or something? Yeah, okay, so this is inputs. Can I do it like this? Can I see outputs, inputs, changed by us? Add immediate word. Oh, okay. An immediate value being a value specified in the instruction. A literal, okay. So that's why I was specifying an immediate here, and then using CPI. I hope I'm doing the right thing there then. So this means that we don't need to copy a thing over, it'll already be an X. This is an immediate. LEDs. Okay, so LED data, so x, 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 x. So instead of x, would we be able to do this? If the thing stored in x is now called this, I wonder. Start with subtract. Rxx is just some register I didn't specify exactly. Can be R2 or R15. Yeah, I did CLR, which apparently sets it all to 0. Okay. Start with subtract. Okay, so you're subtracting. Oh, I see. You're subtracting x equals x minus x. That is a fun way to do it. Funny way. Okay. Let's try the backslash and backslash t on the end of everything. To make it more readable. I'm gonna put it over here. Whether that's actually gonna make it more readable or less readable, I'm not sure. Oh, whoops. Start. This might need to be on the same line as the one below. I've never seen a label by itself. If this works, something is wrong with the world because I'm very confused. There's no way this is gonna work. Thank you for the pad 6. Hi, Exia. How BS the X. I very much appreciate pants right now. Not that I don't usually appreciate pants, but it's kind of distracting my eye, pulling my eye away. It sounds gross. Making me. This is catching my eye more than this when I'm trying to read the comment. Okay, so R16, R17, R18, R20, X inputs. That. Oh, so this is not going to be R19. Okay, let's leave that. I do need to make note. X. How does it keep on going into the American keyboard layout? Well, X register is actually R27 colon R26. Okay, let's see what happens if I press compile. Unknown register name X in ASM. Okay. Unknown register name X. Is it able to say exactly which line now? So it actually doesn't know X. So I guess I have to specify it manually. R27, R26, or is it this one it's complaining about? Oh no, that's a constraint thing, isn't it? Can't find a register in class. Point to X-regs. Wow, it actually doesn't seem to know anything about an X register, does it? Wow, it's acting like there is no such thing as X. Interesting. That does make it sound like it was trying to store this into this, which is very nice. I think you can use plus X in the output part to specify it as both an input and an output. Okay. Well, the problem right now is that it doesn't seem to understand X as a concept at all. Or if I specifically say R27 colon R26. Matching oh, right, sorry, that's not a... Never mind, that's not a... That's not a constraint. LED data code is an input. Yes. LED data code is an input. It's a pointer. Just set up here. I'm trying to make it, put it into X. Otherwise, I was gonna try to just move whatever this is, wherever it is, into register 26 and 27. X, in other words. Well, I wasn't expecting it to not understand that X is a register. I don't know if that is what's happening, but that seems like what is happening. A very non-descriptive error. Well, I mean, because X reg is like X meaning this, right? So if I were to put Y, it would not understand pointer Y regs. I'm assuming is what that means. Oh wow. That's completely different. Oh, I guess I need to specify them here maybe. Pointer Y regs maybe. R28, R29. R28, R29. Yeah, there we are. Now pointer Y regs is the problem. Do plus X in output. Plus X, okay. I just want to see what the plus does. Oh, is that why? Because it's thinking that if I'm modifying these two, then it's not allowed to put this into it. Is that why? Okay, let's put that back to 27 and 26. So X in there, but wait, we remove this now. Remove this, remove this. Plus X in output. Move from input to output. Wait, really? Move it from, really? So like this? Plus marks an output as also an input. Okay. That's what I was about to try to look up in the thingy. What it means. Okay. Outputs. Plus blah means blah is output and input. Okay, let's see what happens. Pointer register X, Y, or Z required. Pointer register X, Y, or Z required. Well, garbage at end of line. Garbage at end of line. What? Is the error on the assembly itself? Yes. Assembler messages. Oh, there, yeah, it does say garbage at end of line. Pointer register X, Y, or Z required. I know what that means though. Let's have a look. Oh, this. Wait, is this the third time I've this loaded? It's not. It's... Oh, it might have been. I closed the other one, actually. Remove the spaces \n \t from the last ASM line. Oh, that's nasty. Garbage at end of line, pointer register X, Y, or Z required. Try opening the .s file. Oh my goodness, ready? Okay. computer is running at a snail's pace. CCA5NN. It does not exist. I'm afraid. There is no such file there. I guess it deleted it afterwards, I'm afraid. It's percent name. Percent name. Percent name. What did I do then? Oh yeah! Right! And you, yes, I see now. Okay. Percent that and percent that. Okay. And see what that does. Same thing. Pointer register X, Y, or Z requires garbage at end of line. I don't know. Let me see. Yeah, same line. Plus X. 16, 17, 18, 20. 16, 18, 17. And 20. And 20. I wonder if it's this. I wonder if it's because you really do need these all in one line. Let's see. Nope, still... Oh, it's one line earlier now. So, wait, this is a way to find out which line is the problem. Because it's one line earlier. Okay. Let's just insert another empty line somewhere. Blah. Okay, is the problem before this line? Still line 291? Oh wait, no, it's the other way around. Hold on. Okay, what is it now? Isn't NT required? There is NT. 291. Here. Now it's 292. Now it's 291. Okay, so something above here. Now it's 291. Now it's 291 still. Wait, is it this? Is it because there's a... Is the problem that there's a comment on a line by itself? Oh no, okay, never mind. No, wait, it's still 291. No, it's 291. Wait, am I crazy? What am I doing here? I'm chasing this area around. Okay, 292. Okay, so the problem is this line then. The problem is this line. It's probably the LD with the plus. Yeah, it is. Since that's the one place where I think you have to use X, Y, or Z. Can't get removed much before. Okay, nice. Data car. Plus. Okay, what's it saying? Pointer register X, Y, or Z required. LD. Mode indirect. DSX. You try the suggestion to use X directly. X plus? Well, making it work properly would be nice. True. Yeah, X plus is what it was originally. Let's try it, I guess. It compiled. It's a bit strange how... Oh, whatever, everything's strange. Who knows if this will work though. Thank you for the pats. There's extremely little likelihood this will work still. Thank you for the hydration though. And then, oh my god, I just almost dropped it.
Cheese!
Thank you, both of you. Celebratory cheese. No! I need it. I don't need... In the voice of Cat singing the song. Okay, so... Shall we try uploading it and seeing if we just get 24 pulses? That's all we should get at the moment, 24 pulses, and like maybe they'll be like fractionally longer if it's a 1 or not, but whatever. 24 pulses is what we should get. Upload. Alright, it's uploaded. Let's get the probe. And make the scope visible. Oh, it's you? Okay, let's see. Weighted percent name. Also, I'm supposed to put the name inside. Do %A name. %A. And %A name. %A name. Wait, where did you find that? Is the secret still? Oh, it is still there. Yes. Oh my god. Thank you so much, Ericsson. Holy. Same place. Inline assembly. %A. Oh, this? Print pointer register as address X, Y, or Z. Print pointer register as address X, Y, or Z. Like in %A 0 plus. And this is a modifier, print operand modifier. Wait, where do I put %A's? Wait, what does it do otherwise? I think it prints R26 or whatever otherwise. I mean, that is an extra register, but okay, okay. I mean, like this should work as well then, right? I should just be able to do this, shouldn't they? If I just don't do the increment, in case. Oh, it doesn't actually work. Very interesting. Okay. So not just interchangeable. The way it was written in the thingy made it sound like they were the same thing. Okay. So %A name. This is extremely cryptic though. Let's see if it works there. Nice one, it does work, but there's no way I'm gonna remember what the hell that means. This is much easier to understand for me. And the plus? The plus was implied by the %A. Right? It would seem. It wasn't? Oh. Okay, well, that works as well. What if I had a second plus? That doesn't work. Okay, good. What error does it give? Garbage end of line. So rude. %A. So, what happens instead of... So should I just be doing %A all the... Could %A work all the time? Well, no, it wouldn't work in this one, would it? Because it's not a... Ah, it'd only work for pointers. Okay, it'd only work for pointers, I guess. So what does it do otherwise? That's what I'm really curious about. Oh, right, you said R27, R26, didn't you? But, like, how else can you print a pointer? Like, Check the suitable constraints. X, Y, Z, B, and E. Okay. I don't know what B and E is, but yeah, okay. Every Python programmer to C programmers. I don't know what I said. Sorry. This is getting very cramped here. Why do I keep pressing it twice? Can I do this as well and it still works now? Yeah. Scroll up 2 tables to check B and E. Base registers Y and Z. Point registers X, Y, and Z. See, this... Oh! So now because... okay, so this is when you'd want to do it. This is when you'd want to do this. If you're okay with it using any of these registers, which I am, I could just do this, I guess. Right? And then it'll choose whichever one it works best for it, right? But it'll still be an X, or Y, or a Z. So that should just work either way. I guess. It does work. Okay. So pointers go into X, Y, Z registers. Or pointers must go into these. E equals any of X, Y, Z. I wonder what base registers means though. Also, I hope. Oh my god, okay, I definitely pressed Ctrl S out of habit by that time, by myself. But out of habit by mistake that time. I do wonder what base registers. Wait, base registers are not the same as. Oh, Y and Z. Yeah, it is 28 to 31. I'm wondering if like X and Y. Like, I'm wondering if like this one is faster or something, or these ones are faster or what. I'm just a little bit worried about. Mind you, this says, oh, there are notes here actually for about the speed. Let's see. Oh, it's a fake thing. It's not. Oh, there we are. RAM cycle times for data memory access assumes internal RAM and not valid for external RAM. That's fine. That's internal. Okay. Okay. Percent means name will be replaced with X/Y/Z rather than raw register numbers created by LD, apparently. Okay. Oh, you can't even see the flipping short novel I'm typing there. Thank you so much. What the hell? Okay, just compile this time without the C code. Okay, and it's uploading. And it's uploaded.
Jeez!
Who's cheesing me? Who's cheesing me? Chaos! Okay, let's see if this works. Let's turn this back to being triggering. Wait a minute. There we are. Okay, let's see what happens when I press reset. Let's try and make it get a better connection and press reset. It would appear that nothing is happening, but let's take a look just in case. On this view. Thank you, the positive cast. Yeah, nothing's happening. Unfortunately. You can see the input goes down from memory when it resets. Okay, to the surprise of absolutely nobody, this doesn't work. Unless that right there was... hang on, what's the scale? 2 volts per division, no, this should be big. Wait, something happened there. Oh, it's not happening now. Yeah, I think this is just random shit that's happening. Oops. I will stretch in a moment. is that capturing? Where's the... Oh, it's just around there. Yeah, there's nothing happening. Yeah, I saw that. Thank you, Stu. The 2560 is the aviary plus. And aviary. That's one of the few things I actually managed to work out earlier on. Well, I thought I did. I could have still been wrong. It's nice to have your confirmation. Close this now. Close this. And I've got the same thing open twice. Okay, I've got a bit more space in my taskbar now. Okay, so this doesn't work. Like, at all though, which is weird, because we're not... Oh, wait, are we setting the... We are setting the DDRF. Okay, this is weird because... As long as this executes, well, I mean, I guess this might not be working, huh? Let's see if that works. If we just do an ASM just to turn a port on and off. Maybe that's a good idea. I mean, you don't need to pass any inputs. ASM, volatile. And we'll... Out 0x11... Oh, I guess we gotta do this again, haven't we? Oh, never mind, we do need to do clobber warnings then. This is actually one of the examples almost in the thingy, so... R16 is all zeros, R17 is all ones. We will, output to 0x11 17 or ones, and then the same but it's R16. So this is port F equals R17 and port F equals R16. Let's see if that even works. But we need to do the clobber thingy. So this is no outputs, no inputs. This no outputs, no inputs. Changed. That's not a 16. It's not a 16. Thank you. I wonder what it would have said. Garbage at end of line, I guess. Yeah. Okay. So we should get one pulse. I'm guessing the problem is with the port. Either that or... yeah, who knows. If the problem's not with... If this works, then I don't know. I don't know what it would mean. Would it be a good thing or a bad thing? Okay. We are probing and I'm pressing the button. And it doesn't work. Interesting. Yeah, we're getting nothing. Did you set the port as output? Yes, I did that here. Then we're just turning off interrupts. This is not needed anymore. I'm assuming this wouldn't make it crash. But I guess I should be moving this up here just in case. DDRF is data direction for port F, and the value of 0 is input on a bit, value of 0 is input and 1 is output. Yes, it should be. Like, it should be the thing that corresponds to port F. Like in the other thing, this one. When it was happening before, I did DDR-A for setting port A, and also DDR-C. And then I could write to it with port A and port C if I remember rightly. Port A and port C somewhere, I guess. What is it defined as? I don't know. I don't know how to find where it's defined. I mean, I searched every H file before and there were many results. I guess let me reopen that folder again. Downloads, MISC. Hash define DDRF. Lots IO43U. What are these files? This is very small text. There's DDRE being defined. I think it's this one. Pins underscore Arduino. Constant. This is not defining DDRF. This is using DDRF, right? This is where DDRF is defined. And it's defined as underscore SFR underscore IO80X05. An extremely tiny text. Which I can't zoom in on. But like, which one of these is it? Who knows which one of these it is? There's a million different things it could be. It's an array at some position. I'm assuming this is a macro. Let's see what underscore, wait, where's DDRF? Here, let's search for underscore SFR underscore MEM8. IOM underscore 2560. No, I can't sort it. 3250 256. Maybe 256? 2564 RFR2 256 RFR2. Let's just see what this is. Maybe it's the same. DDRF is there defined as 0x10. Oh, I don't know what it was before. I didn't copy the fucking Well, this one says SFR MEM, SFR IO8, and this one just says SFR MEM8, which is interesting. This one is IO8 0x10 as well. Let me just gather. Maybe we can get like a group consensus of what it is or how it changes. These both say that it's this. The random one another random one defines it as this as well. But something didn't. The one of the ones I tried before was different. There, this one's different. This one's defined as that. Anyway, IO8 0x10, let's see. There was this huge table somewhere near the bottom. I don't know where it was. I'm going back through the history. Oh my goodness, I'm sure it was there. No, yeah, yes. Wait, it was something about a summary, wasn't it? Was that called register summary? Nope. Just summary? Oh wait, hang on, am I? Yeah. Register summary. This looks like it. Yeah, this one. Okay. Okay, 0x10, 0x10 is DDRF! There it is! Okay, nice. And that's the bracket names. When using the IO specific commands in and out, IO addresses... Oh! Oh! I'm using the wrong ones! Hang on, I'm using the wrong ones! I should... when instead of 0x11, I should be doing 0x31. Let's see if that works. Doesn't look like it. Nah, that doesn't work either. Yeah, I'm getting nothing there. LD and ST use the plus 20. When using the IO specific commands in and out, the address is 0 to 3F. Oh, where did I just read 30? I thought I read something was 30. I don't see 30 on the screen anymore, but I thought I read 30. Well, I don't see it. Thank you for the follow, 6dbw. IOM2560.h. Does that exist on my hard drive? It does. IOM2560. IOM. Yeah, it's not showing up in here. I wonder if it's indented differently. IOM2560. DDRF. The DDRF is not in here. That's everything. Is it including something else? Including IOMXX0_1. Which is here. DDRF. Okay, here it is. And port F 0x11. Well, _SFR_IO8. I don't know what that is, but _SFR_IO. Okay, I don't know what that is. Is there a definition for that? Like, is it a macro? I'm assuming it's a macro. I don't know if it is. It is a macro. SFR_defs. This returns this. Oh, the macro's all the way down, yes. Hi, 60. So, this is what we have in the end. If I can get rid of the goddamn oscilloscope, please. So this equals whatever IO address is plus SFR offset. Okay, what's SFR offset? Let's find out. Please be defined. This is also an SFR def, so okay. It's the same file. 0. Amazing. It's defined to be 0. So it's just 0x11 in the end. It's just 0x11 is what DDRF is. DDRF literally maps to 0x11. We've come to the bottom of it. We've reached the concrete truth, finally. Wait, was it 0x11 or 0x10? Hold on. So DDFR does that. Wait, what do you mean? We need DD. No, I've never needed to do that. Earlier on, I was outputting to the port. DDRF. D. Hang on a second. Was it? This is saying 10. Why am I saying 11? Oh, because 10 is DDR and 11 is port F. Okay. if I directly output to the port, then it works. So I guess I can double check that that still works. Let's just do the equivalent. Port F equals 0x FF. Port F equals 0x00. Boop. And reset. And I'm no longer seeing anything. That's interesting. I'm seeing nothing now. That's very concerning. DDRF. Did the probe disconnect? I flipping hope not. Unplugging and plugging back in. And reset. Now you can see it go down for a moment when I press reset. At least you could if these cursors things went anyway. There it goes down and then back up. Let me see what that maps to. I have a bigger problem right now. The basic how things should just work is not working. Port F. Why does it say analog? This should say analog. Oh my god, I've written analog the entire goddamn time. What the fuck? How long has that been like that? That must be so long. Amazing. How have I only just noticed that typo? I understand what you're saying, but like that's not how I used it in the past. Right? Right? You have a pin mode in the... Yeah, on one of these. And similarly for all of the outputting, we're just doing the port C and stuff. Don't know why I'm getting nothing there anymore on the outputs. That's really weird. This code was working before, that's why it's there, because it was working. No? 60BW? I'm afraid. It feels like if it feels like if it is as I think, it should have at least have a warning. Yeah. Well, yeah, there's a big problem now because it's just, I don't know, it's not working. Like at all. The most basic of basic things. You see me fiddling with the probe in my hand. Yeah, I know it doesn't check assembly code. This has nothing to do with assembly now. This is just the basic DDRF equals this, port F equals this. And this is now no longer working. This is... Let's just literally put back the original code. This is the original code. I didn't mean to click that, but okay, it works. And press reset. And yeah, it no longer works. Let's just disconnect power on the Arduino and reconnect power. Like actual proper power. And try again. Yeah, it just doesn't work. Wait, now it does? Wait, hang on a second. What the fuck is going on? Is that just random? Is it just random? Let me stop probing to this ground. I think there might be something wrong with this ground pin that I'm trying to probe to. Let me probe to a different pin on the port, which should be being pulled to ground. It's easier said than done. Okay. Now reset. Try again. Alright, fuck it. I'm not gonna use this spring. This is silly. Let's just use a proper flipping clamp to ground with the alligator clip. This is gonna be a noisier reading, but I'm gonna have a guaranteed ground because I don't know if whatever. There's all kinds of weird shit going on, basically. I'm gonna need to get my multimeter for a sec, so I need to see where there's a ground that I can clip onto. Let's see, is this ground? Nope. Is this? Nope. Oh, wait. Yeah. Okay, I can't easily clip onto a ground to get to port F. But... oh yes, I can. It just about reaches. This is very hard to do though. I'm gonna damage the clip, I think. I do it this way. Ah, that works. Okay. I got it. Alright. Okay. Let's press the button. Oh, it's also cutting power, I guess. Could be useful if I wanted to do anything. Okay, now I'm seeing absolutely nothing happening. Like, absolutely. Is that grounded even? Yeah, I'm not even seeing the power drop low now when I press reset. What the fuck is going on, man? What is happening? And nothing's like, I'm getting nothing. What the fuck? Huh? What if I probe the 5 volts pin? Okay, there's 5 volts. I do have a connection to ground. What if I probe 3.3 volts pin? Okay, that works. Now back to this other port. What the fuck? There's nothing. How long is the pulse you're expecting? Now, how confident are you with it? I'm pretty sure this scope shows the, Does this scope not show the max? Maybe it doesn't. Maybe it's right there. Maybe every other time I thought it had, but okay, whatever the fuck. Anyway. Here's a pulse. Amazing, okay. And here's an extreme... well, here's all the pulses, actually. Okay. Well, thank you, 6dBW. I guess the rolling view does not show the max. I thought it... Wait, did I fuck around with the... Wait a minute. Can't remember where the setting is. That might be it. I wonder if that's it. Hold on. If I change that to peak detect... do I see that when zoomed out? I do not, actually. Do that. I do that. I do that. This is very slow scrolling speed now. I do there. Wait, okay. But surely it wasn't on peak detect originally, was it? Did I accidentally change that? Maybe I changed that in the past. Maybe it was normally on peak detect and I changed it to something else. Anyway, here it is. Thank you extremely much, 60BW. I thought I was going crazy there for a second. Well, I mean, I was, I guess I remember. Okay, so let's go back to controlling port F now. Let's just zoom out. Well, go to roll. And upload this. There it is. There's our spike. Yep, it's right there. I am saying nothing now. It was there for a moment. The trigger is here. There it is. What? Why is it so unreliable? I'm so confused. Oh, is it because the position wasn't centered? It might be the position wasn't centered. Okay, I think the position wasn't centered. God, there's so many mistakes I'm making. This is crazy. Okay, anyway, we're right into that now. Okay, so that works. And this worked. Now, let's see if this works. Maybe this worked all along and I was just probing wrongly. How funny would that be? How I would laugh. Let's upload. Well, it does do something. Let's zoom out further. It fucking works. It works. And the first 1, 2, 3, 4, 5, 6, 7, 8 spikes are higher than the other 8 spikes, as I said, might be visible. Okay, this is just working. This is just working. Amazing. Now time to measure. So ridiculous. Oh my god. Okay, let's... What the fuck? Let's see if I can zoom in and see how long these spikes are lasting. Let's just see how long the entire loop lasts for a start. Alright, let's measure from the moment we go high to the moment the next one goes high, I guess. 566 nanoseconds, so that is absolutely okay. All of these ones should have a longer one, and the later ones should have a shorter one. And we want to insert some no-ops between here and here in order to stretch. Oh, actually, no, I need to look at the later ones, actually. I need to look at the later ones. Hold on, let's zoom out. The later ones should have the short thingy. And the first ones, because they're ones, should have the long thingy. And... okay. These are the short ones. So this is, if we measure to there, from here, 560, okay. But this spike, which is very, very short. Holy shit, is that 1 clock cycle? This is 64 nanoseconds. This is... what the hell? This is 1 in 1 clock cycle. It's turning the pin high, and then in 1 clock cycle it must be turning it low. What the hell? I've never seen such fast stuff. This is the time you're seeing there, 64 nanoseconds, is the time between each clock cycle. I mean, 62.5 is 1 clock cycle. We looked at the wrong define. SFR IO address subtracts the 0x20 back. Oh? This is 0x11. Yuki, we are looking at the wrong define. What the fuck? Oh no. But in any case, the code was correct all the time, and the probing was the problem. I find that even more ironic. I haven't even modified this code, and somehow it seems to have worked on the first attempt.
Bits go new.
Bits go new? Bits? Yeah, I guess. Yeah, they do. Right. Yeah. I'm banging the bits. Thank you so much to everyone who's helped. I feel like at this point, it's relatively easy. Just inserting knobs, but I still want to do it. So back to the drivers. I never thought I'd see the day where I switch back to this. So we need to insert some knobs so that this spike lasts 220 to 380 nanoseconds. And I assume the instruction is literally NOP, but let's double check. Look at the lag on my computer. This is not a bloated program. This is just standard things that are so slow. No operation. 1 clock. Okay. Thank you for the patch 11. TLDR, the table in the app mega documentation was correct all along? Yeah, it was. MMIO byte does define MMIO byte. Blah, 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 blah. So MMIO byte adds the asterisk and casts it. Oh, okay. Oh, okay, I see what you mean. So knobs here. So we'll insert a knob. There's one. So this is 1 clock cycle. So this currently is 1 clock cycle, and that's 62. And we need this to be extended to by like 4 more cycles, I think, or 3 more cycles. Wait, 120, 180, 240. Yeah, I think 3 knobs should do it, right? Okay, are you ready? Let's see if these are too much conditional combination. Oh, it's alright. Look at that! Okay, they're longer now. I'm assuming that these are the slow ones. That's because everything's going to be wide now. Okay, let's zoom in. 1, 2, 3, 4, 5, 6, 7, 8. Okay, we're still looking at the later ones. Let's measure this. How long is this pulse now? This is so fun at this point. This is where it's becoming super fun. Okay, this spike is now about 244 nanoseconds. And that is within our range, 220 to 380, and we're on the really lower end. Okay, this is so cool. Ah! This is really exciting to me. Okay, nice. So we've got at this point we actually might have 0 bytes working. I'm not sure if the off time is enough, but let's have a look. The off time is 502 nanoseconds. We're actually a little bit fast. 502. I'm gonna slap 2 no-ops down here then. And try again. Okay, it's changed. I'm just gonna zoom out to make sure I'm looking at the correct bytes. Maybe that way a bit. And zoom way in. And take another thingy. And let's measure. So, this is awesome. Oh my god, I've never done this before. This is so cool. So now, 1 on spike is lasting about 248 or something. I'm measuring it slightly differently. And the off time is 628 or 632. So right there, what you're looking at right there, right here, this is a valid 0-bit for a WS2811. We've flipping got a valid 0-bit in assembly. Now let's see if our 1-bit looks correct. Let's take another look. This time we're gonna look at the beginning of it. Hold on. I'm once again not getting another capture for some reason. Oh, there we are. Okay, this does not look wider than it looks. Doesn't look like wider on the top than the bottom. So, well, let's have a look. The on duration is 432. So this is wider than the other one. Where are we? Hold on, I'm lost. Oh, I'm already on here, so I was looking around. I'm tired, okay. So this actually needs to be 580 nanoseconds. So what I'm actually gonna have to do is extend this a little bit. Because I can't extend this anymore, or else the 0 bits would get... Well, I mean, I guess I could. But if I add some here, this is gonna mean that the extra off time at the end of the... This is gonna mean that the extra off time at the end of a 0 bit is gonna get longer. We are very near the low end of 640 if I'm rightly. That's gonna make this get a bit longer. But it's also gonna make this get a bit longer. Which is good because we're not in the range of this yet. So 432, so adding 2 will add 532, 542, 552, would still be slightly short. I think I have to add another knob. Let's see if that works out. So if I'm right, this should make our on time become about 432 plus 63 plus 63 plus 63. Somewhere around 620, let's see. Let's see if that works. Upload. Oh, I typed calc on here because that's not many hadn't been nice. Okay, let's expand it. Expand DOM. There it is! 620! Holy! That's pretty good. So now the on time is valid. We're in range. And the off time needs to be 220 to 240. This might be out of range, but let's see. So 220 to 420, I said 220 to 240. There it is. Oh, it's just barely allowed. It's fractionally too long, but I think this will be okay according to this. If I'm correct in the stuff that I said earlier, in the when you do a high thingy, it's probably okay if you lag slightly behind. You can move some of the code that does the loop in place of the knobs. Oh, I could! I totally could! Right, we've already used the value at that point. We've used the value here. Right, R18 is the value. Yeah, you're totally... Oh, that's such a good idea. Yes. Thank you, thank you. Is it okay to separate your branch and your compare instructions? Like, can I do an output after? Like, can I go do compare and then out and then branch? The branch checks the flags. Does out change the flags, I guess is the question. Oh my god, Nintoya! Thank you very much for the hydration. How are you doing, Nint? Oh god, I haven't seen you in ages. I was just talking just earlier about Twitch having forgotten me following you like 3 times. I didn't actually say it was you that I was talking about, but it was. I've been missing your streams. I'm glad you're still around. Hope you're doing okay. Looking forward to a new Nint stream sometime whenever you're ready. Shouldn't change flags. Okie dokie. Thank you for the posture check as well. Looks good. Oh, okay. So it's things that use things that do maths that do that. Okay, at the very least, we could put this increment in here. That's such a good idea because yeah, we're getting like an overhead at the end where we're branching. Oh. Hold on. This, yeah, no, that is correct, isn't it? Wait. This is the on time. The off time at the end. Oh yeah, I think let's just see what happens, I guess. If previous CPI determines. Listen, I think you have to add the flags on the clobbered stuff. Instructions PDF says which. Hang on. Hi, Nint! Doing great. Are we streaming soon, you think? Oh, fuck yes. 15 minutes? Nice, I'll be there. I'm joking.
Cheese.
Trying to get back into talking to the people I liked again. I hope you're well. Oh, wow, I'm honored. What the hell? To be included in that demographic. I'm not doing too badly, thank you very much. Can't believe Yuki will get to raid Nintoya today. I know, right? Let's prepare it. I'm sorry, I'm not trying to like stress you or something. Instructions PDF says which flags things change. Add flags on the clobbered stuff, really? I mean, nothing should be executing between here and here, right? Or are you thinking that this is like wrong for a different reason? Not for... Oh god, I should do that. I should go and save the kidneys. Which means go to the toilet. What I'm working on, it's a bit of a long-winded thing to explain, but TLDR, I'm trying to control basically a string of LEDs very manually. There's like, you can get these RGB LED strings and they have like a little driver chip on them, and you got to send pulses to one of the pins at the right speed and stuff to basically send data. You're basically sending RGB values. I mean, you're literally sending RGB values. There's no simplification there. And in binary, just 3 8-bit values. And like the 1 bits and 0 bits are different lengths, and I'm trying to write assembly code to get the exact right timing for each of those. And the reason I'm doing this is because I am making a circuit board, which looks a little something like this, because I already had a prototype made, and it doesn't work, but don't tell anyone, but it looks cool. It doesn't work though. Hold. There we are. And then I did some testing, bunching it in a way to make it work. Anyway, TLDR, I'm going to be changing this whole board probably to work in a different way. Much simpler, less expensive, and lets me dim every LED this old way that I've been doing it here. Didn't work. But yeah. So essentially the new way of working is just basically going to be that this circuit board is one very weirdly shaped LED string, or in fact 16 LED strings. So what it is it's going to like show the volume and like reverb, chorus levels, all this stuff of a MIDI file, MIDI music file while it plays. So you get to see stuff on the right flashing when certain MIDI messages arrive, and you get to look here and see what the panning is and pitch bend and the bend sensitivity and all this good stuff. And so the code I'm writing is to basically output the data for 8 of these strings of LEDs at once. There you go. That's the condensed and slightly meandering explanation of what I'm trying to do right now. And the oscilloscope view at the top right was showing the outputs of one of the such outputs which will be going to one such string of LEDs. And I'm measuring the lengths of the pulses to make sure that it's would be valid to the LEDs. I actually have a tiny LED string right here, like an actual LED string, which uses the exact same driver chip that I can connect to the Arduino and the pin. And if this code works, then well, the LEDs should do stuff. I'm not quite at that stage yet though. How goes the wiggles? The wiggles, they're wiggling, look. Wee. I mean, wee. Now get back in view, please. But hi, Akinyanya. Yeah, the stuff is going quite well. I've just sort of had the bit of the breakthrough moment just 5 minutes ago, with thanks to people and not least for their patience and stuff. I have to be right back though, because someone, Donketa, had to save the kidneys, and it actually has been a while since I've been to the toilet. Possibly too much information, but hey, you know what's more? Too much information? I'm gonna go to the toilet. Okay, I'll be right back. Please use this as an opportunity to take care of your body and stuff and go to the toilet if you need to. Drink, eat, rest, be healthy, not like me. Okay, I'm gonna be right back. Don't fall in, I'll do my best. Thanks. Really nice to see you again in toilet. I'll be back in like 2 minutes. Onion? I did not fall in. Are you proud of me? I didn't fall in. I can't see anything about. Oops! I can't see anything about the flag, so I don't think you need to. Okie dokie. Heck yeah! Not this time. Not this time. What was I doing again? I think I was about to do a thing. We can probably remove some of these now. Anyway, let's just see what happens. Boop. Timings are gonna change a bit. Okay, so timings look like this now. So the timings that I need is that Chinese datasheet gone. On time for a 1-bit. On time for a 1-bit. Let's have a measure. Zip. Zip. Is 624. That's good. That's within this, and it's on the low side, which is really nice because we can, like, you know, push stuff out faster. And the off time is now way shorter, which is pretty cool. It is now 312 roughly, which is very nicely in between the. Okay, nice, whatever. The 1-bit looks completely valid. You're looking at a valid 1-bit right there. Right between these two thingies. We've got a long on and a short off. Like this. Oh, it's kind of hidden a bit. Like this. I keep forgetting the oscilloscope. Should I make the oscilloscope like see-through? Because sometimes it blocks things and I don't realize. Let me just make it a little bit see-through. Just a little bit. Just a touch. How do you do that? Color correction? Yeah. What if you make it like 90%? Oh, that's quite a lot actually. Maybe 95%? Is that alright? Give me some shaders. This actually is surprisingly see-through at 95% opacity. What the hell? What the hell? What about 96? What about 97? Okay, I'm leaving it. It's not great for the codec, but now if I mean, like, it might look crap. But now if I have this here, you can like see something in the background, so, which is nice. Give it some shades. I am not the shader person. Wait, has Nintoya started doing shaders? I know that he was doing Blender and stuff. Yet, maybe. I saw you. I was there while you were teaching Nova shaders the other night. It was so nice to hear like Nova's happy sounds of things working and learning things. Okay, I've taken another snapshot. Oh, these look fairly uniform. Look at that. They look. Okay, let's zoom in and have a look instead of just guessing. Why can't I get another snapshot? Why am I sometimes just not? I have to like really like push the probe in a certain position. Shaders hurt my head? Okay, not yet. I see how it is. Just like Stewie said, not yet. It was crazy how quickly you learned the Blender stuff though. Like in the nicest way possible. Sorry, not Blender stuff. Sorry, Godot. I mean Godot, sorry.
Jeez.
Well, Blender as well then. Oh, jeez. Gotta go for work now. Bye bye, 11. Bye bye. Let me just clip my arm right through myself. Someone. Oh, let me move myself over. It's probably what. Oh god, this looks awful. But fight. Well, there we are, I guess. Oh no, now you can see my. Now you can see the flipping. The shoulder clipping through. There's no winning. Looks like I'm tweaking the... No, it doesn't look like I'm tweaking the chat, actually, never mind. Okay, how long is the on? The on is 248. And it needs to be 220. Okay, this is fine still. And the off time. Looks like it's gonna be good. There it is. 690. That's it. That's within range. We appear to have valid data. You know what this means? At this point, I could connect up this LED string and see if it actually turns red. Thank you for the pats. Because the data we're clocking out is 8 ones, so that's all the red. 8 zeros, that's all the green, and 8 zeros, that's all the blue. So 2 for 5 red, 0 green, 0 blue. I've done some shaders for trees and some small things, but other than that, nothing yet. Shaders for trees sounds not the most straightforward. Sounds pretty cool though. Trees are quite excellent for providing shade. Hey. Let me measure this again. Measure. This is 624. This is... Yeah, I don't think we can change this easily. I think what we're seeing here is probably as good as we're gonna get it. And yeah, this is amazing to me. This is amazing. Because what we're doing now is clocking out 8 unique values. This might not look like it, but every one of these can range from 0 to 255. And everything in the... We're only looking at the... I'm probing the pin that is the lowest bit in this 8-bit number. And this one, and this one, and this one, and this one, and this one. So at this moment, we can, if I wanted to, I could then combine this with another one. For example, if I made this 3, then for the second strip, this one would have a 1 bit in this position as well. And essentially we can combine, and this is obviously going to be done in the code. I'm not going to be hand doing this, but... TLDR, we're essentially clocking out bits for 8 LED strips right now. Wait, we actually are. We totally are. It is WS2811. You know what? What we're looking at right here... Hang on a second. I'm gonna get a second probe, because I want to probe the second pin as well. Because on the second pin, we should also be getting 24 pulses, but the first 8 should all be 0. Whereas the first 8 on this one up here are all 1s. Thanks for the follow, Tilly. have a second probe. This is used a lot, by the way, on in LED strips. If you search for that, you'll probably find a load of the strips, like Christmas lights, especially coming towards Christmas now. There is an English datasheet as well, by the way. Here. But it has an error. In this table, they show the high time, where they should be showing the low time. Like the table should say short time, long time, short time. But here it just says short time, long. It's... yeah, anyway. I'm glad I stumbled upon the Chinese one first. Otherwise, might have been very confused. Okay, connecting the second probe. Not sure if there's going to be space for me to probe onto the pin right next to the first one, but I'll give it a try. Let's turn on the trace on the oscilloscope. Oops. Where are we? And let's maybe... what are we looking at? Let's move this up a bit. There should be enough space. And this down a bit. Okay, let's connect the grounds together. Clip, get on, okay. And that's pin 1, and that's pin 0, or bit 1 and bit 0. I'm gonna press reset on the Arduino. Let's see what happens. Boop. Oh, I have to do angling of these to try and get them to actually get connection. Two things at the same time. Ah! Hold on, let me just... I'm gonna change transparency back because this is a bit much. Maybe I'll make it 98%. Look at that. This is amazing to me. This is amazing. I've never seen this done on an Arduino before. Look, we're getting the 1 bits on the yellow channel, which is the least significant bit, and on the pink trace, we're getting the 0 bits, which are the short pulses, and they're both coming out at the same time. Look at that! Look at that! And we can do that with up to 8, because there are 8 bits on the port. CLI and SCI are probably added at the beginning and end at some point to make sure there are no interrupts to break the timing. Yes, that's correct. That's correct. CLI is here, and SCI is there. We don't need this anymore. Well, I might keep this because this is the equivalent. Don't need this anymore. Don't need this anymore. Oh, I can't believe this works. This is like absolutely, it's everything I hoped that it would be possible. Look, we've actually got quite a bit of times for free. Look, we're just burning 3 cycles here and 3 cycles here. Which is pretty cool. You're asking her? I thought you made a statement. Oh, okay. I'm not sure. Trying to be a stand-up comic. Good job, Jockibber. Good job, Bibber. Okay, what I want to do now is connect up this LED strip to one of the, well, you know, the bit 0 of port F, which happens to be the analog input 0 pin, even though I'm not using it as an input. And I am just gonna unplug these scope probes. I think I'm done with the probing for today, but just in case, I'll keep the scope on because I don't want to turn it back on if I turn it off, because it makes a loud beep and people are trying to sleep. That rhyme wasn't intentional. Okay, I am holding right here a tiny 2 LED strip. It's technically a strip, I guess. So 5 volts is red, ground is white, and the data is green. Okay, let me just connect this up to the Arduino, and then I might switch over to the webcam, and we can like have the moment of truth together. These are gonna need to become 2D because I won't be able to have face tracking. Let me just grab 3 little jumper wires, like breadboard jumpers. Jumpers have been obtained. let's connect. That goes in there. That goes in there. And this goes in there. Kind of with a little persuasion it gets in there. There it goes. Okay, let's connect them to the Arduino. I'm going to disconnect power from the Arduino, not just because I want to make sure I don't short something while I'm plugging it in, but also because I want to be sure that I'm not going to accidentally spoil myself. And these are only 2 LEDs, so I can just run it off the 5 volts the Arduino is passing through, which is fine. 5 volts. The worst we could pull would be 20 milliamps times 3 is 60 milliamps because of red, green, and blue, and then times 2 is 120 milliamps because there are 2 LEDs. Which is, I would hope that there's 120 milliamps still left over on this USB thingy. I'm not sure though, but I hope so. Okay, it's fully connected up now. We'll check I'm not gonna kill something. Okay, seems good. Alright, I'm going to temporarily disappear. And I'm gonna be in the void for a moment as I do some changes to my system. And since I'm in the void, I should probably sound like this. And I have to do a few things, but bear with me for a moment. Please hold. Now would be a good opportunity to take care of yourself if you didn't earlier. Also, I guess we could go to just chatting while I set this up in case anyone has, you know. Thank you, hydration. I should take care of myself as well. I see what you're saying. I see. Yeah. Well, did you hear that? I accidentally just played a guitar string. Thank you. Thank you for the pat, Stu. I actually just stretched up to pick up a thing, but I've just done it again just for you. Just for Stu. Oh god, I'm breaking things. Ah! No, it's meant to tear. Okay, damn it. Hopefully this will work. Gotta move a camera out of the way. Sorry, I gotta move a keyboard out of the way. This would better work, because if this doesn't work, I'm moving a hell of a lot of stuff just for a letdown. I'm fairly confident it'll work thanks to the oscilloscope. We'll see for sure in like a couple of minutes. I really need to not plug the Arduino in, otherwise it's going to run the code and turn the LEDs on immediately, so let's not do that yet. Move the probes out of the way. Ah. I keep nearly plugging in the Arduino. Okay. Now let me just close some other things because I need to open another thing and there's no space left in my taskbar. I'm gonna save this. I think it's useful for illustrating stuff in the future. Oh, but you can't see it. Sorry, I'm saving the thing that was on Microsoft Paint. Hold on. You know what? It might be a bit of a pain in the ass to become a 2D VTuber at the moment. Like right now. Do people mind if I just don't be 2D? Well, actually, yeah, no, I won't be able to be 2D, I just realized. Well, I can if I just slap it on top of my streaming setup, I guess, but... whatever. You know what? I'm just gonna be frozen. I'm gonna be staring. I'm gonna be a staring 3D VTuber. Which means I can close VC Face for a moment and possibly get some of my computer back. In terms of processing. Suspense. I know, I'm sorry. I'm clicking as fast as I can. Where is it? Video capture device. Bum bum bum. There it is. Oh, this doesn't look too good. Whatever, it's probably okay. Okay. Hi X, welcome. How's the X? How yes, the X. Alright, this should do. This should just do. Hopefully it'll do. It's gonna look a bit weird. Why is the webcam like some square thing that's not widescreen? Oh god. Thank you for bearing with me. Okay, I think it's working. I think it's working. This is gonna look extremely scuffed when I switch scene, but here we go. Oh, there's not even switching scene. Wait. Oh, it's knocked out screen capture. What the? Hold on. Uh-oh. Is it working now? Yes. Ta-da! Ta-da! Behold. I have gloves now. They're a little bit too big. The fingertips are floppy. Anyway. Here's the LED strip. It's 2 LEDs. I'm doing fine just playing Danganronpa on the Vita. Sounds fun. I think I have Danganronpa, but I've never played it. Wait, that doesn't make sense. No, I don't have Danganronpa. Sorry, I'm thinking something else. Anyway, look, it's connected there. It's connected to the power and ground and analog 0 and login 0. Actually, you know what? I can reappear now and stop being silly, but I'm gonna be frozen. There we are. I'm grinning. Okay, nice. I'm just gonna be frozen like that, I guess. I'm very happy, look. Me trying to do a grinning sound. It just sounds weird. Anyway, I'm gonna connect it, and if it works, we should get red LED. One red LED, and the other one should be off. Because I'm only clocking out one 8-bit value. Not quite sure how to get this to rotate to... let me twist the wires a bit to try and force it into an upright position. Is this gonna work? It really likes to be upside down, apparently. What if I just move this over here and then... no, there's no way I can get this to be upright, apparently. Oh well. What if I just wedge this underneath the books? And point the camera down? That works, okay. That works. Wait, what is it? It's like a weird... What the hell? Can you see that? It's like a weird overlay. Oh, wait. Is it transparent? Oh, it is transparent. You're seeing the code behind. Okay, whatever. Anyway, I'm going to connect the power to the Arduino now. If we get a red LED, a bright red LED, then that's very good news. If we don't, then whatever. I'm not fixing it today. Plugging in 3, 2, 1. It's now plugged in. Guess what? We get nothing. You get no. Oh wait, it just came on. Ah! Wait, what the hell? Wait. Why is there a green LED on? Hold on. Wait, what? Lick your finger? No. Wait. Okay. Why are we getting a green LED? The weird shade of red. It is. It also appeared after a while when I just wiggled the wires, which makes me think that wasn't actually data that I sent. Anyway. Let's press the reset button. We, again, just get green. Okay, I'm gonna pull the power. And plug it back in. And wait and not touch anything. Change the data to make it green and see if you get red. Okay, I'm getting green again after a while. That's weird. Okay, well, you know what? You can still see a little bit through this. I'm gonna shrink this view a bit because it's stupidly big and unnecessarily. So let's put that over there, I guess. It's not quite the same size. How annoying. Could order be something other than RGB? According to the datasheet, it's red and then green and then blue. There. So it might, the data I'm sending out might not be quite right. Somehow. I don't know how or why, but there you go. At least there is only one LED. Let's change a thing. Let's change it so that we clock out 3 0 bytes first. Or 0 bits, sorry. No, 3 0 bytes, 24 0 bits. So now the first LED should be off and the next LED should be on. And upload. Too many initializers. Oh yeah, true, right, this needs to be double now. 48. Boop. Holy shit! Okay, okay. We actually we're addressing the correct LED. Holy crap! Okay, that actually surprised me. I thought it was just garbage that it's picking up, but it's actually kind of done it correctly. Anyway, yeah, maybe it's actually not red, green, and blue, or maybe the LED is just wired in a different way. Let's try turning this off. Actually, let's just try keeping only these lower bits on. This should be a darker shade of whatever color that is, presuming that the MSB is clocked out first, like the datasheet says. But the datasheet also says that red comes first, so you know, clearly we can't trust it. Let's see what happens. Boop. Oh my god, it worked! It's a dim green now. Look at it. Holy. Maybe the controller is RGB, but the LED is GRB. Yeah, maybe. I can't believe that. We're actually sending data and it's understanding it. Alright, well, let's turn this off and turn on the second channel then. Let's turn on the second channel at half brightness, just a 1 here because I can't be bothered to type all the other bits. We've got green, and then we have red! And then we should have blue. This should be blue on this LED, and this should be red on the first LED. Oh my god, it just fucking works. It just works. This one's red, and this one's there. I'm covering up. This one's the one I'm not covering up is blue, and this one is red. I can't believe this works. I can't believe this works. This is so cool. What the hell? GRB it is. Yeah, apparently so. It doesn't really matter though, because I'm not going to be using this LED strip. In the end, I'm just going to be using the chip. This is fucking amazing. I can't believe this works. What a victory screenshot right there. I'm even grinning. I'm not really, but it kind of looks like I am. Hey.
Celebratory bits.
Thank you. Oh my god, my head. Thank you very much for the bits. Okay, that is amazing. I'm so happy right now. I can't believe I made it through this thingy right when I, was getting super, I was feeling like my brain was almost dead. Oh my god, that makes me so happy. This is amazing. I'm so happy. Okay, I'm gonna go away now. I'm gonna go away. Don't look like that. I'll get banned on Twitch. Get banned. They'll think I'm not wearing anything. Ironically, hiding the breast area will make them think that I am exposing the, whatever. I'm not gonna try to rationalize Twitch. Are you using version control in your code? Because now it's time to git commit. I am not. That is scary. And stuff. Thank you for the pats. So, is this the time where I should copy and paste? I should make a backup though. Yeah, I should definitely make a backup. I'm not. I've never got into the git. Oh my god! My webcam's getting. Hold. Oh my god! Near the elastic band twanging. Okay. Using Twitch fonts as version control. Streamer privilege. I just have to watch my VOD very closely and type every single line and, you know, make the same mistakes and backspace them again. Okay, I'm back. I am back. And so is the slowness of my computer. Okay, so is the rest tray one part of the LED strip? Yes, it's built into the LEDs on this particular strip. But you can also get the strip, the chip without the LEDs. Basically, there are some 50/50 LEDs that have the WS281 in them. And then you can cut the strip anywhere in between the LEDs, and the strip will just keep working up until the cut point, because they just chain one to the other. Why is my hand stuck? But yeah, that's amazing. I have an LED strip here with 5 pins. Wondering if it's similar. Probably not. This is 3 pins. There's only power, data, and ground. Can't imagine what you'd need. I can't imagine what the 5 pins would be for. I guess ground, red, green, blue, and white, or red, green, blue, and a clock or something. Like you clock and then put data on individually on red, green, and blue. I wonder what kind of protocol that would be. I guess it could be not even digital if you just control the brightness of the entire strip at once. Okay, I'm going to now turn off my scope. This is the sound of a successful night of working on a thing coming to an end. Listen to this. I'm going to turn off the noise gate on my thing so you get to hear the noise that was being blocked all the time. Ready? There you are. Isn't that more annoying? I'm going to press the power button and it's going to turn off. Here we go. Shutting down. It's off. And so am I. I thought that was a pretty good segue. It wasn't intentional, it just kind of became one. Congrats. Thank you very much. I will have to really thank especially Stewie and Ericsson for helping me a bunch. But one of my hands is just stuck. What is this? What is it thinking is my hand? Is it this box? Thank you, Stu. I'm sure other people did as well.
Formaggio.
Help me as well. I'm so happy that this works. Okay, this absolutely paves the way for me making a circuit board. Hey, would you like a sneak preview? Because I already started making a sneak preview. Thank you, Nint. Thank you, Lex. Thank you, Six. 1 second. Because all the time during the stream... Oh my god, my computer is dying! All the time during the stream... This is me just trying to drag a window from one screen to another. Oh my god. Okay, look at this. This is the speed my computer is running at right now. It's in case you thought I was like exaggerating about how snail's pace my computer is being when doing certain things. Okay. Oh, it still says still showing the oscilloscope. Get it. So I started remaking this, or making a new circuit diagram that is this. And we're just gonna chain a bunch of these WS281 ones, and it's calls it red, green, and blue, but cheese. Why cheese? It calls it red, green, and blue, but it's not gonna be red, green, and blue. I am a little curious about whether the data sheet is correct, and it's actually is outputting red, green, and blue, and just this LED strip that I have is wrong, or if actually it's clocked out in the order green, red, blue. In which case, oh my god, I keep having these weird hiccups that aren't quite coming out. In which case, I'd like this to be wired a different way, because otherwise it's going to be annoying. But anyway, basically, we're just chaining these to each other. This goes to here, then there, then there's another one on the bottom to finish up these ones. Then it goes back to the top, and then down to the bottom, and then just chain along like this. And I started increasing the number of LEDs from 1, 2, 3, 0, 1, 2, 3, to having a number 4, a 5th one on the end here for the little bar graph LEDs. And yeah, I think I'll just continue it like this. It's going to be so much simpler than the other ones, like so much simpler. We're not going to need any of this. We're not going to need any of this at all. these are not going to be separate things. The special message LEDs, the ones that just flash momentarily on the far right of the board, will just be part of the normal channel LEDs. And there won't be any output to be chained from one board to another, because each board will have its own 4 data lines, because each board has 4 MIDI channels. That's basically it. I'm now trying to drag OBS from one screen to another screen, and my computer is almost completely dead at this point. Hi Linux Dev, welcome, if I may shorten your name like that. A weird cheesy cat girl looking at circuits. Thank you. I actually am finishing right now, because just right now, just like, oh, my hands got stuck again. What is it seeing? Is it my scope? Does it think my scope is a hand? It's out of scope. No, that wasn't even a good joke, I'm sorry. Yeah, just right now I got the thing working, so I'm gonna end it now, because look, it's 3:30 AM, that's crazy! Windows Management Instrumentation was throwing a fit for you tonight too. Bring your 5950X, I'm not sure what that is. I mean, a CPU, an AMD CPU I guess, but I don't have a good reference. To 100% usage and hanging the dual GPU graphics drivers. What the... I'm glad you've recovered. Thank you for the follow as well. Thanks to the random sub, Mokatech. I don't think Mok is here right now, but she's off. What the hell? My noise gate's way too aggressive. She's often here is what I said before I disappeared into the... Oh, wait, I didn't disappear then, that got quiet. Oh, it wasn't the noise gate that made me disappear. Maybe my computer really is struggling more than I thought if audio is cutting off. Alright, I'm gonna have to find someone to pass you on to, but yes, thank you for all this as well. It feels really weird shortening your name to an operating system. Alright, I want to pass you on to somebody. Oh. Meisaka has just started streaming minus 11 seconds ago, according to Twitch. Look at this. -5, -4, -3, -2, -1, 0. There we are. I could see into the future, and I could see Meisaka was about to start streaming. And yeah, she's just started. So I think I'm going to pass you on to...
Yes.
I think I'm going to pass you on to Meisaka right now, who's another dev VTuber. I'm not sure what she's going to be doing, but as you can see, software and game dev it is. Thank you for the hydration and posture check one last time, Stu. Why the cheese goop? Hi goop, bye goop, I'm ending now. I don't know why I got a gift sub. I follow. Oh, nice! Nice. Oh, Meisaka? Well, Mokatech, I wonder. Either way. I think Meisaka's one of the most recent dev VTuber discoveries, or dev VTubers that I discovered. But yeah, I'm a little bit honored to be in the same space as her now, because I feel like she does vastly complicated stuff compared to me. Having just said that, I did just do assembly for the first time. And I can't believe the code actually worked first time. I mean, once it compiled, it took a while to compile, but we don't talk about that. Shh. It technically worked first time, right? Alright. I'm gonna pass you on to Meisaka now. We'll see what she's doing. Thank you all so much for hanging out. Glad we had like a really satisfying ending as well. And well, this opens the door to future streams where I'm gonna be keeping on redesigning the LED display for the MIDI LED board. So yeah, and it's going to be simpler, much simpler. I'm very tempted to order some WS2811 chips, just the chip. Hold on. Wait, let me try again, my voice is dying. Oh god, that was terrible. That was fucking awful. Okay, never mind, I'm sorry, that was... My voice is dying. Okay, I'm ending the stream. Cut! Stop it! End it! What was I saying? I don't remember what I was saying. Oh, I'll hit
Bye, B.
Bye, Jockibber. Here's where we're going. This is not what her avatar looks like, but this is what it's set to currently, so I'm gonna give pants. Oh god, that's not working. There we are. Pat. Not enough impulse. Life for 0002. Look at the snazzy new software and game dev section. Apparently software and game dev is HTML. Or XML, whatever was in the background of that. Yeah, I'm gonna do more streams where I'm designing that board. I'm very tempted to buy... Oh yeah, that's what I was saying. I'm very tempted to buy the WS311 chip. Just one, or, you know, whatever the minimum order quantity is from somewhere. Just so I can be like absolutely super double triple sure that the order of the outputs is red, then green, then blue, because I'm, you know, right now the datasheet says one thing and the LED strip in front of my, like in my hands right now says something else. So, you know, thank you for the pants, thanks. And hide deflex as well, and buy deflex. And buy Nint, buy everybody, buy Lexi, buy Linux. Yeah, that's gonna be everything. Buy Stew. And 60PW, Ericsson, everybody flipping, Jockeyber, I'm scrolling, okay, I think I've covered everyone. Oh no, 1186 was up there as well. Okay, I think it's everyone. Alright. Bye. Thank you for being here, I'm gone. Let's all say hi to Ritaka. Use the roll emote if you haven't, I guess. Alright, I'm gone, bye.